All right, well, welcome. My name is Eric Dishman. I'm the General Manager of Health and Life Sciences at Intel. Happy to host everybody here in Santa Clara, the Robert Noyce building, the headquarters for Intel Worldwide. I was hoping you would all bring your bunny suits and we could just pop over to the fab and you can stroll around and actually see what it's really like to work at Intel. I've actually never been in the fabs. They won't let me in there. They know that I would cause some problems there. So if you think about what's happening in some of the fabs right around us, we're actually working on the next generation of microprocessors so small they'll go into flexible electronics that we can wear all the time, all the way up to the high-performance computing systems that today's precision medicine analytics are already taxing. And as we think about the scale of precision medicine going forward, the compute challenges from the wearables all the way to the back end are just enormous. I just thought I'd share a quick story by way of introduction. It was about 13 years ago, my Intel team, we had been studying the needs of people with Alzheimer's. And we were able to find from Korea the very first, well, sort of smartphone that actually had GPS in it. And we had built some sensors that went into the homes of people. Our goal was to really help people with Alzheimer's to maintain independence doing activities of daily living. So we had little sensors that we put up that could help track activities of daily living, coach somebody, this woman I remember from the fieldwork in particular named Barbara, struggling just to try to make tea for us when we had arrived. So our system was trying to use intelligence and sensors to be able to help her make tea on her own and maintain some independence, while at the same time collecting a whole wide range of data sets. And this was almost impossible 12 years ago. It was very expensive. Wearable technologies had not taken off. And we were faced, as we did this, with an enormous challenge because we had all these data streams and we were like, well, one goal was to sort of use these data streams to help people maintain quality of life, and the other was to have insights into things we had never understood before about the emergence of cognitive decline. And it was hard to know with all of that data, personal data, wearable data, in-home data, what was going to be medically meaningful. Well, fast forward 13 years, I had my team, some of them are here today, check. We have a particular cardiovascular wearable pilot that we're doing with about 500 people right now. And I said, hey, how's it going? And they checked the servers last night, and we're pulling in about 1.5 to 2.5 million data elements tonight for just 500 people. And the compute power that we needed 13 years ago was all pretty much in a wearable and a few placed sensors around the environment. But the same question remains. That data, while powerful and giving people insights into their own lives, can it give researchers and medical experts and clinicians insights, and we turn it from insight to knowledge to actually do something with? How do we make meaningful use of personal and mobile technologies? And I think that's going to be a key theme today. So I'll shut up and just do the next step of welcoming Dr. Francis Collins. Dr. Collins needs no introduction. He's been our fearless champion for the President's Call Out for the Precision Medicine Initiative, and it's a great honor to have all of you here for the work group today, and especially to welcome Dr. Collins.
Thank you, Eric, and good morning to all of you. Let me add my welcome to everybody who is here, some local and some who've traveled considerable distances. I really want to thank Eric and his team here for helping us organize this and hosting this in such a nice place and in such a good environment for the conversation we're going to have. And particularly want to mention thanks to April Hanks, who's Eric's assistant, who I know has done a lot to make this all happen. I should also thank our working group co-chairs who have been pretty much putting their lives on hold for the last 4 months or so. That being, of course, Rick and Bray and Kathy, and all of you on the working group who have pretty much also agreed to take this as a high priority in the midst of everything else that you might have been planning to do this summer. But I think we're on a really good path here to deliver what's expected, which is by September, a plan for what this cohort is really going to look like. And these workshops have been critical for getting the kind of input we needed in order to get there. Kathy will come up in a minute and sort of lay out the context of how we have gotten to this point in terms of what the Precision Medicine Initiative aims to do and what we've accomplished so far. I particularly want to thank, though, for today's conversation and tomorrow about mobile technologies from NIH, Bill Riley, Roderick Pettigrew, Alan Guttmacher, who have helped us at our side of this to try to put together the program. I will tell you that I'm really excited about being here because this has been a personal interest for me for several years, the idea of using mHealth to advance the cause of how do you maintain health and how do you manage chronic illness. I have been geeking out about this for long enough to be pretty jazzed about what we're going to hear today. I was a volunteer once upon a time in a LiveCore's test of their EKG transmission capabilities, which was kind of fun to see what happened. And certainly have spoken repeatedly at the mHealth conferences, which have turned into big gatherings every year in the D.C. area. And yet it's also clear from tracking how this is going on that there are lots and lots of really exciting gadgets. I'm sure many of you are wearing them. I have at least 2 on my wrist at the moment. But the questions that remain largely unanswered, at least in my perspective, are exactly how we can implement these technologies in a way that you can actually prove outcomes are benefited, and that it's not just a lot of cool technologies and gadgets, but we're actually able to generate evidence about how this changes health behaviors, improves outcomes and management of chronic disease, and so on. And it seems to me that this precision medicine cohort of 1 million or more people, I'm still sticking to that or more because I hope it's more, will provide the kind of real-world laboratory to enable a great deal of information to be gathered about which of these various approaches actually do turn out to be useful in terms of improving health outcomes. There's a lot, of course, of possibilities here. We all know there are 7 billion cell phone subscriptions worldwide now, and gathering all kinds of data that should be potentially relevant to health. And we've seen applications in many different situations that seem to be showing some real benefits: Parkinson's disease, post-heart attack, smoking cessation, clinical trial monitoring. And NIH is certainly investing in various research projects to look at mHealth technologies in obesity and diabetes and substance abuse, heart disease, psychiatric illness, depression, many others. And so evaluation is getting there. But still, I would love to see that trajectory sped up, and that's what I'm hoping we could imagine here in the next day and a half might be possible with the way in which the technologies are delivering so much potential and the opportunity in a situation like the PMI to be able to test those out and see what they could really accomplish. So I guess my hope and my charge to the group is that we roll up our sleeves here. We listen to some fantastic presentations. We have discussions on the panel that are supposed to be highly interactive, and we've organized the agenda in that fashion. So this is not the sort of meeting where you just come and do your email. This is a meeting where we hope there's going to be lots and lots of interaction amongst all of you who have turned up in the panels that have been carefully chosen. And this will all feed into this effort, which the working group has been charged with, to deliver a plan in September that can be put forward to the advisory committee, to the NIH director, and if then accepted, put into place. I can tell you we did have a meeting about the cohort study with the President of the United States just a couple of weeks ago, and he is intensely interested in what's happening here and intensely supportive of the goals, and wants to be kept apprised of all the details that are emerging as part of this. You can't ask for a more connected kind of leader of the free world in terms of what this particular effort is turning out to represent, and that's really quite gratifying indeed to see that kind of leadership. I'm happy to also say that I think in the U.S., the support for this in the Congress of the United States is also broad and strong and completely bipartisan. So we have a lot of support. We just have to make the most of it here and turn this into a program that is truly going to change the world, and that's our goal. So without further ado, to set the context a little bit more clearly, I'm going to invite Kathy Hudson, the Deputy Director for Science Outreach and Policy at NIH and co-chair of this working group, who is fresh back from a whole week riding her bicycle across the entire state of Iowa, to tell you a bit more about context. And again, many thanks to Kathy, who's put a huge amount of time and effort into getting us to this point. Dr. Hudson.
So good morning, everybody. It's really exciting to be here at our final Precision Medicine Working Group meeting. And we have a significant challenge ahead in the next several weeks to put together this report for the advisory committee to the director. But I wanted to make sure, since for some people this is your first workshop of the Precision Medicine Initiative, I want to make sure that we're all sort of on the same page here as we get started. So the challenges that the Precision Medicine Initiative is intended to address are multifold. First, We all know that too often either we or our family members or somebody that we love end up in a situation where they are ill and there is either no diagnosis or no options for treatment, and we end up at the end of a road without a happy outcome. Oftentimes, the options that are available fail to address the individual's genetics, behavior, background, environmental exposures, and the like. Also, research can sometimes be too slow to be able to address many of these problems, too expensive, underpowered, and again, don't really address real-world situations. So we see people intermittently in clinical trials or in other research studies, and being able to track people over an extended period of time in their real sort of free-range environments offers tremendous power. One of the key values that has really undergirded all of the planning efforts for the Precision Medicine Initiative is having a new relationship with the participants within the initiative, so that they are not research subjects, they're not patients, but rather they are our partners and active participants in all aspects of the Precision Medicine Initiative. And then finally, an additional motivation really for the Precision Medicine Initiative is that too often it takes too long for new knowledge to be translated into clinical practice where it can actually benefit individuals and families. There we go. So the President of the United States in the State of the Union in January of this year launched the Precision Medicine Initiative, and I'm hoping if I click something, this video will start. And this is when he announced the beginning of the initiative. And if
I'm launching a new precision medicine initiative to bring us closer to curing diseases like cancer and diabetes, and to give all of us access to the personalized information we need to keep ourselves and our families healthy. We can do this.
So what you'll notice there is that everybody in the chamber, both Republicans and the Democrats, all rise up in support of this Precision Medicine Initiative, which nobody actually knew what was and which we have been trying to define. Interestingly, in this age of electronic monitoring, there was polling going on during the State of the Union, and it was that sentence that was the single sentence that was most favorably received by people who were watching the State of the Union address. So there's enthusiasm out there, maybe for the word precision, maybe for the word medicine, or maybe for what is very clear, the President's own enthusiasm about this initiative. So the time is right for us to launch this project. I don't know why that's still there. Shouldn't have been there. So the time is right for this initiative because of advances in all sorts of technologies that make this feasible, both from a cost perspective, but also from a technological perspective. So some statistics there about the cost of sequencing, about the increased utilization of smartphones, about EMR adoption, and other kinds of electronic health information also skyrocketing. So this is the time to be able to harness all of these technologies together for the initiative. So the vision for the Precision Medicine Initiative is to build a broad research program to encourage creative approaches to precision medicine, to test them rigorously, and ultimately to build the evidence base needed to guide clinical practice. And there are two research components of the Precision Medicine Initiative, one in oncology, which we're not going to talk about today, and one, this national research cohort of 1 million or more Americans, which Francis mentioned, which is really the purpose of this workshop and the ones that preceded it. So the goal of the research cohort is to enroll 1 million or more U.S. volunteers, and we have sort of at the ready numerous existing cohorts that we could utilize to help build this new cohort. We also want to make sure that we're reaching out to underrepresented and underserved communities to make sure that they have an opportunity to participate. And we also want to be able to enable anyone in America to be able to say, I want to contribute my information in order to advance science and advance this precision medicine initiative. So we need to be able to have multiple routes of being able to invite people to participate in this cohort. As I mentioned, participants are going to be centrally involved in the design, implementation, and governance, and be able to share their genomic information, behavioral information, biological samples, and electronic and other digital health information. We want to make sure that all participants are voluntarily and actively and enthusiastically participating in this study and making choices about how they participate in this study and what information they receive back, and I'll talk a little bit more about that. This study will be a new model for an engaged partnership with our participants, and also with open, responsible data sharing. Not only data sharing within the scientific community, but also data sharing with the participants themselves. So the cohort has a number of possible uses, which are listed here, including being able to provide data to subclassify disease, to be able to test existing pharmacogenetic variants in a broader array of populations, and looking and seeing how those variants that indicate either adverse reactions or responsiveness to medications, how that works on a population scale, and being able to identify new pharmacogenetic variants that would influence decision-making about what kinds of medicines individuals take. There's a number of other examples here of possible uses for the research cohort, and it's going to be important for us as we build this cohort to have very clearly in mind some research questions that can be answered in the near term and the longer term, so that we can define very specifically the data elements that we need to collect. So in launching this study, we know already that there is strong support in the Congress, as Francis mentioned, extraordinary enthusiasm in the White House with the President of the United States, and also strong support in average Americans. We managed to do a survey earlier this summer of 2,601 folks, asking them how they would feel about the creation of a national research cohort like this. There was very strong support of the idea about creating a cohort, 79% saying that this should be built. There was very little variation across racial and ethnic groups in terms of that strong high level of support. And when asked would they participate in such a study, after having that described and defined for them, more than half said that they would indeed participate in such a study, with consistently majority support and interest in participating across all groups, although higher, interestingly, among Hispanics, increased interest in participating with higher educational levels, and lower support with increasing age. And that's something that we're going to have to be mindful of to make sure that we get everyone involved and engaged in the cohort. So as Francis mentioned, after the President's State of the Union mention and then another event at the White House about 10 days later, he put together this working group, which I've had the pleasure and honor of co-chairing with Rick and Bray over the last many months. The charge of our group is to design the plan, lay out the blueprint for the precision medicine research cohort. And to do that, we have sought broadly to get input from experts and people with special expertise and experiences that we can draw upon to help build this cohort. And part of that outreach effort has included workshops such as these. And so we had 3 previous workshops, one on what would be the unique scientific opportunities that we could explore with the cohort, one on digital data and how would we build the data architecture for the PMI cohort, one on participant engagement and health equity, basically talking about how do we get people engaged in the cohort and maintain that engagement over long periods of time, making sure that we have a very inclusive research population. So that brings us to today and today's workshop. And after today's workshop, we will be very busily working on our report that we will deliver to the Advisory Committee of the Director in mid-September for their consideration, and then on to Dr. Collins for his final decision. We have had a great partnership between the working group and staff and leaders at the NIH, so that all of the NIH leadership has been paying very close attention to the deliberations in these workshops and to the working group, so that we're ready when the report is delivered to us to be able to translate that into funding opportunities and initiatives that will launch this cohort very quickly. The members of the working group are all seated up here in the front couple of tables, and they are all listed here. It is an extraordinarily diverse working group in terms of areas of expertise and perspective that have been brought to bear. It has been a tremendously productive and engaging group to work with. So up until this point, we have given a lot of attention to making sure that the cohort is inclusive, but not necessarily statistically representative of the U.S. population, and that's an important point. It's important both for how we go about recruiting and sort of the general sampling strategy that we will undertake. We want to see where possible that we can leverage existing cohorts. We want to make sure that we include the underrepresented and the underserved, possibly by working through federally qualified health centers. And that's a tremendously exciting opportunity, with the majority of folks receiving care in federally qualified health centers being at or under the poverty line. We want to be able to include people of all ages, from the youngest to the oldest, and we want to make sure that we enable participation from active duty and retired veterans. And we've been working very closely with our colleagues from the Veterans Administration, who have the Million Veterans program already underway. We're learning from their experiences and hope to be able to combine these efforts, and also with our colleagues at the Department of Defense. Of course, we will obtain consent repeatedly throughout the life of the cohort for participants, because as we move forward, we'll adopt new technologies and adopt new research questions, and we will want all participants to be engaged in that. So we've talked also about, oops, I skipped forward, that's all right. We've also talked about data and data management, and balancing the need to broadly share information, but also be able to secure people's privacy and make sure that information about individual participants is not used in ways that is harmful or hurtful to them. And we have worked very hard on the question of what information is returned to participants. Certainly participants are interested, or at least some participants will be interested in knowing what research is done with the cohort and what was learned from that and how was it utilized. And certainly that's one category of information. There's also information about individual participants that we have heard through our survey and through other means that people would be interested in getting back. And so we need to figure out how to do that in a responsible and appropriate way. So we have a number of challenges in all of those areas. And today's workshop is really focused on how we can utilize mobile health technologies in the cohort in order to collect new kinds of data in new and different ways. So we want to explore during this workshop the benefits and barriers of using mobile technologies in the cohort. We want to talk about what would be the ideal desired functionality of such technologies. We want to talk about both the technical challenges but also the social challenges in utilizing these mobile health devices. And then we want to talk about specific examples where we could employ technologies within the cohort and really test their capabilities. So that's the broad goal for our workshop today, is to explore these technologies and how we can utilize them potentially within the cohort. I'm particularly excited about this workshop. This is not an area I have much past exposure and experience with, so I'm really looking forward to learning from all of the wonderful panelists and speakers that we have lined up today. A couple of housekeeping issues before I introduce our first speaker. So this workshop, like all of the workshops that we have held for the Precision Medicine Initiative, is available on webcast, so you can watch this. Greetings to all the people who are watching us over the webcast now. Also, Please, if you tweet, please join us we are using hashtag PMI Network, so please join us on Twitter to have conversations within the room and with our fellow friends who are watching on the web. I sort of feel like tweeting in meetings is a little bit like passing notes or having a separate conversation. It's quite entertaining. So with that, I will introduce our first speaker, Jessica Mega. Dr. Mega is the head of clinical science and the baseline study at Google Life Sciences. As a faculty member at Harvard Medical School and a senior investigator with the TIMI study group and a cardiologist at Brigham and Women's Hospital, Dr. Mega led large international randomized trials evaluating novel cardiovascular therapies. She also directed the TIMI study group's genetics program. She is widely published and has received many, many awards for her work. And we are pleased to have her here with us today to talk about mobile and related technologies and their potential for advancing precision medicine. Thank you very much.
Well, thank you all for the invitation to be here. And without sounding too hokey, I am also happy to stand up in support of the Precision Medicine Initiative. So what I want to do today is to reflect at a very high level on mobile and related technologies and their potential for advancing the mission that we have today. Speaking of technologies, I'm not sure the clicker is working, but I'm happy to just say next slide. So what do we mean by mobile? And that's what I want to spend the next few minutes on. So if we think about mobile, it's an adjective. And if you look at the definition, it means of or relating to cellular phones, handheld computers, and similar technologies. And this is not news to this audience that the original cell phone came out in 1973. It was 9 inches by 5 inches. You could talk for about 30 minutes, and it charged for 10 hours. If that was the case, then it wouldn't be very helpful in the discussions that we have today. But this was a major breakthrough at the time. And if we look over the decades, what we can see is devices that are becoming more miniaturized. We have devices that are truly mobile, and the battery life is getting better and better. And it's because of this that we're able to think about new ways to data capture, and I hope there's a very lively discussion on this today. So where are we in 2015? Are these devices the type of devices that people have ready access to? And the short answer is yes. So 90% of Americans own a cell phone. 64% own a smartphone. And if you look at American teens, it's over 70%. And so these numbers are only going to be rising. What types of things can be done? And this is where much of the discussion today is rooted. Through these types of mobile devices, we can gather patient management information, diagnostics, information management, health record maintenance. No longer do patients need to go, or participants need to go to the doctor to get this information. There can be references, medical education, and an understanding of what happens to someone's nutrition and wellness outside of the confines of an office. And the scale and utility of smartphones, in addition to this dramatic shift in healthcare, has catalyzed biosensing wearables. And we heard in the introduction by Francis today that many people are wearing a wearable. I was able to check my heart rate before I gave this talk. We'll see how it goes. I'm starting to feel pretty comfortable. You seem like a nice group. But these are the types of things that we have access to every day. And what you can see along the x-axis here is the many different spaces where these biosensors are infiltrating. Anywhere from movement to heart rate, which I think a lot of us think about, but thinking about oxygen monitoring, muscle function, eye function, indigestion. So this is where we're going. And the other thing is a shift towards these devices just being part of a health and wellness profile to something that can help us manage patients who have more end-stage types of diseases. So devices that are measuring oxygen saturation, devices that are going to be measuring things like galvanic skin response. These are things that are going to be providing signals that will hopefully give us very useful early data to predict before a certain disease state happens. But I want us to pause for a minute and reflect even more broadly. So we talked about mobile as the concept of mobile devices and mobile phones. But if you look at the second definition of mobile, what it means is able to move or be moved freely and easily. So where might we be going with these technologies? Well, one area that illustrates this exceedingly well is to look at diabetes management. There are 382 million people around the world who have diabetes. 79 million adults in the United States have a pre-diabetes state, and patients with diabetes need to check their blood sugar somewhere around 4 times a day. We know that typically this means using a Lancet and deriving this data. We have many of the physicians in the room have patients who come in with nicely curated notebooks, but this is where we are today. But the hope is to take mobile technologies beyond the cell phone and miniaturize them in a way that we can more continuously be getting the information. And this morning, Andy Conrad, who heads Google Life Science, happened to have one of these contact lenses in his pocket. I'll put it right here. And this smart contact lens, it's a monitoring device that hopefully will lead to continuous non-invasive monitoring. And what's really interesting about it, and again, if you take a look, there's a very small sensor. The power device is all internalized. And the chip requirements are starting to get more and more efficient, as we heard in the introduction today. So we have wireless power, we have biocompatible substrates, and there's a fast wireless readout. And this is just the tip of the iceberg. This is just one example of where these types of mobile devices are going. In fact, if you think and shrink down to even smaller level, we talk about nanodiagnostics, so non-invasive methods where someone may be administered nanoparticles. These then circulate within the body. So now we're talking much smaller than this contact lens. We're talking about microscopic particles. And these can detect the nanoparticles, and this can share the information with doctors. And again, the hope would be these kind of mobile, again, using the word very broad now, but that these mobile types of devices may be able to detect circulating tumor cells before a mass is actually detected. But now I want to get even smaller and then pop out to think, what if mobile isn't something that you even need to wear or put on or inject? And is the future of a wearable, not a wearable, but nonetheless aware? And so what do I mean by this concept? Well, we have devices that detect whether we're going to have a fire. There are codes. We have to have these devices. There are environmental detectors now looking at our environment, smart ways of managing your home heating, your home cooling. These types of devices are thinking for us, they're detecting signals, and they're trying to make very smart and active decisions. And now I'm talking in a bit more of a hypothetical space, but again, I think these are the types of sensors that we heard are already being developed. So let's think about arrhythmia management. As you heard, I'm a cardiologist, particularly sensitive to patients who die of sudden cardiac death. But what if there were sensors within your home that detected when your heart went into a ventricular tachyarrhythmia? They then alerted 911 and emergency services could be delivered. So that's one way of thinking about sensors more broadly. Mobile, but not something that you may need to wear. There are also people interested in seizure activity, looking either at the brain activity or looking at motion detection, another area where these non-invasive types of sensors could be considered. Again, hypothetical, but something that people are starting to think about. And then let's take it a step further and think about the environment in which we're embedded. And I know there's a discussion today around trying to measure the environment that we're in. But let's say that you had your personal health data and you went to the hotel. I know many of you stayed locally, so welcome to California. So let's say you went to the hotel, and when you checked in, you also provided your health information, and you said, I want you to know on this chip it shows that I have a peanut allergy. And as it turns out, we know that peanut allergies kill many people every year. I saw on the back there's a table of peanut cookies. So for those of you who are very sensitive, it's being raised right now. Please beware. But let's say you checked into a hotel. We knew you had a peanut allergy. You were able to detect the environment looking for these allergens, and there was a closed feedback loop. And so there was an HVAC system that was able to extract these allergens. This is the way the environment is starting to be mobile and is starting to detect all of these signals. Again, something that we hope to strive for. And if you look at the NIH, a mobile page. I found it really interesting. The information is quite comprehensive, and the hope is quite broad. And the hope is that mobile technologies could, and again, they use the word potential and could, which I think is very appropriate, but this could change when, where, and how healthcare is provided. It can ensure that important social, behavioral, and environmental data are used to understand the determinants of health. And I think really important, something that Kathy mentioned this morning, the hope is to truly improve health outcomes, not to just gather a lot of information, which is kind of fun, but it's to really do something different for participants and for patients. And so what is the onus on us? What are we going to need to consider? Well, there's going to be an exponential expansion of data, and everyone in the room knows this. You've had working groups talking about the genomic and molecular markers, talking about the organ itself, and then the exposure. I know there are groups working on environmental exposures. But we're going to have to be very careful with this data and be very thoughtful. So we know that there's certain known signals. I showed you the example of ventricular tachyarrhythmias here on the top of the slide. We know that atrial fibrillation exists. There are devices that can help detect atrial fibrillation. If a patient has this condition, we can use antithrombotic agents very early and prevent strokes. So here, these, I would argue, are known signals. They're great to go after. They're actionable. There's something that we can do about it. But there's also going to be a lot of unknown signals. And how do we thoughtfully think about these signals that may have a more circuitous path, but may really hold the true gem that we're looking for? And I think that's where initiatives like the Precision Medicine Initiative come into play. Because you're hearing these concepts of having over 1 million patients and participants that are engaged in providing all of these human signals, and then people like you in the room and people across the country who are going to be looking at this data can help tease out what is a true signal and what is actionable. At Google Life Science, we've been engaging in work around the baseline study. We've started a pilot that's been publicly announced. Here we're doing a deep dive into these human signals, and we really hope that this type of initiative is very complementary and can work together with the Precision Medicine Initiative. And these are just two of many different initiatives that are ongoing, but I think there's a real opportunity for all of us to work together to tease out these signals. Because we're going to be integrating data, processing huge amounts of data, and then exploring data in new and different ways. And we're very fortunate that nowadays we have new machine learning algorithms that are constantly evolving. But the hope is to try to, again, tease out what we should be doing, not just because it's fun to collect, but because we think it's going to make a difference. And as I think about it, and as I move towards the conclusion, I like to think about what tools do we have to understand the population and precision medicine. And I know a lot of times if you focus on precision medicine, people frequently think it's pitted against population medicine. But I actually think the two of them are intertwined. So if we think about all the new expanded data capture sources, and again, many of these capture the working groups that you have, and this is on the left-hand side of the slide. And then you think about all the expanded data sources, and this is where PMI fits in. And in fact, one could argue that we're going to start to be able to study the entire world. Within the mobile health technologies, there's a real interest in international work. In fact, many people predict that that's where the biggest impact is going to be, targeting patients of lower income where access has been different. So there's a real global opportunity here. But as we take this data, not only do we need to think about known and unknown signals, but I think we have to go back to the fundamentals of what it means to be an epidemiologist and looking at non-randomized exposures, trying to get these signals to see if there's a correlation. But I hope we push further and also look for causation and start to embed randomized trials, because then we will be able to truly know whether there's a link. So just because someone wears one of these smartwatches and their health is better, is it that? Or is there something truly causative about having this closed feedback loop? And I really hope that we continue to strive for these very basic research principles. And I think if we do this right, then we truly will optimize population management, but get to the heart of what you all are doing here today, and to really expand precision medicine. So I thank you for your attention and look forward to a really great day and a discussion that will continue on this. Thanks so much.
Good morning. My name is Josh Denny. I'm one of the working group members. I'm here to introduce Section 1. First, thank you so much, Jessica, for that great opening kickoff talk. If I could have the members, I think, of the session go ahead and come forward. I believe you actually all have talks. The first talk will be by Dr. Rhoda Au, who's a neurology professor at Boston University and the senior investigator director of neuropsychology at the Framingham Heart Study. She is going to be giving some of her discussion. Do you want to speak from here? You do? Yeah. And I think I'm not going to go through long introductions on each of the candidates or each of our speakers today. They all have extensive experience with mobile technologies applied to clinical research studies, and that will give us more time to interact with them through the discussion.
Thank you very much for inviting me to share with you our experience at the Framingham Heart Study. And I'm looking for, there we go. And I think, as many of you know, Framingham started out as a study of heart disease, but has, over its now nearly 68-year history, has expanded to a study of really chronic disease. So we really like to think of it as a study of health moving forward. And I'm hoping that this does not work. I am pushing it. You got it to work. All right. It's not moving forward.
Can someone advance it from the back? Can someone from the back advance too?
All right. I'm still not getting it. There we go. There we go. So what I wanted to start with is to tell you what Framingham is doing right now in terms of its integration of technology. And to start with sort of where we are in the wearables is we actually are doing an in-home sleep study where we mail the devices to our participants, and they wear it for 2 days and then they mail it back. And here are the two instruments. We have them wearing an ECG monitor as well as an oximeter. And just to give you an idea of the kind of data we're collecting traditional sort of what you would expect from a sleep study, both in terms of breathing, and then also because of the new technology, it's allowing us to look at novel analytics related to quality of sleep. I'm a neuropsychologist, so I'm very interested in the assessment of cognition and really thinking about how technology can really advance this. This is not necessarily in the stage of wearables, but I think it's in the first step in moving us into a digital era. So in 2011, we started using the digital pen at Framingham. This is a clock drawing test. Could someone please play this video? And so what we've done is we basically have substituted a regular pen with a digital pen, and I'm waiting for you to play this. Can you? There we go. Okay, you're playing it toward the end, but in any case, what this pen does is it really gives us now a window into the brain as the person is conducting the test, and this really gets us at a level of precision that we haven't had before. And but I wanted to move beyond sort of tests in which participants use a written response, and we have now, in collaboration with my colleagues at Tsinghua University and Peking Union Medical College Hospital, both in Beijing, have moved toward creating a platform for all our neuropsychological tests rather than just any single one. So if you could play this video as well, please. And in this case, we're taking sort of an incremental step where, from the standpoint of the participant, it continues to look the way they've always done the test, but we're now digitizing it. And so if we could play that. And I think that the end goal here is to eventually get to the point where we will be able to do cognitive assessment remotely, but this is sort of the first step, and I guess the video isn't working. All right. Okay. One of the things I like to remind you about Framingham is that our value of Framingham is in the data we've already collected. As I mentioned, we have nearly a 68-year history. And so one of the things in thinking about how do we integrate technology into our study is how do we also at the same time link it to what we already have. So we've already had a little bit of discussion about the importance of big data analytics, and we have a partnership now with Thomson Reuters. Sort of one of our first steps is to start harmonizing data across different cohort studies. So in this case, we're looking at Framingham as well as the ERIC study, looking to how we can harmonize our data, fuse it not only with structured data, but what's called unstructured data, using Thomson Reuters proprietary tools, and really to identify sort of where are some of these new relationships that our traditional analytics currently don't allow. In addition, with Thomson Reuters and with Biogen, we have formed a partnership to look at multiple pathways to treatment for Alzheimer's disease. I recently put out a paper where I suggested that one of the issues with Alzheimer's disease is that we keep thinking about it as one disease, and when in fact it's really multiple diseases. And we really look to big data analytics in order for us to determine what are those different treatment potential pathways for Alzheimer's disease. Now, one of the things I like to remind people, particularly when I'm working with the technology community, is the greatest consumers of healthcare are really the elderly population, okay? And today, there's really an overwhelming amount of technology that's out there. And the other thing that I also like to mention, and if we could play this video, is that the lowest consumers of new technologies are actually our elderly. And so is this going to play? And so we can build the devices. The question is whether they're going to use them. And so in this video that isn't playing quite correctly, it's really, someone who has been given an iPad and is using it in a different way than it was intended. So where is Framingham today in terms of really moving forward toward an e-platform for research? And what we did was a survey of all our surviving members from our Generation 2 and Generation 3 cohorts. And of that, 78% actually responded to the survey. Now, our participants are very active, and they like to give us a lot of feedback whenever we're doing anything. So they also took it upon themselves to give us some comments and to let us know that as a whole, they like the idea that we're moving sort of into a new era. But we also get comments that suggest some are a little bit concerned about this new direction. Now, among our respondents, we tried different methods in terms of getting feedback from them. We used REDCap, but we used it as an online version rather than a mobile version. We also need to follow up with some in terms of phone and mail. Among those who did respond, it turns out that 91% actually had a cell phone, which was good news, but 67% had a smartphone. And not surprisingly, the ones who had the smartphones tended to be our younger participants. I think the average age was around 55, as opposed to the ones who didn't have a smartphone, and that average age was closer to 70s. But among those who did have a smartphone, many of them had an iPhone. So with these results in mind, my colleagues on the heart side decided to launch a pilot study. And they started out with 200 participants. The inclusion criteria is that they had to have an email address and they had to have a smartphone. And it's a 3-month observational study. They're actually given the option of 5 different devices. And our initial results suggest that, not surprisingly, when we try different recruitment methods, bringing people in to the clinic, showing them how to use the device, led to greater usage of the device, both in terms of selecting more devices to use and then the actual data that we've gotten. But what I think is of importance is that 50% of our participants who are enrolled in the pilot to date are over the age of 65, and that's, I think, very promising. But I think that, one of the things I always worry about at Framingham is less what we are doing and more about what we're not doing. And as we're thinking about sort of these e-health initiatives, one of my concerns is, the fact that we can't have people wearing multiple devices. So that's one issue. And then the other one is because I'm on the cognitive aging side, so I deal with more of the elderly population, I also worry a lot about that user interface. And then, Framingham, sort of as I've mentioned, is really tied to our past, and so I'm looking also to what kinds of relationships need to be formed to move things forward faster than I might be able to do within Framingham. So around that, I have a partnership now with Shimmer. Shimmer is an Irish-based company, and what I like about their particular wearable is that it's customizable. It can be customized for a number of different metrics, and the other important thing that I think has already been mentioned is the need that it be open source, because we need to probably establish new gold standards as we move into digital technologies. And then in addition, as I mentioned, I'm concerned about that user interface. I worry a lot about participants, particularly older participants, having to interact directly, input things into a device. I worry about the iWatch. My elderly can't even see it. And so if you could play this video, this is actually an avatar that interacts with the participant. It's obviously scalable because it's electronic. It's been piloted in Boston, and it's currently being piloted in China. So this gives you an idea. And one of the things that we're hoping to do right now in collaboration with some Hong Kong colleagues, they have a research technology center there, we're really now looking to integrate. We want to integrate mobile with smart home devices, feed it into this, what I would call this better user interface for my elderly, so that they can really use it in the home. And then in addition, we actually are launching a new longitudinal cohort study in China, likely the beginning of next year. And in this case, we're really integrating new technology as part of our new data collection process right up front. And this is really a study of chronic disease, so it's independent. If we collect the right data right up front, it's really independent of what your health outcome of interest is. And then finally, I've been very concerned about sort of the issues of measuring diet. Right now, we have a number of instruments that are out there. I think that the goal here is that we really need to find a way to look at nutritional biomarkers using a portable device similar to how we do with glucose. And it turns out, I've learned now in the past year, that if you tell the technology company that this is what I want, sooner or later, someone's going to produce it for you. So I'm in discussion with 2 companies that have created nutritional devices that measured nutritional biomarkers, and we're looking to start piloting those within the coming months. Although I come from Framingham and Boston University, I think what's very important as I've moved into this arena is that we can't take a siloed approach. And so consequently, we've built a network of collaborators, both within the US and outside, particularly with China, to help us move this forward. And I thank you for your attention.
Thank you very much for that discussion of the work with Framingham and as it extends beyond. Next up is Greg Armstrong, who is an associate member at St. Jude's Children's Research Hospital and also University of Tennessee at Memphis. And he's going to talk about some of his work with children's survival and the children's cancer survival study.
Well, good morning. My name is Greg Armstrong, and I am from St. Jude Children's Hospital in Memphis, Tennessee, and I'm the principal investigator of the Childhood Cancer Survivor Study. By way of background, the curing of childhood cancer really is one of the wonders of modern medicine. If you go back to the 1960s, less than 20 to 30% of children would survive their cancer. Now over 83% will survive. This means that we've created a new population that did not exist 50 years ago. Adult survivors of childhood cancer, and that is who we study and who we follow and who we intervene on. Looking forward, by 2020, there will be 500,000 survivors of childhood cancer in our population, all of whom remain at increased risk for certain late effects, largely driven by exposure to chemotherapy and radiation during their childhood. So the Childhood Cancer Survivor Study was funded in 1994 as a retrospective cohort for children diagnosed between 1970 in 1999, so that's over 3 decades of time, from 31 contributing centers, major children's hospitals in the United States. And to be eligible, they had to be 5-year survivors of their cancer, so 5 and alive. All major childhood cancers with a detailed information on their treatment, so dose-specific, organ-specific dosimetry for radiation and dose-specific chemotherapy exposure information. And then a wide range of outcomes that we're following as we follow them across their lifetime. There were over 35,000 eligible for this cohort, 24,000 participating, currently over 20,000 active participants. I show you this map to show you that our population is spread widely across the United States. This is not a population that will ever come in for a one-time health evaluation at a clinic in a uniform way. Rather, this is a population that we communicate with through some very old mechanisms. I call them our original 3 dimensions of communication and survey completion. These are patient-reported outcomes, and so participants have the options of completing a paper survey sent by U.S. mail. If they don't, we have a large telephone team who calls and follows up, and they can complete a survey by phone. And since 2007, we've added web-based completion. So we've moved into the more modern generation. But in the last year or two, we've really asked some hard questions. What is the potential to now engage using mobile and tablet-based communication? And really the interesting question, what about direct assessment using sensor-based evaluation? And this is what, as I've explained to our executive committee, what I call the 4th dimension of communication for our study, moving beyond our original 3 dimensions. And in one slide, I want to paint for you the vision that I've put forward to the executive committee for this mobile-based communication. It's push, pull, and monitor, intervene. Push information to our participants, pull information back, and then ultimately monitor and intervene. So think of what we could do with cancer survivors as far as pushing information. We could become a resource for survivors. We can provide for them latest news from our study as well as around the world, health information, related types of updates. Importantly, we contain the treatment information for all of these survivors. Many of them were treated at a very young age. Perhaps they were 3 when they had leukemia and have no idea what they were exposed to. We have that treatment information and can provide them back to them as a resource. We can provide reminders to complete surveys or even invite participants to additional studies through mobile-based communication. But then pulling back information is incredibly important for us as a study, as you can imagine. We could get updates on key health outcomes. Currently, we collect second cancer information, our most vital outcome, every 3 years on a paper survey. That means a survivor could have a breast cancer and die from breast cancer before we get around to the next paper survey, and that shouldn't be. With mobile-based communication, we could get a real-time update on a new malignancy among our survivors and then validate that malignancy in real time. We could allow them to complete surveys now on their phone while they're transporting by train or by rail or by bus to work, rather than having to sit down with a paper survey. And all of this, we felt like we could do well through app-based communication. And I draw a red line here because I think all of this are things we should have been doing a year or 2 ago. And so we are rapidly catching up now by adding app-based communication in our cohort. But it's what's below the red line that I think is what's critically important, and that's the ability to monitor and intervene on a remote cohort that we've previously only been engaging by paper. So you could imagine that through mobile technology, we could connect a sub-cohort of our survivors and monitor their health outcomes directly. So instead of asking them, how is your activity, what is your activity by paper, we can directly measure their activity. Or we could directly measure their blood pressure instead of asking them, have you been told by a doctor that you have hypertension? And obviously that's where we're moving. We have a current study, the ASK study, funded as an R01 by the National Cancer Institute, Advancing Survivors' Knowledge of Skin Cancer, where in a randomized trial we provide, in the 3rd arm of this study, a dermoscopic lens for their cell phone. Survivors are at greater risk for melanoma, those who have been exposed to radiation, and perhaps by providing this dermoscopic lens and giving them the opportunity to connect to a dermatologist directly through their mobile phone will increase the rate of screening, both self-exam and physician-based exam. So the opportunity to monitor and intervene. Ultimately, one day I'd like to see that we have a completely connected survivor cohort. So how are we going to do this, and how have we done this? Well, very simply. For our app-based communication, we decided to connect and work with one of the largest app-based vendors, Salesforce. And we wanted to do this because primarily we needed to operate within a HIPAA-compliant atmosphere and assure security of this health information for our survivors. And Salesforce has been doing that in a number of venues, and so we've moved quickly to build an app in a HIPAA-compliant space. But below the line, when it comes to monitoring and intervening, we were very quick to realize that we cannot catch up as a study, as the CCSS, in understanding where technology is. So we've been very quick to say we can't do that unless we join forces with someone who's already doing it well, and that is the Healthy Heart Study. So I'll tell you about both of these. In one slide, here's the app that we are in the final phases of development now and will deploy later this summer or early in the fall. It is labeled the Long-Term Follow-Up Study app, not the CCSS app, and that's just a historical nomenclature. Our survivors know us as a long-term follow-up study. But you can see, even from the entry portal into this app, you have to have a specific username and password that we provide our participants. So this is their space only for their secure health information. We provide latest news right on the home page, and then a menu board, which you can see gives them a resource hub to key resources that survivors need, a space for their treatment where they can actually see the treatment that they were exposed to and push a button and email that treatment information to their personal physician, and so on and so forth. So this is our app-based communication. But again, it's below the red line that I want to spend the last few minutes talking about, because I think this is what's important for our survivors going forward. Now, we currently ask them, how active are you? But what if we could do a 6-minute walk on every survivor, no matter where they are, what location across the country? So in collaboration with the Healthy Heart Study, we're moving forward with co-enrollment of our survivors into the Healthy Heart Study to have full opportunity for engagement of mobile applications, such as a 6-minute walk platform or a photo diary diet platform. Instead of doing a food frequency questionnaire, which is a laborious thing to do on paper, now through a more modern diet capture of the photo diary, we can directly capture the food and label the food along with calorie content. So these are the types of opportunities. So here's how we're developing our collaboration with the Healthy Heart Study. Their mission is to support multi-component research projects such as ours and to maximize our ability to use mHealth technology. And so what we're putting forward now is co-recruitment of our CCSS participants into the Healthy Heart Study. This is going to provide and is providing us initial data on participant interest. Will our survivors be interested at all in engaging in this technology? And more importantly, if fruitful, develop a sub-cohort for subsequent monitoring-based and interventional studies. So we started a pilot in February of 2015, just 5 months ago. We targeted 500 survivors for co-recruitment into the Healthy Heart Study. And here's what's important, is the ability to collaborate across 2 major studies. Healthy Heart allowed us to tailor their materials and create a tailored web portal specifically for our survivor participants. Our participants are sheltered from most of the Healthy Heart messaging, so we don't want our participants receiving messaging from 2 major cohorts and bombarding them and thus fatiguing them, and so we've been able to shelter them. And then additionally, we've collaborated through our IRBs to share data between our 2 studies. So here are our pilot results to date. We targeted 500 patients to see if they'd be willing to engage. In just 5 months of time, 56% of this population has co-enrolled into the Healthy Heart Study. This is phenomenal. I would have estimated it would take a year's time to get into the 60 to 70% participation window. In 5 months, we're at 56%. And not just that, of those who've consented, 80% have gone on to complete the first e-visit, so the first series of Healthy Heart questionnaires. So they're engaged and moving forward. And notably, on the far right side of the screen, the number of refusals who said, hey, do not ask me about this again, is only 6%. So the summary of our proposal for our study moving forward is that we're going to collaborate with the Healthy Heart Study and add them in our upcoming competitive renewal as a new core facility. We currently have 4 core facilities handling radiation dosimetry, biostatistics, etc., but now a 5th core facility within our study to understand and lead in mobile technology. We will then move forward in recruitment of a 12,000 survivor cohort, a cohort co-enrolled into Healthy Heart, which I will call a connected cohort, ultimately to provide a large pool, first and foremost, for mHealth-based intervention studies, so that we can use our mobile health technology as the outcome measure and intervene on this population to determine if we can change the course of health in this survivor population. And finally, in the distant future, I do think it's realistic within our study to have a completely connected cohort, providing direct measures in real time. So I think all this is consistent with the NCI's vision that they laid out for 2 years ago for 21st century technology-driven epidemiology. In this meeting that happened just, I believe, 2 years ago, the call out was to include intervention studies, to monitor across the lifetime, to use novel technologies, be able to process large data sets, and to be cost effective. I have everything in here in red that I think we're doing consistently. So finally, in closing, here in one slide were our key concerns, because I think these are the discussion points for future discussion on this topic. Number one, security. Absolutely, we have to protect the health information of our participants and do this in a HIPAA-compliant space and in a space that is consistent with the consent process. Secondly, will it be used? This is a population used to completing surveys by paper and by telephone. Can we induce culture change, and is it sustainable? Flexibility. Well, is the platform we develop today going to be flexible for next year and the next 5 years and 10 years? It has to be. Expertise. I'm quick to say we don't have it, but we can engage those who do and collaborate. Cost. Validity of outcome measures. Perhaps my most important. I'm not interested in the newest, latest, greatest gadget. I'm interested in something that can measure an outcome in a valid way, both precise and accurate. I want to know that if we're measuring blood pressure, that we're actually measuring blood pressure, not some other number. That's the accuracy. I need to also know that over time, in repeated measures, that those measures are precise and consistent. That is key. Otherwise, none of this is worth going forward. Validity is the key. And finally, I won't enumerate this, I think we'll talk about it much today, is the ability to handle big data. We currently as a study don't have that ability, but again, through the expertise we're engaging, we should be able to. So thank you for the opportunity to speak. It's a fantastic opportunity to be here with you. Have a good day.
Thank you, Greg. Our final speaker in this session is Dr. Jorge Chavarro, who is an assistant professor of nutrition and epidemiology at the Harvard T.H. Chan School of Public Health and also in the School of Medicine. And he'll present on Nurses Health Study 3.
Okay, thank you for the opportunity to present about our work in Nurses Health Study 3. So you may have heard about Nurses Health Study and Nurses Health Study 2, but not necessarily about Nurses Health Study 3. So what I'm going to tell you about is the most recent offspring of this chain of studies. Right now, the Nurses Health Study 3 is an ongoing open prospective cohort study of nurses across the United States and Canada. And we have right now approximately 40,000 participants enrolled completely online. So compared to where my colleagues started before, we decided to forego paper, we decided to forego telephone, and our initial engagement with everybody started in web, and then we moved forward starting from web. Now, what I want to tell you today is how do we get here, and what are our plans to moving forward with this cohort that is a completely electronically based cohort. So, of course, we had some experience in our group in identifying women or people in general and tracking them using questionnaires in paper. And we also had some experience in biologic phenotyping, of obtaining biological specimens and obtaining other blood, but also other types of biological specimens, and increasing the precision of phenotype on that end. And what we wanted to grow was on the electronic phenotyping in this cohort. So what's the type of information that we can gather from electronic devices, from wearable devices, and from your electronic fingerprint that can aid in advancing health research. So I'm going to focus today on three things. First, how do we get people into a study? What was our experience into getting people into a new study? How do we get people to follow up over time? So if there's one thing that you cannot buy is time. So what has been our experience in following up with time? And third, if we are able to get them to respond either on web or through phones or wearable devices, what is the infrastructure and what have been the decisions that we have made in order to make the best possible use of this data, or at least what have been our judgments in trying to answer those things. So I'm going to start with the first two, what has been our experience in getting people into studies and making sure that we can keep up with them. So when we decided to start a new cohort, or to try to start a new cohort, we decided to pit against each other two approaches. One was going completely opposite to our tradition, which was focusing on health professionals. And rather than focusing on health professionals, we decided to go for an HMO membership-based, population-based cohort, because we thought this could have the opportunity for scalability. There are existing HMO networks that have been used for research, and we saw the opportunity for scalability. This could definitely overcome one of the major problems that we have faced before, which is the concerns about underrepresentation of minorities, and generalizability of findings from a cohort of professionals and of health professionals in particular. And it also offered an opportunity to do something that can be done very easily in Europe, but cannot be done easily in the United States, which is to passively follow people with high-quality data. So we knew that if we could get access to EMR and insurance claim data, we could potentially follow passively people. And on the other hand, we decided to say, well, let's try again with the health professionals. We have been successful with health professionals in the past. Let's see if we can be successful with health professionals again. So what did we do? For the initial study, which was the HMO base, we decided to do a pilot to test only two things. One, can we get people to join the study? Second, can we follow up people for at least 6 months if we haven't had any contact with these people before? So we decided to randomize them to two strategies for recruitment and retention. One was to have them contacted multiple times. The other one was to offer them money to participate. And what happened with that? So the results in a nutshell, we had a very low enrollment rate of 5,000 people randomized, 5,000 people randomized to one of the four arms. We had a marginal response rate of 6.4% of all people we contacted. Now, the good news is of people that we were able to contact, a lot of people were, most of them were eager to give us access to electronic medical record and insurance claim data. So 72% of people who decided to enroll, meaning they completed baseline questionnaire, were consented to give us access to their electronic health data. The other bad news is that of those who enrolled, only 63% completed a 6-month follow-up. So we were only able to keep contact with 200 people out of 5,000 within 6 months. So at the same time, we were, the only one thing that we did find useful in this study was what happened with this intervention. So offering financial incentives decreased participation rate. So if you offered people money to participate, they were less likely to participate. And if you contacted people more often, they were more likely to participate. So the highest participation rate was among people who were contacted multiple times and were not offered money to participate. And we also looked at what predicted who would complete a follow-up 6 months afterwards. And the only significant predictor of completing follow-up was allowing us access to insurance claim data or electronic medical record data, which we interpreted as if you want to participate in a health study, you will participate in a health study. So at the same time, we were we were also evaluating the potential of going with health professionals. So we tested 3 strategies. One is repeating what we had done in the past, just send blank invitation letters. The other one was send blank multiple contacts based on some of the information that we had seen before. And the third one was to let a cohort build itself organically. So we identified 1,000 Nurses Health Study 2 participants that were actively engaged in the study. We gave them a description of the enrollment criteria, and we told them, if you know somebody who might be interested in participating in a study like this, let them know, and this is how they can participate. And these are our cumulative response rates over the first week of study. So the bottom 2 lines are just the blank mailing. So if you just mail people and ask them to participate in a study, they won't. So we get response rates at about 2% for just blank participation. The person-to-person strategy was slightly more successful, and that's what we decided to go with. So what we have been focusing on is on outsourcing this and replicating this peer-to-peer recruitment by partnering with nursing organizations, by asking existing participants from Nurses 1, Nurses 2, and Nurses 3, and by engaging participants very, very strongly in social media. And we had a concern about potential issues with underrepresentation of minorities, so we did a targeted mailing to potential minority participants, and we essentially sent them this card. So we identified people who we thought were African American, and we sent them this postcard. We identified people who we thought were either Asian or Hispanic, and we sent them this postcard. The reverse of the postcard had information on how to join the study. And this is how our enrollment has worked. So the peaks have actually coincided with mostly mailings, with mostly third-party initiated personal invitations. So either an organization with or a group that somebody already has a relationship with asks somebody to participate. The things that haven't worked has been advertisements. So we've tried Craigslist, we've tried Facebook ads, we've tried Google ads, and that hasn't worked so well for us. Now, how about retention? So this is more or less, this is a diagram of how participation in the first year of our study has worked for us. And if you'll notice, there's a lot of little feedback loops telling us people, try again, try again, try again, until you get people to respond. And I think this has been the main key thing for us to be where we are. When we first started, we had a much lower intensity of going back to participants, and that had us at about the same 60% response rate to the initial questionnaire that I showed for the other study, when right now by increasing the frequency, we're at about 75% to response to the first questionnaire. And once people respond to the first questionnaire, they're very likely to stay. Our response rates go at about 70 to 80%, 80 to 90% after the first questionnaire. Now, lastly, what have we done about the mobile part? That we have decided to work into a three-tier, not showing, sorry. So just imagine that there's text there. So the bottom line said tier 1, which said it was a mobile application. The second one, the second box, was supposed to say tier 2, which is ecological momentary assessment data. And for working on these two tiers, we have decided to go with a product called Spades, which is an open source product for app development for health information, which was developed through the NIH's Small Business Program. And the reason we decided to go with this is essentially scalability and the fact that it can be modified and it can be and we can change what we want to know over time, and that has been very, very important for us. And also battery life. It has a very, very low impact on battery life. The third box that you're not seeing there is wearable devices. And as far as wearable devices, we have decided to go with try with Fitbit charges. And the reason of that is twofold. One is the granularity of data that we're able to get from Fitbit through their API partner. And second, the fact that the Fitbit device, as opposed to other devices, has addressed some of the issues, a major issue which that we had and that was mentioned before, which is validation. So we want to know that what we're measuring is actually a trait that we want to measure and not just one random number. So this is how data moves within our study. And lastly, to finish, so what have been some of our major concerns towards implementation of this initiative? First, money, but more than money is the fact that we're competing for the relevant skill sets that are necessary to make this thing a reality with people who have much more money than academic institutions, like our hosts today. Second is the rate of technology change and trying to balance the rate of technology change against the long-term partnership. So for us, it is very important that if we start measuring something today, we want to know that we can still measure it 10 years from now, but that's not necessarily the same interest of a technology company. Third one that has been very important and that was a major issue that we decided to go to Spades is data ownerships. We could have gone faster on using an app if we had decided to use other services. But a key issue is that many developers, some of the services built within their contracts have it that the data belongs to the company, and that is just a no-go for us. And also, we also need to understand. We need to understand how stuff works. So, and that has to do with ideally we want to have as much as raw data as possible. Although we understand that that's not necessarily something that some companies may be able to to share. We want measures that are validated or validatable and as few black boxes as possible. Lastly, two things. Building knowledge and comfort about this type of technologies within IRBs has been a major issue for us. Many of the comments that we get back from IRBs when we try to push technology a little further reflect, in my opinion, just lack of comfort with this type of technology and in deploying this type of technology in large numbers of people. So they may be okay with a study that's going to do this with 50 people or 100 people, but when you tell them you're going to do it with 100,000 people or 200,000 people, they get very nervous and they start asking a lot more questions than you would normally get. And last one are data storage and data issues, security, privacy that was mentioned. How do you manage this volume of data? So how often do we want to measure, how often do we want to retrieve specific data if we're going to get it from a large number of people to make sure that we actually can store it somewhere? That has also been a major issue. And also we think that going forward, there's going to be a major need for standardizing processing algorithms for this type of data, and that we currently do not have. So that's it. Thanks.
Great, thank you very much. So just to orient you, since this is the first session of the day, those who have not been to a bunch of these, as the people sitting in the first few rows have, we will now go through a session where we'll ask questions and just kind of moderate, talk amongst ourselves. And then towards the end of this, we'll open up to the audience for maybe the last 15 or 20 minutes or so. So thank you all. I detected a number of themes in this discussion. One of the things I think maybe would be interesting to start with is the beginning, which is enrolling patients. And so I think each one of you talked about models of consenting that were electronic, and I guess I have a couple of questions in that vein, which would be, how did you manage identity? How did you do the consent? How did you sort of verify it is who they say they are in terms of then sharing vital health data that could be protected by HIPAA, especially when we talk about connecting to the EHR for the Nurses Health Study?
Okay. So most of our participants right now are web-only participants, not necessarily participants that have provided via specimens, which require an additional level of identification, or participants that have required mHealth data, which requires an additional level of identification. So the way we have dealt with that is by asking our IRB to continue the traditional model that we had for paper-based studies, in which the IRB had agreed that if somebody returned a questionnaire that was implied evidence that they were interested in participating in a study. So we just translated that to the digital world, and we said, well, if we send them a questionnaire and they enroll in our study and we get data back from them, that means that they are interested in participating in a study. And the IRB was comfortable with that. As far as validating who they are, as far as linking that information with other potential sources of information, we have done that. We have tried to address that in two ways. One is try to obtain social security numbers or other other data that can be linked to National Death Index or other social security-based outcomes data. Now, we decided purposely not to do that at the beginning of the study because we didn't want to freak out people saying, hey, tell us all about you, and by the way, what's your social security number and your mother's maiden name. So we didn't want to do that. So we have delayed the implementation of collecting this type of information to make sure that first we're collecting among participants who are our most faithful participants, and second, to decrease concerns about privacy of information. We think that once somebody has been in the study for 2 or 3 years, providing us information every 6 months, sometimes more often, they will feel comfortable in providing us information with social security numbers. One thing that we have not been successful at and that we keep trying, that we have that I want to eventually become successful is in getting electronic medical record and insurance claim data from hospitals and from insurance companies, given that we're not starting from an HMO-based study. And I think the main reason that we have not been successful is that many hospitals have not transitioned from the model of a paper-based request for information to an electronic-based request for information. So all our transactions with our participants are electronic. So we can get electronic signatures, we can get electronic authorization from our participants, but when we transmit that information to a hospital or to a healthcare provider, they're going to say, no, we really do not know that this electronic signature corresponds to this person, so we're not going to release information from these people.
So we're in a unique situation in that we have a cohort that we've been engaged with for 20 years and have a rapport and a relationship with. So as we've moved forward with our app-based communication, so the app is going to provide treatment information. So this is protected health information. So we want to be certain that we are reaching that participant. So we mail out a letter with a personal identifier code, an access code that goes uniquely to that participant. They use that code to access the app, and then they have to then enter a second piece of information that only we know, such as their birth date, for example. And so by entering those two pieces of information, we link them to their portal and their portal to them in a unique way. So that's for our app. For our monitoring and intervening piece, again, this is, for us, not having to develop that expertise was important. So we, by engaging with Healthy Heart, use their e-consent process to consent into the Healthy Heart study.
So our relationship with our participants is even longer. Right now, our original cohort has largely passed away. There's under 50 that are alive today. But for their children, their grandchildren that are enrolled, or Gen 2 and Gen 3, this has been their whole life that they've been part of the study, and their family's been part of the study. So we don't have the same issues, I think, in terms of recruitment, because we are a closed cohort that is generational. And so we have what I would say is a very compliant participant base. The other thing is, because they've been in the study for so long, they have signed multiple consent forms, so that's not an issue. And when we went into the realm of genomics and genetics, we actually had to go back and reconsent people with the idea that they need to consent for things that we can't yet anticipate. So we have that kind of now grandfathered in. We have proxy information. Everybody has had to identify proxy. I deal on the cognitive aging dementia side. So we even have access, once they lose the cognitive capacity, to provide consent. So I think that the other thing that we have that's really important, and I think that's been said here, is we do really have a personal relationship with our participants. They actually expect us to know a lot about them. I happen to have to go into their homes, and they expect that I know everything about them. I know everything about their family. I know everything that's happened to them. So we maybe have a very different kind of relationship. So, and I think that speaks to why, with our recruitment base, when we used our in-person sort of contact and direct phone, we were much more effective because we have that personal connect with them already.
I agree with all of the points. I think the hope that you're hearing from everyone is that the new technologies will make the consenting process actually truly informed. And so I know many of us in the room have consented patients with 20-page forms for a clinical trial. And while it has to be at a certain level, reading level, to pass IRB approval, I think the reality that people are truly ingesting this information seems unlikely. And so working with consenting wizards, working with user experience groups, which has been a lot of fun personally, really trying to think about the end user and how that information is being generated. I hope that we really push the boundaries on IRB, mostly to make it user-friendly for our participants.
I think each of you talked about different mobile technologies that could be used, and in most cases, these mobile technologies, it seemed like they were all standardized across either a custom app or a Fitbit or something like that that was going to be uniform across the study. Do any of you plan to use just a variety of different types of technologies and trying to harmonize them in the back end, such as Fitbit, Jawbone, and some other way of assessing number of steps per day.
So I agree that that's actually one of my major concerns right now, is that we have multiple devices sort of moving forward, and we need to integrate better. So I sort of taking, I guess, maybe a two-step approach to that, which is one is as we move on the back end, is using the big data analytics to help us harmonize data into a more centralized form. But I think the other piece of this is we need to think about integrating our devices themselves. Like I mentioned, we cannot ask people to wear multiple devices, and part of my sort of thinking about what devices to use, part of the reason I selected Shimmer was because it's an open platform. And so on the one hand, it's customizable to pick up a number of different metrics with one device. I mean, from the standpoint of the participant, they just put it on. It's actually programmed to measure different metrics at different points of the day. And all the participant has to do is wear it, dock it to recharge it, and wear it again. So I think that that's really important. And because it's open platform, it also can integrate across other devices. And then I also mentioned, I have some collaborations going on with the research institution in China, in Hong Kong, around technology development, where we're now trying to integrate devices. So in terms of mobile devices, smart home devices, and then also a user interface that I think is both scalable, but that also can speak. In my case, I have a lot of interest in the elderly population.
So I'm not particularly interested in letting devices drive what we connect. I want the research questions to drive what we connect. So in my mind, we want to ask, what are the key questions for survivors of childhood cancer? And I'll pick one, hypertension. We know that for survivors of childhood cancer who've had chest radiotherapy or anthracycline chemotherapy, hypertension in a multiplicative way compounds their risk for heart failure. So we need to measure hypertension. And so we won't do that across a 10 or 12,000 person cohort, but we want to do it in a focused way, and in a way that we can intervene. So selecting a sub-cohort of that population for a randomized intervention trial where hypertension is the outcome. And so I don't see deploying one device or multiple devices over the entire population, but more creating a platform for intervention-based types of studies.
So I think we're halfway between those 2 points. So there are a number of traits that we're interested in measuring. We know some of them can be measured very well with wearable devices. Some of them could be measured with smartphones or with just the built-in sensors that most smartphones have today. The main drivers of our decisions to go with Spates for the application and with Fitbit for the wearable device is not because we don't think others are not good, especially on the wearable device end. It is because Fitbit had done, or somebody else had done their homework in comparing Fitbit to accelerometers. So they had done their, as far as measuring whether or not a Fitbit could actually measure physical activity, and it can do pretty well. So it comes down to the issue of we don't want to measure something for the sake of measuring it. We want to know that when we're measuring something, we are measuring what we think we are measuring. So we decided that at this time, at the state of technology, or at least at the state of technology that is verifiable in the scientific literature, we could only be certain that you could measure sleep and physical activity with a Fitbit. It's possible that other products can do the same or better. It's possible that you can do better with other devices for other traits, but we don't have any evidence. And if we don't have any evidence that they are actually going to be able to work, then we cannot publish papers. I mean, just imagine writing the method section. So we use this device, and then the hocus pocus in the background happened, and we got data. I don't feel comfortable writing a paper doing that. And in our group, we have decided that before going with specific devices or specific apps, we need to know what is it that we're measuring.
I think to follow up on that theme, that makes sense. And I think the biggest challenge, though, is to try to tease out one of the items I started to talk about, which is the known versus the unknown. And so I think in many ways it makes a great deal of sense to use the best device, for example, if you're interested in atrial fibrillation. So we know atrial fibrillation is a problem. But chances are there are a lot of signals that are unknown and probably even better detection devices. So as a cardiologist, we can think for heart failure, I could list off what I think are going to be the 5 best things that a mobile device should measure. But that's based on my experience. And it may very well be actually the number of people I see or how much noise I'm exposed to or all sorts of other variables. And I think to try to push the envelope, we need to consider some of these unknown signals, especially in the context of research studies. Again, it's a much harder thing to do, but I think that's something we want to keep in mind.
So just to add to that, what I want to remind everybody is Framingham started out as a study of heart disease, and we've now grown into a study of chronic disease. I always tell people that I'm very fortunate. Turns out what's bad for your heart is bad for your brain. Our dementia studies didn't start until 1976. The diagnostic criteria for Alzheimer's disease wasn't published until 1984, and yet we're really leading on that front. So I agree that we have to think about what I always talk is about the balance between novel versus innovative. So novel is sort of more based on precedent, where we have some basis for understanding and moving forward. But I think we have to think about the innovative. And the innovative, I always tell people, for something to be truly innovative, you can't have heard it before. And therefore, there's really no basis for us to make that decision. So we have to, if we look at Framingham as an example, it really is about if you measure the right things at the beginning, even though you don't know you're measuring them, they can be really important.
Can I make another comment? So I forgot to mention, one of the other reasons we decided to limit the number of things that we're the devices that we're measuring now is that we think we need to gather experience in precisely identifying these unknown signals with a single device, with a standardized device that we know, where we know everybody has it. But obviously the idea is that the experience we gain in a more controlled setting when we have a single device that knows that works can be used to build a platform where you can integrate data across multiple devices and across multiple types of electronic data coming forward.
I think you could go thinking about the different devices and validating the measurements to the perspective of thinking about blood pressure cuffs. So you mentioned hypertension and measuring blood pressure. We have a wide variety of blood pressure cuffs that can be used within a hospital, and we believe that they work, assuming that they meet certain standards and they get validated, and we let our patients measure their own blood pressure, and I actually believe their blood pressures if they tell me they use a certain kind of cuff, and I check it in my office. And so, we maybe are early on the phase of this, but you could imagine a variety of devices that are validated being acceptable. And, if you think about Google, sort of your large data across many different sources often seems to win over a smaller data set with a lot of precision. And, healthcare, I think we're usually more comfortable with a lot of precision in infusion measurements than maybe more imprecision over lots of measurements. I don't want to spend too much time on this topic, but any brief thoughts on that question?
So I think you highlight 3 key themes. One is the openness around the data. The second one is collaborating to make sure we understand these signals and that they're identified and then further validated. And then we take it to the next step to make sure they're potentially causative. So I think that's important. And then the final one just goes back to our original theme is we know what we know, but we don't know what we don't know yet.
I just want to remind us in terms of what we know, what we think we know. We know it based on old ways of gathering it. So when we think about the gold standards that we're trying to validate, we have to remember that we're validating them against the old metrics. And so that's where I really worry about us tying ourselves too much to what we already know. I like to use blood pressure as an example. We know blood pressure fluctuates throughout the day. We don't know actually how much it fluctuates, and certainly not in a normal population. Most of the people we monitor very closely actually already have high blood pressure. And the reality is that we don't go from, particularly in the area of chronic disease, we don't go from being normal one day to being not normal the next day. So you're not normotensive one day and hypertensive the next day. It's something that happens over time. And because we haven't had the technologies up until this time to measure something even as simple that we think we know a lot about in terms of blood pressure, there may be now with these new technologies a new arena of what we really think is going to be gold standards. So that's probably one thing I keep in mind.
One of the things I was really glad to hear, I think, from everyone was the importance of thinking about validation of the meaningfulness of the outcome, that we can measure something highly precisely and not necessarily it have clinical impact. And of course, I always jump to thinking about the CAST trial and suppression of other things that we thought were meaningful in the EKG obviously was not helpful in that study that caused excess death. And so I think we'll find lots of things, and everyone has, I think, echoed this, and I don't know that we need to spend more time on it. Were there, in particular, unintended benefits or unintended harms so far seen in your studies using mobile technologies?
So one of the unintended benefits that I hadn't really anticipated, it turns out when you sort of start to merge technology with your research interests, is that you create new IP. So since I sit in Intel right now, that might be of great interest, is that when you create this new IP, you actually create new opportunities for products and services. In my initiative with China, both in terms of the mainland and Hong Kong, they actually look toward the development of this national cohort study. They're interested from the health perspective, certainly, but they're also interested from the economic perspective. They think that this is going to help drive their new economy. So my own personal is that suddenly I have to give disclosures in a way that I never had before because I'm now part of initiatives that are moving into the commercial market. So that's one really unexpected. I think that it's a good thing.
I'm not sure that we're far enough along to answer that question well. I mean, obviously, one of the downsides potentially could be breach of information in a way we've never had the opportunity to breach information before, and so I worry about that. That keeps me up at night. But I think there's tremendous benefits that our population. I mentioned this, the pilot using the dermoscopic lens, not a pilot. It's actually an R01 funded intervention trial. Our participants are jumping off the shelves to get this device. So there's a novelty and an interest factor and a very high quick participation rate with that study that amazes me beyond any other intervention trial that we've done within our study. Yet I do worry about the staying power. We're in the middle of that first year, and will they be consistent with this novel device over time? And we're seeing slowly in the first year some waning of that. So I do worry about that, but I think the verdict's out for our study on that.
So we have very similar concerns regarding data security. I think that's definitely the biggest issue that we have to deal on a daily basis. Another unexpected problem that we had is providing feedback to participants on a timely manner. So timely means something very different if you are dealing with somebody who's communicating on a smartphone versus somebody who's communicating on a letter. And we dealt with that very early in our study when we asked screeners for depression and anxiety. And we always leave space for our participants to add additional information if they want to. Oftentimes, participants leave information about providing more details than we want to know. But we had at least one instance in which one participant wrote in the open comment section that she was having suicidal ideation. Now, there's one way to deal with the perceived timeliness, depending on your resources and depending on how you deal. So if you deal on a paper-based questionnaire, which is where we have developed our experience, and you're checking paper questionnaires months or years after somebody has checked these, your responsibility as an investigator is very different from when you're gathering information, and people, even if you tell them that you will not be checking information in real time, people may have the expectation that you're going to be checking information in real time. So that had us change some of our procedures, some of the way in which we delivered the questionnaires, because we realized that we were not prepared to address these kind of situations. Definitely not with our existing infrastructure. It would be exceedingly costly for us to be able to monitor for these type of interactions. Another side benefit that we have seen is that people are actually are more willing to share information than we thought they wanted to share information. So they actually want to tell us a lot more than we thought they wanted to tell us. So one characteristic of our studies that we embed within our questionnaires a lot of branching to allow for personalization of questionnaires, and a lot of personalized routes within the study. So essentially, everybody in the study has their own timeline depending on their experience. Most of our participants, so our average participant is a professional woman of 30 to 35 years of age who has never been pregnant. So we are now entering the peak reproductive years of these women, and one of the things that we allow branching for is for pregnancy and for people who think they want to get pregnant or are actively trying to get pregnant. And those are our best participants, the people from whom we actually get the most information about. We also have additional branching to assess the specific occupational exposures and to assess detailed family history. And one concern that we had at the beginning was that we were asking for too much information. And the feedback that we get for people who actually do end up going into these branched questionnaires is that we're asking them too little. So that has actually been quite positive. Now, whether we want to keep asking more and more detail is a question that we haven't decided.
You raise an important point that we've discovered as well, is long before this becomes cost effective, and you could imagine with mobile health-based communication, we might need less staff. But long before that happens, it's cost intense, because we're doing all of our day-to-day activities, and on top of that, our new activities with new questions, new real-time engagement. It's become cost intense, and it's unbudgeted in our current award. So it's an intense process.
Yeah, I would say that too. I mean, in our recruitment, the in-person contact seems to be the most effective, and that's not a funded initiative on our side. But I think it is surprising how much of our participants, because many are older, are actually using technology at some level, which I think is very, very encouraging. And then their willingness, they're very patient with us too. And so as we throw new things at them, as long as we take the time to explain them and walk them through it, they seem very willing. I got to tell you though, one big thing is we're drowning in data, and we do not have within our current funding mechanisms the capacity to find the expertise that we need on the analytics side to make use of it. So more than anything, we can collect all this, but I got to tell you, we need a lot of help in terms of analysis. I mean, Framingham has that problem without even adding the digital technology into it.
And I would highlight that I think we think a lot about mobile technologies, and today the focus is on that discussion. But as I was thinking a lot about it, the synergies between the technology go way beyond just the devices or the molecular toolkits, but it's the back-end analytics and partnering with strong software companies and groups that have thought a lot about data and also have access to very large data centers. It makes sense to extend these discussions, I think, in those kind of technological spaces as well.
Let me go ahead and open it to questions from the working group and to the audience. Rich.
So in addition to the terrific work you're doing with mobile technologies, you must have made a lot of progress in engaging your participants in thinking about the questions that you study and the ways that you study them and the ways you give data back, and those are all really important to us. So could you talk about the role of your participants in what we would overall call governance?
Okay, so I'll answer that one first. So I think one way in which we have our relationship with participants has changed a lot has to do with the expected speed of feedback. So when you move from a paper-based or a telephone-based interaction that happens occasionally with a web-based or a mobile-based type interaction that can happen any day, any time, and when people may be in different stages of their study at any one particular time, giving feedback and giving good quality feedback becomes increasingly difficult. So, in that sense, participants have changed the way we operate. We can no longer operate with the same infrastructure that we had for paper-based questionnaire because that doesn't meet these needs. The other thing that participants have done is that as over time, participants have actually shaped how we ask questions, and they have shaped our decision to ask or not ask for different types of health outcomes. So I already gave the example of the mental health issues, right? So we became aware that we couldn't deal with real-time interventions, nor we were interested, nor it was responsible for us to pretend to be web psychiatrists and to try to deal with these type of issues on real time. So it changed the way in which we approached how we assessed mental health issues. But so that happened in the way of restricting things, on shrinking the way we were doing. But it has also changed the way in which we ask things. So in terms of adding more information. So one thing that I think the clearest example for that has to do, in our particular population, has to do with occupational exposure. So we started a little shyly trying to ask occupational exposures of these women, in part because we thought that would be something of interest for participants and would keep them more engaged. But since we keep open-ended fields to gather information on how they think we're doing, as far as asking questions and as far as asking whether or not the questions that they want to get asked, we have expanded the assessment of occupational exposures. We have expanded the timing of when we ask occupational exposure. So we only used to ask among non-pregnant women. Now we ask among non-pregnant, pregnant, as well as women trying to conceive. And it has led to refining of some questions. So we've, in moving from the paper nurses to the web nurses, we tried to maintain as much as possible consistency so that at some point we could pull data across the three cohorts. But as we moved to web, we realized that some questions that work well in paper actually do not work that well on web. Not only because the format allows you to gather additional information that you wouldn't have gotten on paper or better information, but also because you're dealing with a different generation that were, even if you want to have data across multiple cohorts, that might not be the relevant question that you're asking for a younger cohort.
Is there other viewpoints on governance we want to discuss?
For us, participant engagement is critically important. We have a limited number of survivors. Every one of them is a precious resource. If I put out a Fitbit and the instructions aren't clear and they get frustrated, they may not only not connect the Fitbit, they may leave the study altogether. And that is, so it's mission critical for us to be engaging in a way that is clear communication. And so for our app or for any other survey, we have a patient engagement process. We'll pilot that in a small group of our participants and get feedback. And we let that help to guide us as we go forward. So engagement, I think, we cannot be in the mindset of there's 300 million people out there. If someone doesn't want to participate, we'll just find someone else. We're actually need everyone, and we want everyone.
So let me just ask, do your participants, are they involved in either selecting or prioritizing the topics that you will study? If you say what's going to be in the next round of grant proposals we write, do your participants engage in that process?
No, yes and no. Largely no, because we've been collecting the same information consistently now over 20 years, so there'll be a base set of information that we will continue to collect. And then our additional studies above and beyond that are really targeted at research questions, health-related research questions, some of which is driven by feedback, but most of which is not.
Right. I would say they're not actively involved in deciding the science, but they have the, obviously the option of opting in or opting out of our different, we have many ancillary studies at Framingham. Our participants are kind of used to being contacted about different studies that go well beyond the heart disease. Everything I do is not related to, cardiovascular disease. And so I think, but we also have multiple engagement with our participants, and they do give us feedback. With the sleep monitoring study, for instance, that was a new way for us to do sleep study. They had previously participated in the sleep health heart study, which was very labor intensive and required that we come into their home. So the feedback we got was that, one, they're very happy that we're not having to come to their home to do it, but two, they sort of give us feedback, even in terms of, yes, you didn't give us enough information, we've had to change the brochure a few times. They were actually our participants were very engaged at the time when we moved into sort of some genetics work. At one point, we had brought in a private company to do potentially the genetic sequencing. And our participants actually objected to that. And so we pulled out of that. So I would say that we keep them informed of what we're thinking about, we take their feedback, and we incorporate it into how we're going to move forward. And it has, at least in one instance, sort of changed the way in which we did move forward.
Great. In interest of time, let's go through kind of questions and answers quickly. Pearl.
Yeah, thank you very much. We've talked a lot about participants. I was wondering if you folks could also talk about providers, the importance of engaging providers, because you're talking EMRs, we're talking potentially actionable items.
So we have an advantage at Framingham because you can't go through medical school without learning about the Framingham Heart Study, so that makes it very easy for us to sort of engage in providers. One of the things we do ask our participants to do is to sign a release to get their medical records, which we've been doing for many, many years now, and we contact the providers directly. I think it does help that we're in the media as well. A lot of our studies are published. Our participants are actually very proud to be in our study because their physicians will often say, you're Framingham Heart Study participant, so those are all things. So we have a little bit of an advantage, I think, on that front.
Yeah, just a quick comment on that. I think there's the providers in a study, and then they're just providers more broadly as we start to have all of this data. And putting a physician hat on, physicians don't always want more data right now until we understand it. And also making sure that this is something where physicians and providers and healthcare providers more globally are part of these decisions, such that whatever comes out is really, I always call it a healthcare provider support tool. It's not something, you hear a lot of people around here talking about how there's no need for physicians, and we hope that it just helps make everyone's job better, but I think engaging now is critical. And then one comment to the engaging participants. We obviously are now talking about crowdsourcing of clinical trials. We just have to be aware that the paradigm is changing. Patients are organizing themselves, which is great. And what does it mean to be a data donor, which takes it a little bit outside of the hands of what we traditionally think about. So we're going to see, I personally think we're going to be seeing some big changes in study design in the years to come.
I want to add my voice to thanking you for a series of informative and thought-provoking presentations. Thank you very much. You know, of course, that we're struggling with thinking about how to assemble this cohort of 1 million plus people, and we wanted to be able to support great science. And part of that has to do with a general consensus that in order to do great science, we need to ensure that it include the diverse aspects of our population, because we know that disease, disorder, related conditions and risk are not randomly distributed in our population. We know that they systematically vary by age, gender, SES, race, ethnicity. Assuming we can accomplish that at the cohort level, in the data acquisition process, we have similar concerns about the same extent to which these factors may be at work in terms of the differential participation of the members of this cohort. So in your answers to several of the questions, it's been from the perspective of the participants you already have in your cohorts, as opposed to how you engage them. Dr. Chavarro's report of I think, very striking low rates of participation raise great concern, because we know even the conventional methods that we have today in terms of recruitment and study participation, we see enormous differences by those very same factors. So my question of you is, what kind of guidance can you provide us based upon your experience to date if you were rethinking doing your study in order to ensure the kind of diversity and representation to do great science with the applications that you hand?
So I actually confronted this very question in thinking about how do you develop a longitudinal cohort study on chronic disease in China. China is 1.3 billion people. There's no way to get representation from any one study group. So our strategy has been that we're defining a core protocol. We're saying that we know sleep, physical activity, nutrition, environmental exposures are very important to health, all health outcomes, regardless of what your outcome of interest is. And we're really mobilizing around that. So we have a cohort study. So that's what you do, is I think you have to establish the baseline. And then from that, I think you then make it widely available. This is all about data sharing, right? And so if you put it in the hands of many, then I think then you have the individual investigators start to move out and find those represented populations.
How do you take your experience and generalize it to the U.S., though?
So in the U.S., I think it's the same concept, right? I mean, we started with a cohort study, Framingham, and I think that was sort of my idea is sort of, well, how do I build? Framingham is not representative today like it was before. And so I think the idea here is it's the same concept. If you establish the same base protocol and widely share it, we talk about team science and data sharing. This is really we have to go, but we have to put it in the hands, I think, of individual investigators, because you're going to need that sort of, certainly at the beginning, that personal touch to really drive it forward.
Just quickly, we're fortunate in our study that we have very good descriptors on not only participants but non-participants. So we can describe non-participation, and to the ends that you can describe non-participation, that's very, very important to at least describing the bias that may be potentially in your study.
So this is an issue that we have paid a lot of attention to, especially after our experience in the HMO-based enrollment. So as far as trying to improve diversity, what we learned very early on is that you need to bring expertise for people who know how to do specific things. So we know how to start studies, but we don't necessarily know how to make advertising for joining a study. So we have been very fortunate of being able to work very, very closely with Dana-Farber Harvard Cancer Center Health Communications Core. That has done a fantastic job not only in redesigning all our communication tools, redesigning our messaging to participants, but also helping us figure out what is it that we can do specifically to reach out underrepresented minorities. If you look out at how much does it cost us to recruit a Caucasian female as opposed to a minority woman, it is incredibly more expensive to recruit her, in part because we have put a lot more effort into doing so. So when I described the targeted enrollment, so what we did was essentially we played junk mailer and racial profiler. What we did was we obtained licensure rosters from every single state in the country. Some states will sell you race information, so they'll sell, here are the names, and if you want the race information, we can sell that to you for another however many dollars. So we purchased that. And for the states in which we knew the race of the potential participants, we target them specifically. Most states will not actually sell you. So what we did was we used a combination of data on zip code and of zip code where these people was residing, and demographic data on the racial composition within that particular zip code to try to guess the race of different people. And then we did these targeted mailings based on this information. We might have been wrong, but this has actually, as far as trying to guess what particular minority these people were, and that's why we didn't include any specific messaging in terms of words. It was in terms of images. To try to garner interests from these particular subgroups.
Great. I think we're going to go for about 4 more minutes, so I'm going to kind of resort to how we've done before and ask for lightning round style questions and answers. John, I know you've been standing there for a while.
My name is John Birch. I'm a private investor and a member of the Angel Capital Association, particularly the Life Sciences Syndicate within that group. I've got just one quick comment, then a question. The comment is on security issues. It seems that security has been mentioned by everyone as being absolutely critical, and I don't think it's just critical from a scientific or data point of view, but also from the patient's confidence point of view. They know that if they give a fingerprint or if they type in their social security number, it's not very secure. There is a company I should mention, I'm not invested in it, called iVerify, which has 99.99% reliability that just uses the camera in a smartphone to look at the blood vessels in the eyeball. It'll even distinguish among identical twins, and it maps, changes over time. It can not only, you don't have to do anything, you just look at your phone. And it verifies you, and it can make sure that you are it is continually you who is interacting with the phone, throughout the interaction. Might be something to think about. But my question is this: you've all mentioned some degree of, let's say, pushback as you've begun to adopt some mobile technologies. Could you just quickly summarize what those key sources of pushback are from your participants?
I'd say the number one factor is age. What's the age of your participant that you're targeting?
And what are they objecting to, I guess, is really...
Yeah.
So in our case, we have a very young population, so they're very comfortable using mobile devices. So in our case, the biggest discomfort happens at the institutional review boards.
I agree.
Great. I'll take a question over here. I think you're not on. Can we get this mic on?
Hey, yay, thank you. Hey, John White from ONC. It's an actual question, but I'll make it a rhetorical one since time is limited. In your opinion, across the Precision Medicine Initiative, what's the right level of collaboration on shared data infrastructure, analytic tools, things like that, to enable the goals of the Precision Medicine Initiative? So that's, you don't have to answer, just think about it. Thank you.
I think you should answer.
Sure, quick one-word, two-word.
Team science, multiple PIs on every grant, by the way, and then data sharing for anything that isn't specific to your aims.
I echo that. Collaboration is the word.
Yes, and I would add collaboration between industry and academia. It's going to be key to move this thing forward.
Collaboration sounds good.
Great. And I think we'll let you have the last question here, since you're a member of the working group. Go ahead.
She was standing there first. I was trying to be a gentleman as a lady to the right was standing there first. So I'll yield to her and I'll be quick after she speaks.
Just a quick comment. In the workshop number 2, we discussed the use of omics and the exposome, the environment, the effect of environment, the exposome, and many other things that can be captured by global analytical tools. I just want to remind the panel that perhaps a crosstalk between all of these tools that can bring a measure of sleep, the metabolome, perturbations across the sleep cycle, are things that can be measured by measuring hundreds to thousands of chemicals, right? The diet and the composition of the diet to get to a quantitative measure. We have the analytical tools, and this is being battled by the metabolomics community. Connecting the dots, I think, is going to be important to derive knowledge, not only data. And connecting this to the monitors would be great.
And I would take it a step further and say now's the time to start thinking about how to integrate all of that data, because I think we heard from the panel, there's the collection and then there's the appropriate integration.
And you were a great gentleman. I'll let you have the last question.
Thank you. Roderick Pettigrew from NIH. I actually had 2 questions. One, they're both simple, but one would be longer to answer, so I won't ask that one, just the first one. Greg mentioned validity of data is a key concern. And I think that this is a question that often gets a free pass among the public. There is an assumption of validity there. I think those of us involved know that this is not necessarily the case. Could each of you talk about this issue and how you have addressed it or are addressing it in your cohort studies?
Sure, I'll start. And again, I plead that right off the bat, we're not experts in this, and so we had to collaborate with those who are experts. So through our collaboration with the Healthy Heart Study, Jeff Olga and Mark Pletcher, who's standing behind you, we are counting on them as a core for our group. We're not going to put forward a device that doesn't have adequate validation or we can't validate. So for us, it's leaning in on those who have the expertise to validate this before we move forward with the device.
So my strategy is to do both at the same time. We still collect the old data, we collect the new data, and we bring them together, and we see how they compare.
Same thing here. So the way we have done is start with a device that we know has been validated, but that doesn't mean that we need to stop there. So one concern that I've heard from industry is that the level of information that we would want for complete validation, saying give us the raw data, gets in the way of IP issues for a company. So what we may need to find is a middle ground where academic investigators feel or have the ability to work with as much granularity of data possible without making public trade secrets of companies that have a very strong monetary incentive.
Great. Well, thank you guys very much for a very obviously energetic, entertaining session. Let's give another round of applause as you are. Thank you.
Hi, and this is Gwen Jenkins. We're going to be taking a slightly shorter break, 15 minutes, so we're going to reconvene at 10:30. Thank you.
We are off to, I think, a great start this morning, and we're headed into a very high-energy session on mobile technologies for participant engagement. I'm Bray Patrick Lake. I'm one of your co-chairs for the advisory committee to the NIH Director on Precision Medicine, and I am delighted to introduce to you all today Dr. Mary Beth Gandy. Mary Beth Gandy Coleman, she actually goes by Mary Beth Gandy, and if you're looking her up on Twitter, she is at Mary Beth Gandy and not at Mary Beth Coleman. She is the director for the Interactive Media Technology Center and the associate director of the Interactive Media for the Institute of People and Technology at the Georgia Institute of Technology. Go Dogs. No, I'm just kidding. All right. And then we also have Dr. Bonnie Spring, and she's the director of the Center for Behavior and Health and a professor of preventive medicine, psychology, psychiatry, and public health at Northwestern University. We also have Dr. Anand Iyer, who is a chief data science officer and former president and chief operating officer at WellDoc. And then we also have Miss Kathy Sigona, and she is from the Healthy Heart Study, and she is a study participant and Alliance Steering Committee member. So with that, I will turn the podium over to Dr. Gandy.
Hello, everyone. Oh, there are my slides. And this is the thing I hit. Okay. So I'm a computer scientist, and I study all the cool things we can do with wearable technologies, augmented reality, stuff like that. But I work at the human-computer interaction level, so figuring out how to apply all these really novel technologies to applications that are effective and that people really want to use. And so a guiding principle of the work that people like me do in HCI is user-centered design. And, you know, at the core, this is about not trying to force the users to conform to your system or your application, but rather truly understanding them and the context that they live within to design a system that is appropriate for them. And so a couple things I want to highlight. One is when we're talking about these mobile systems, and especially wearable systems, these are supposed to integrate into your life as you go about your business, whether you're at work, you're playing with your kids, you're socializing with friends, you're exercising. And so those systems, you have to be willing to wear them, you have to be willing to interact with them, it has to feel comfortable on your body, it has to look a way that you find appropriate for your style, for the community that you live in. And, wearable applications are meant to support you in your primary task. It's not a typical computing application where you're focusing your whole attention on it. It's supposed to just become part of your regular life. But this is a big challenge then for making a system that elegantly integrates into your experience. Another point I had on that previous slide was about all the different stakeholders in these kind of systems. So yes, there's this user, the person that you're giving this app to or you're asking to wear this wearable device. But then there is the support network around that person, their friends, their family, the child that is doing IT support for them, the doctor that's receiving the data, and the community at large. So if I'm using some system like this out in my life, my coworkers, my friends, random people with me on the bus are also going to possibly experience part of this system. And this is very important when we're talking about health systems, where people may not wish to disclose to the world around them the details of their health status. Or you might want to design a system that isn't discreet, but presents itself in a way that is like positive and affirming for the person that's using it. Now, so then to design this individualized solution, you first have to understand the ecosystem that this person exists inside of. So, what are they doing in their daily life? What kind of work do they do? What kind of food do they eat? What kind of entertainment do they partake in? What are the cultural norms within their community? And again, with this health applications, obviously, there's lots of privacy and security concerns. And some of that is ameliorated by the amount of value that the system provides. But it's particularly tricky because there's a lot of aspects of our health and wellness that we may not want to advertise to our friends and colleagues. And we first have to look at, well, why are the existing interventions failing? So there's this major leap. We've heard today about all these great technologies that are out there for sensing, so collecting all this data. So we collect it, then we have to figure out how we're going to present it, either to the caregiver, the medical professional, the user. Okay, we've presented the data. But then, especially for the user, there is this process of sense making, and then developing strategies based on their new understanding of what this data was telling them. And the real challenge then is making that leap to positive behavior change and long-term adherence. And we've all seen various studies showing the drop-off of use of a lot of these wearable technologies, for example. You get it for Christmas, you use it for a week, you lose it, you lose interest. And a lot of that has to do with, if you're asking someone to really heavily engage with this mobile app or wear this thing every day, it has to be providing them positive value daily. And that value, the fact that it helps them manage their diabetes, that might not be enough value. And so a really good example of how this can be done right is the Digital Family Portrait, which is a classic project from Beth Minot back in 2000. Now, under the hood, it was your standard kind of health monitoring system. So you've got an older adult, you're monitoring through smart home technologies, their activity level, their various health statistics. And you could imagine presenting that in kind of a dry, prescriptive way. Instead, that data then drove this very compelling, positive application, which populated this picture frame that would then be at the family members' homes. And it gave them this kind of gestalt, pretty vague sense of what the older adult had been doing over the past few days. And the point wasn't to look at that and diagnose a problem. The point was to trigger communication between the family. So trigger a phone call, trigger a visit, or some other sort of interaction. And so that was really provided a lot of value to this older adult. Instead of feeling like it was this medical app that's watching them, it's like, hey, this is this really great experience where I feel more connected to my grandkids, and people are calling me more. So as we see again and again with wearable systems in particular, if somebody isn't getting a lot of value from it, it's going to disappear, it's going to break, they're going to say they don't understand how to use it. There's just not a lot of motivation to continue with it. So you really need to be providing that value. And this came up in the last panel. Is there this one-size-fits-all solution? And unfortunately, I don't think that there is. You can have this great device or this great app, but if you're talking about drastically different user groups, that one-size-fits-all may not be appropriate. So like my pictures here, these are all drastically different people wearing Google Glass. And that baby is my baby, so I'm not violating anything. But here's an interesting piece of wearable technology in drastically different situations, from a police officer, to a baby. So there's all these aspects we have to consider beyond, there's the basics that technologists like me think about. Well, does this collect valid results? Where does it stream the data to? What's the update rate of the data and that kind of thing. But we've got to consider, especially with the wearable and mobile experiences, what is the context that this particular person is going to be using it in? And if it's something that's going to be visible, what kind of statement is it making about them to the outside world? What are the social conventions? Even if it's just a mobile app, it doesn't seem all that fancy. Is this something I'm having to pull out constantly while I'm at work and interact with? Is that considered appropriate in the environment that I'm in? A lot of these wearable things, the problem is, depending on the community you're in, the type of work that you do, you might not feel it's socially appropriate to wear an accessory like that. So you really have to have different sorts of solutions for different sorts of people. And kind of to go back to something I said a minute ago, remember that you're using this system as you go about your daily life. So you've got to think about what are the cognitive and sensory requirements of using this thing. So I only have a limited amount of, attention and cognitive resources and visual field of view and space on my body. And whenever you're introducing one of these systems, you're taking up some of that. And you can go so far that you're keeping them from being able to go about their regular life, or you're making them uncomfortable, like physically uncomfortable, socially uncomfortable. So you have to consider all of these things. So to conclude, I won't go through all these, but these are just some, I think, interesting lessons learned from related research in this area. For example, Rosa Arriaga and others have looked at asthma management in kids. And, as adults, we might think, okay, here, we've got this great system, you use this inhaler, you have this mobile app, this is going to be great. Except that the kids were being made fun of on the playground for how it looked when they used that inhaler. Another example, Becky Grinter has been looking at nutrition education for people in lower socioeconomic levels. These are people that live in food deserts. If you give them an app that teaches them to drink kale smoothies, it's not going to have any effect because the people in that community cannot access the kale, they can't afford the kale, it's not socially, maybe the norm to eat the kale. So this Order Up application that she built teaches you how to make good choices with the food that is available in your community. And this is all in this theme of nudging. So there's a lot of research now showing that if we want to help affect this positive behavior change, sometimes the best approach is a very light touch. So now there can be a lot of really complicated algorithms behind the scenes, but knowing when to give this just-in-time information and help someone, just nudge them into making just a little bit better choice. And that can have bigger effects than the application that swoops in and tells you, again, kind of gives you this negative feeling, like you're doing this wrong, you're unhealthy, you need to go run a marathon, you need to drink your kale smoothie. That doesn't necessarily have a good effect. Back to my point about there isn't a one-size-fits-all solution. So there's some really positive outcomes from using SMS for asthma management. Low-tech solution. You get a text message. It asks you for a bit of information about your condition that day. And really the best effect from this is it makes the person themselves reflect on the state of their health that day. When you take that same system and apply it to people with congenital heart disease, it does not work because it made the users feel upset about being reminded of this condition that they have. So you can't just take this one technology or this one application design and apply it uniformly. So to conclude, what we know from various research studies of wearable systems is that, okay, not only does this participatory design approach work in terms of creating better finished systems, and we've kind of heard that already today, not only does it do that, but the people that are the participants, that feel like they were active partners in the research and the design, have a more positive view of the system at the end and continue to be more engaged with the system later. So one way of getting people more engaged is by having them feel like they're a real contributor to the research. So with that, I will conclude.
Oh, okay, now we'll hear from Dr. Bonnie Spring on social support apps for engagement.
Great. I'd like to thank the committee for all the hard and very worthwhile work that you're doing on this, and thank you also for asking for input. So the question that we were asked to address is, what features should a mobile application have to ensure long-term use? And much of this, you know, I'm sure you've heard again and again, it needs, whoops, I've lost my slide. Okay. It needs to be simple, usable, personalized, and it needs to change periodically. But I think there is one thing that's critical and underlies everything else, and that's the value proposition, that it's got to give someone something that they want and need. Given the fact that the cohort study is an observational study as opposed to an intervention study, one of the things you can give people is feedback, best if it's in real time. You can probably ask them to do more if you remember the burden proposition, which is that you can ask people to put more effort into something if you give them higher value and reward back. And I think that's the sweet spot that's really important to remember. So just taking an example, I work in the prevention space. I work on health behavior change. One of the things I work on is weight loss. And so here you see what we used to do to have people accomplish weight loss. We had them track their diet and activity on paper and pencil records. Now we give them apps that we can't, they still have to enter their diet, but at least it can track automatically their physical activity. They can stand on a scale that wirelessly uploads their weight. So does this make any difference? Well, it does, and in some very good directions. So if you look at self-monitoring adherence, and this is, did people track their diet, exercise, and weight every day over a 6-month period? You can see that with paper and pencil, we get about a third of the days tracked. If we just give them the technology, which gives them feedback in real time, we go up to about half of the time for diet and physical activity. We actually go over 90% of the days tracked over 6 months for weight. And this is just the feedback. So the feedback is something good, and it's something you can use. The other question I was asked to address is, would adding social support further enhance the engagement with self-tracking? And would it improve clinical outcomes? So we've been looking at this a bit, and this is an app from a study that we've just completed where we had people in a weight loss intervention, and we had them competing in groups of 8. And we wanted to know whether giving them information about their group members would help them succeed in this self-tracking. We asked people if they were willing to share their weight loss with people. Nobody was willing to have their weight floating around in cyberspace. But what they were willing to have was their self-monitoring adherence. And so what you're seeing here is an app we developed where in traffic light colors, they're seeing whether somebody has been tracking their diet intake and wearing their accelerometer. Starts out red when they haven't at all, goes yellow when they've done it part of the day, green when they've done it more of the day. So it's pretty cool. People said they liked it. Did it work? Well, it seemed to work for about half of the people. For that half, they behaved like we thought they would. They said, I was really jazzed to know what my peers were doing. I wanted to reach out and support somebody if they were having trouble. I wanted the support myself. But then there were other people who said, I really didn't identify with those people. And this was sort of burdensome. And the other thing it did was it created the problem that when we had some people participating with the app and in the chat room, nobody was responding. So it was actually isolating that person, making them feel very bad. So our thought was, okay, the problem is these groups are too small. If we have just one person speaking in a chat room of 8, that's too small. So we went bigger. We got data from an online weight loss network. We got data from 27,000 people. And what we looked at was, did the social support in this digital online space work better? Well, the first thing we found was that only 11% of people used the social support function. Only 11% of them made any friends at all. If they did, it made a huge difference. In this site, about 40% of people went to the site once and never came back. Half of them were gone by 2 weeks. If somebody made one friend, 90% of them were around 6 months later. So the friending, the socialization, is clearly related to adherence, but we don't know the direction of the effect. The friending was also related to a clinical outcome. Here's the relationship between their social network and their weight loss. And what you can see is that if they made any friends, they lost more weight. If they were connected to the giant component of the network, they lost still more. And if they were connected to these connector hubs, the sort of yentas who welcome people into the site and cheer them on, they did really well. And there's a dose-response relationship between how many yentas they were connected to and what their weight loss was. But the problem is we've only got about 10% of people benefiting. So how could we improve upon that? I think what I have finally realized is I've been thinking about this like a researcher who thinks of myself at the center of the universe. I have been recruiting people and trying to stratify my sampling, control the randomization. I think what I need to do is to go to the social networks and the communities where people already are and let them bring their own network. So, and I think this is related to a question I heard raised in the last engagement session, which was, how can the precision medicine cohort engage resilient people, and how can it address prevention? And a number of us are thinking that establishing a college subset of that cohort could really go a long way here. But enrolling a college cohort really requires you to address the value proposition. I'm launched on a trial, we're about to begin this, that's funded by the American Heart Association that addresses a little known but important health problem. And that is that during the college years, college students lose between 13 and 20% of their long-term cardiovascular health. The reason is that they pick up these chronic disease risk behaviors, like they gain weight. They often pick up some of them will pick up smoking in conjunction with their drinking. They become physically inactive, and their diet goes to pieces. And by the end of this, they have lost a lot of their cardiovascular health, and these habits tend to persist. So we are about to launch a trial in which we are randomizing 500 incoming Northwestern freshmen to a cluster randomized design in which we're intervening to try to prevent this loss of health in half of them, and the other half are addressing other risk behaviors. So I thought this should be pretty straightforward. I'm a health interventionist. I know how to treat these behaviors, so I'll just go out and I'll offer these things. But I thought I'd better spend a little while getting to know the college population. So we spent the last year doing that and learning what they value. And what they tell you they tell us they value is, most of all, academic success and future professional success, saving the world, and maybe having a little bit of fun, de-stressing. Their college administrators, in turn, also have some things they care about. Mostly they care about academic success because they want successful alums. And they also care about the health problems that wind up getting them in the newspaper. Some of you may have seen the New York Times article today on suicide in the college population. They care about binge drinking. They care about sexual violence. So I'm sorry to tell you that if I walk in and offer my treatment, there is nobody who is saying, where were you when I needed help with controlling my fruits and vegetable intake? Just like I'm sorry to tell the committee that there is probably nobody, in spite of the positive feedback, who is sitting around saying, I just can't wait till I can enroll in this cohort. People have their own agendas. They're going about their lives. And so it behooves us to figure out how to align with what they're trying to do. This is what's gotten us very heavily into an engagement solution. What we're doing is citizen science. We are truly co-developing our intervention with the students. We have no choice. We would be fools to try to go in and do anything else. We are having them, because they don't understand why they should care about these health behaviors, we are having them do N-of-1 experiments on themselves to look at the impact of their physical activity, their diet, on their academic performance, and on their appearance, something else they care about, and on their stress, something they experience. We have computer science courses engaged in developing apps for us. They said, look, we can't exercise because we have no time. So they've developed an app that tells them when they have free time to exercise and suggests what they might do. A number of us, we have a workshop coming up this Thursday with computer scientists and health specialists who are working with us to try to establish a college student cohort, multi-site, to look at this problem. And so my recommendations to you would be keep the apps usable, simple, personalized, and introduce novelty from time to time. Remember the value proposition. It's fundamental. The burden has got to be really low unless the reward is high. The driver has got to be what the participants are trying to achieve. It's important to capitalize on the existing social networks to recruit. And it's really key to collaborate and co-invent with the community because they've got to drive it. Thank you.
Great. So thank you to Dr. Spring. Now we will hear from Dr. Anand Iyer. If you are on Twitter, he is at WellDoc.
Hi, guys. Yes. Hi, guy would be the appropriate response. It's okay. So I'm a wireless guy, and I've been in wireless for, 20 years, and then something funny happened in 2002 when I developed type 2 diabetes myself, and I affectionately joke that the two things that define me, one is good, which is wireless in my blood, and one is not so good, which is a little excess sugar in my blood, but somehow WellDoc has managed to fuse the two together. What I'd like to do is share with you the journey we've taken and the outcomes that we've achieved, and share with you along with the way some frameworks that we've established that I think are going to help this entire dialogue about what we do with precision medicine and the data. So the honest truth is, as a patient, is on a day-to-day basis, I have to manage everything, right? I have to manage my glucose, I have to manage my meds, I have to manage my diet, exercise, stress, sleep, smoking if I smoke. And there's this little thing called life that gets in the way every now and then, right? At the same time, I consider myself a little bit of a nerd. I am a data scientist. So I take my data into my doctor and I graph it, okay? But what's the doctor going to do in a 2-minute office visit? The human eye isn't trained to look at a series of numbers and say, oh my God, it's time to add 10 more units of Lantus to this patient, right? And so at the same time, doctors don't want to be bombarded with the data, because if you ask an overworked, underpaid doctor to do one more thing that's outside of their workflow, no matter how sexy it is, they won't do it. And so what you have is you have this clash. And there's a lot of stuff happening. There's a lot of buzz going around. meter companies, I have new meters, and they count down from 5 instead of 6, and I'm like, I have a hole in my finger. It doesn't matter. So they're innovating in ways that don't matter to me. And so we asked the question, are we solving the wrong problem? I love this picture because the guy's arms broke, but the vase stayed intact, right? Are we focusing on the wrong problem? And I would assert that the problem is actually twofold. The problem is first that the right data is not getting to the right person at the right place at the right time. But that's a problem that every other industry has solved. That's called connectivity. And you can do it with all the security and privacy and encryption and non-repudiation and all that good blah, blah, blah stuff. Great. The harder problem is, how do you take that data and convert it to information, knowledge, actions, and tangible outcomes? And tangible outcomes for me may be very different than they are for Bray or for anybody else, and certainly for the different stakeholders in the healthcare ecosystem. And one of the things that's required in this transformation, people call it behavioral science a little bit, is context. If I tell a patient who's naive to insulin, and they're afraid of taking their insulin, maybe if I show them how to inject, or if I show them this is what you can actually do, and maybe they don't want to take it because grandma died when she was on insulin. Well, grandma died because she started it too late. Well, you have actually a chance to live. But if I show them that kind of support 6 months afterwards, it's annoying. I got it, right? And so things have to be contextual to them. It has to be contextual to their med history, their medication regimen, and their psychosocial preferences, right? So what we did was we built this system. We built the system that had 4 parts to it. So there's a patient coach, and we were talking about real time, and the patient enters their parameters on their smartphone, dumb phone, we really don't care. Let it be any phone. It has to be a device that they have that they use. It could be a TV, an iPad, a PC, seamless mobility. Let them use the device that's most convenient to them, right? But when they enter that parameter, they get real-time coaching on what to do. And my coaching may be different than Sparrow's coaching because our history may be different, our doctor's instructions are different, so it's tailored and personalized to them. We've had patients when they entered a good blood glucose value, and you say, hey, way to go, Richard. If you give me another way to go, Richard message, I'll throw the bloody phone away. The very next lady, though, says, hey, if I have a nice day, can I have a picture of my grandchild show up on the phone? Because that's what keeps me motivated. And so you start to think about the level of personalization. So you provide real-time contextual coaching. The second thing you do is you provide clinical decision support. We talked about it earlier this morning. People say, you know what, mobile health and digital health are going to take doctors away. When you're sick, you don't want to see your phone, you want to see your doctor, okay? Plain and simple. But the doctor has to be a critical stakeholder and a contributor and a participant in this equation. So what do they get? They actually get a nice formatted, analyzed report at their beckon and call that suggests to them, hey doc, here's where they were, here's where they are, here's what's changed, here's what you need to do, but you're the doctor, do what you think is right for your patient, and I'll talk to you about the outcomes. And then, of course, there's the expert system that ties it together, and there's this little growing piece, if I would, called social. Because at the end of the day, sometimes as you start to look at the ethnic groups, especially the South Asians like myself, you look at the Hispanics, we listen to one another sometimes more than we listen to our doctors. But if I can actually find a recipe that works for me, that works within my parameters and my constraints, well then that social networking and that concept of getting information from my diabetes peers is actually positive, right? So when you take the solution and turn it on its side, what do you actually have? You have 4 modules, which is kind of cool because this is a platform of sorts. I can expand this to asthma, to rheumatoid arthritis, to oncology. The modules stay the same, the content changes, the rules change, right? But there's medication management, which is required, of course, for us in diabetes and every other chronic condition. There's symptom management. There's lifestyle management. And this is all aided, of course, by this Internet of Things. The faster and the easier I can get this data from a series of sensors, that's what we do. And of course, the last thing is physiologic management. That are measures that we can actually take, numbers that we can act upon. In our case, it's blood glucose, it's blood pressure, it's weight. In asthma, it's spirometry. In ovarian cancer, it's CA-125. Where we can have a number to hit and a marker to hit, we can actually then provide tailored feedback to patients on what to do. So what I want to do is introduce these 2 frameworks, which is, what are we actually doing in the realm of data collection? I would assert that all data today in healthcare, the vast majority of it sits in this bottom quadrant. That is data that's coming at a low frequency, okay? Say once every 6 months or 12 months if it's claims data, and it's coming from a lab or a system, right? And that's necessary, but it's not sufficient, if you would, in mathematical parlance, to actually make the outcome. What digital health does is it expands 3 new vectors of data. The first is this low frequency data, but it's actually coming from a patient. That is their medication profile. It may change because these are somewhat progressive diseases. It's their psychosocial profile. It may be their own preferences. It may be the people in their social network who may come and go and change. At the same time, you get high frequency data. And you first get high frequency data from the system, which is kind of cool, because even the absence of data, on day 3, if I don't use the system, it'll say, hey, I noticed that you haven't put in data for the last couple. So even the absence of data itself prompts action, right? Or you have things like repeated hypoglycemia. Hey, I'm glad that you're checking, but let's work on why you're waking up every morning at 60. Could it be because you're taking too much of your, long-acting insulin the night before, or did you skip a meal, or things like that? And then lastly, of course, you have the data that's coming from the patient on a day-to-day basis. And I'll share data with you that's it's Mythbusters, as I'll call it, and I'll share it with you in a moment. And of course, these data have to fulfill these 5 V's, if you would. They all have to represent a variety of all the parameters that I said. The more heterogeneous that data is, the better, the more value you can extract from it. There's a volume you have to consider, because there's some minimum volume that you need to actually make sense of what I'm going to show you in a second with pattern recognition. And there's the velocity, the veracity to make sure it's actually correct, and then that's how you extract value from the data. So if that's what we collect, then you say, what do we do with it? What we do with it is I'd like to introduce this framework that I introduced at the joint session with the NIH and the National Science Foundation a year ago, which is called IDEA, that says I first inform, here's where I know my data and I know my outcome, and I just want to, this is kind of Math 101, reporting. Show me how many times a patient did this, or males did this, or Asians between the age of this age and this age who are on this med regimen did that. It's 101 mathematical manipulation, okay? I inform. But once I inform, I then discover. This was Dr. Mega, right? Dr. Mega, who spoke earlier, the concept of the unknown. Can I learn something from that data? Can I learn something that I otherwise don't know about a cohort? For example, why is it that all these Indian males who have a certain set of practices because they fast every fortnight, why are they on a sulfonylurea like Amaryl that makes you have hypoglycemic incidents? That's the wrong drug, right? And so their social behavior actually informs the doctor, hey, this is the wrong therapy for them. I put them on something else, right? And then what I do is once I discover something of interest, I come down and I extrapolate. I build a predictive model. Today, I can predict after 10 days of use, on the 11th day to the nearest hour, if a patient's going to go hypoglycemic. And out of the 274 billion we spend in this country on diabetes, 47 billion is unnecessary hospitalizations due to hypoglycemia. I'll show you a chart in a second of how that curve is coming down. And lastly, once I extrapolate, I then adapt, right? That's how I change, and this is the point that Bonnie just made. Refresh it. Give them something new. Update it, but update it based on this journey of science, right? So if you put all of this together for a patient, what does it mean? It's the data. It's all of the data they collect that gives them this information, that gives them knowledge, that makes them do certain things to keep them in the safe zone. So, is the absence of evidence the evidence of absence, right? If you want to be a player in this place, you better have outcomes, and you better have proper research, otherwise it's just a gimmick. So, can you imagine, for diabetes, the gold standard is A1C, and A1C should be less than 7, and every 1 point delta, 7 to 8, 8 to 9 is 42% increase in heart attacks, kidney failure, blindness, amputation, stroke. The FDA heralds a drop of 0.5. When we got a 2-point reduction, they said, what the hell are they doing, swallowing the phone? We said, no, they're doing what their doctors asked them to do. And that's a huge finding. This is 2 to 3 times the value. In fact, when you compare it to other drugs, you can see how dramatic the effect is. At the same time, if I show you I was listening this morning and I just added this, so I'm going to take 60 more seconds and I'm going to stop, okay? Which is real world data. So this is a cohort in Maryland. Okay, you can see the numbers, so 600 plus patients. And look at the engagements. Okay, they entered their meds. Med entry is a huge problem. They're actually tracking their meds. But look at the third one down, notes. When they put in a high blood glucose after lunch, they're telling you why. They're telling the system why, because I'm glad you measured. It's okay that it was 300, but let's work on that 300. And they write, I won't have that extra slice of pizza. I'm going to try harder next time. In fact, the free notes are averaging 83 words. They're writing paragraphs. We never thought they would do that. So Mythbuster, guess who's our power users? They're all above 65. Oh, doctor says, I'm not going to prescribe it. They're not going to use it. They're the ones who are using it the most. Perhaps it's because they feel their morbidity. Maybe they don't work, and so they can. And that's the only way they keep in touch with their grandkids today is like this, right? And nobody does this anymore, right? Okay. In another one, people thought this is just good for people on insulins. In fact, the people on orals are the ones who are left behind. The oral guys are using it just as much, if not more. And then look at this curve. That's the number of hypoglycemic and hyperglycemic trends over time in this cohort. By the way, every one of those episodes cost between $2,000 and $14,000 for a visit or an ER admit or something like that. And look at the trajectory of this curve and think of what the cost savings and the direct cost savings of that is. So, yeah, is this the future? I think so in many ways, right? This is for real, right? And then, I'll end with this, which is I'm fascinated and I'm humbled to be part of this, team and we as a company being part of this team. But let us not forget, apart from the research and the President's initiative, having a chronic condition is lonely. And people go into this downward spiral, this abyss of misery because they're alone. And that has all kinds of negative consequences. And if technology can help abate that, if it can help give them a place to go to, then we've actually done something of value. Thank you.
Okay, so now we're going to hear from Kathy Sagona, who is our Healthy Heart Study participant and Alliance Steering Committee member.
Well, good morning. Green. Okay. Go for green, I hear. I'm very pleased to be here today to talk about a subject that's very near and dear to my heart, and I don't mean that to be a pun. I'm going to talk about the study itself, the Healthy Heart Study, how it's changed me as a person, and then talk about some of the lessons that I've learned. A little bit about me. I am a retired principal. I worked with 7th and 8th graders for many, many years of my career. And I have since retired, and I am now an adjunct professor in the School of Education at a local university where I live. Anyway, because I became so interested in what was going on with the Healthy Heart Study, I was asked to be part of the Healthy Heart Alliance. And with that, we have looked at how to engage patients and how patients really could support a lot of what we do in research. They have a voice. And so I'm quite happy to do that. I was asked to represent our group at a patient engagement meeting with PCORI in actually it was in February, was it late spring? And I learned an awful lot about what I can do as an individual, but what we can do as a Healthy Heart Study. About 10 years ago, I was diagnosed with atrial fibrillation. I didn't know anybody who had heart disease, nobody in my family, it was me. And after working with local cardiologists, I was referred to UCSF, which is 100 miles away from my house. And so to go there, I had to have considerable information to take with me to make sure that that 15 minutes that I saw my doctor was going to be worth my 100-mile drive. I was, as I said, a principal, and I did considerable amount of work in analyzing how kids learn and grow. I worked with staff. I looked at behavior. I looked at student achievement. I looked at absent rates. And so I was really into the global perspective of studying data. I knew data was power, and I wanted to make sure that I could bring that same power, that same rate back into my own life and take it to my doctor. So with that, I would go to see my doctor, and we talked about starting this, or he talked about starting this particular study. It's an online cohort study. You have to be 18 years or older. you have to have an email address, and you have to have a heart. And that's it. It can be a healthy heart, it can be one that needs a little help. But those are the only requirements. The Healthy Heart Study was conceived by 3 practicing doctors and researchers. One is here today, and Dr. Mark Pletcher, Dr. Jeff Olgan, and Dr. Greg Marcus. Those were the 3 that started this. Their overall goal was, there it goes, sorry about that, was to do research to simply improve cardiovascular health. That's their broad general consensus. How are they going to do it? Collect big data. We're going to keep costs low. We've all talked about in the last couple of hours about collecting data. For me, living 100 miles away, it was considerable cost for me and for the doctor's office if they wanted to collect my data on a regular basis. The cost of gas, cost of my time, the cost of the nurse's time to do my blood pressure, the cost of the lab in order to take my blood. So all of that can really be dispensed when we look at what we can gather online. Okay, we've talked about the smartphone several times, and I just had another little statistic. This particular one greatly affected me. That's one that Morgan Stanley did, that 91% of all of the phones that we have are within 3 feet of the individual 24 hours a day. When I first started this, that was not me. I was in the 9%. My phone was in my purse. And where was my purse? In my file cabinet. Where was I? Out and amongst all the kids. So I had no belief. When something I started asking my friends. Many of them work in the private sector. Many of them work in schools. The younger the person was in my little study, the more that was accurate. And then I started talking to folks who were working in other districts. Yeah, they carried them right there. They kept track of things on their phones. So I thought, well, I'm going to try that. So I did. So you know what? I'm one of those 91%. And what got me up today was the app on my phone that says, wake up at 6:30. So I was pretty excited. Well, let's talk about the Healthy Heart Study. And if you choose to join this study, this is the very first screen you're going to see. And I find that it is one of the screens that will open up an amazing world to you. It did for me. There's a little button, a little video button off to the side that will bring you in. It'll talk about the study. It's pretty jazzy, you know. Some people would say it's kind of sexy. I was enthralled the first time I saw it. So let's say we're going to join the study. So let's do that. I'm not going to talk to you about consent and IRBs and all of that because, frankly, I don't have the skill set to do that. Remember, I'm the teacher. So the very first thing you're going to hit will be a series of surveys and screens for you to select. This is just the flow chart. You're going to be looking or giving them basic information, detailed demographics about you, your activity and well-being, habits and lifestyles, and some of these little subsets under each one of these little categories are surveys that are tried out in the practice of medicine. Your medical history, detailed family history. It was interesting when I had to start talking about my parents, my brothers, my sisters, how detailed. In fact, I had to call my brother. Once that's all done and you've finished your detailed family thing, then for me, I had atrial fibrillation. So I had a couple of more surveys triggered based on that. Look at all the blue. This is a pretty exciting map, I think. Every country that is identified in blue has participants in our study. To date, we have 28,700 participants, and currently 21,841 consented participants. That's pretty exciting. I think Healthy Heart is well on its way to beating heart disease. This is basically where we are, and this is to support actually Dr. Ayer's statement that most of the people are between 60, 69. Well, that's me. And so it's pretty good to see that we're doing pretty well. And you can see between male and female, we're about the same. Some of the smartphone apps that the Healthy Heart looks at will take care of behavior, activity, communication patterns, locations. We have tiny little surveys that pop up every now and then. Hospital detection, 6-minute walk study, the diet, I believe Bonnie talked about that, and a social graph. Sensor integration, and this is where we talk about the wearables or the usables. Activity, sleep, weight, blood pressure, et cetera, et cetera. This is one of the screens in the Healthy Heart, and I think it's probably one of the most important ones for me, in that the study is agnostic in thought towards what device you're going to use. It doesn't matter. The other thing that's pretty exciting about it is I can pick and choose. And I did pick and choose. I don't use every one of these. And the other thing is I can choose my level of engagement with the Healthy Heart. One of my friends does not have a smartphone, but she's very engaged in this particular study. So she only inputs things through her computer. I input more, but that's where I choose to do that. One of the things that I do is a blood pressure measurement. As a heart patient, I do have a problem with high blood pressure. And I must say that this blood pressure has helped me tremendously, both with my PCP and my cardiologist, by the fact that I can keep track of my blood pressure on a regular basis. It's very easy to use. It downloads into my phone. It's stored somewhere up there in the cloud. And I can take that information to either doctor. A couple of weeks ago, I went to see my cardiologist, made that 100-mile trip. Bart was out, actually, part of the day, so it added to my stress on the freeway getting there. And so by the time I got there, I'm 15 minutes late. But my blood pressure is a little bit high. So anyway, I get in there, and Dr. Olgan says, "So how are you doing?" "Well, I'm a little excited here." So he read my blood pressure. "Oh, yeah, you are." And so first thing he did was say, "Can I see your log?" Absolutely. So I pulled up my iHealth, showed him my log. But then more importantly, I said, I want to show you through my electronic health record. I jumped into there and I showed him the last 5 times I'd been to a doctor and had them take my blood pressure. In the past, that probably would have been, "Well, Kathy, I think you probably need to adjust your medication." At this point, we didn't have to, because he could see that things were, pretty okay from the information I was giving him. The second one is, it's one of my favorite. Since I have arrhythmia, I use the AliveCor EKG. It's very simple. Every now and then, I get excited about it. You just put your fingers right on the diodes there. 30 seconds later, I have a printout. It's exciting. And this is what a printout actually looks like. That's not me. I am 100% pacer work. I'm very... I would probably say that I'm an electronic girl. Since I'm pacer controlled, my heart will not go below 60, so that 59 is not me. Anyway, next one was the app. Ginger.io has several things working in their particular app, And this is one UCSF wants to know, the Healthy Heart Study wants to know when you've been in a hospital. So this alert will come up. And basically, it'll ask you why you're there. Are you there because you need to be worked on, or are you there because a friend or a family member is being worked on? I lived right behind a surgical center. So I get this app probably 6 times a week. And finally I called them and said, you know, I do live. And so it's basically a geofencing type of thing. So it pinpoints me. And so it thinks I'm in the hospital a lot. So anyway, we squared that up. But the thing that the thing that I liked about it, it gives me a little, hey, you're doing good. So to sum things up, I was happy to hear that some of my conclusions met with some of my colleagues here on the panel. I want an app that's easy to read. I want an app that is intuitive. I don't want to have to spend a lot of time. Some of these apps can be used as individuals. I prefer to work as an individual. I'm not a joiner. And some of them you can join with. And then the other is the visibility factor of these apps. About 5 days, every 5 days, I get an alert from the AliveCor. If I've not already put in an EKG, it's going to ask me to do so. So I'm more inclined to do it because somebody's watching. And I'm going to comply because basically I want to do this. This is my contribution to medicine. The relevance in my life, I'm more engaged. I'm a participant in my own health. I'm a better patient. I come prepared with data. So it's not just me and my 15 minutes with my doc, but I come prepared with lots of information. I probably wouldn't have been where I am today without belonging to this particular study. And then the last is a little bit altruistic, is there are lots of people who have been in studies, such as the Framingham study. Lots of people have been out there to help pave the way so that I can be healthier. And so if I can contribute, I'm going to do it. And it's kind of fun. There.
Okay, so thank you to all of our presenters. We're going to do a bit of rapid fire discussion. We have some questions to go through with you folks, but then we want to very rapidly move into our audience discussion. I think we've touched upon a lot of these. So keeping in mind that the working group members have to write a report when we leave here today, we want to pick your brains very concisely and very rapidly. So what are the most important features to incorporate in a mobile application for the precision medicine cohort to ensure long-term use? I think each of you touched upon a few of them, but just what's the most important?
I guess I'll start. I want something that's easy to use and doesn't take much time.
And then building on that, I want something that collects things that are of relevance to me and that are going to help me at that moment with the problem that I'm struggling with, and also help me with, if it's a recurrent issue, help me with solving that problem over time.
And I want something that gives me feedback in real time on something that I care about.
So I think the fact that those were 3 different answers shows that there maybe isn't one thing. So it's about having something that can personalize itself based on what your values are and your psychosocial desires and such.
All right, so how do we personalize something for 1 million people?
I think this goes to the issue of engagement and to the fact that we can't as researchers, because we don't know our audience, that we need the engagement of the people that we're trying to help, who really need to take a hand in personalizing things for themselves. And I think that this is what's going to lead to some of these new research paradigms where we start to engage people in collecting data on themselves and learning how to organize those data in ways that they find valuable.
So this is an opportunity for all of us. If you put on your data modeling hat for a second, as scientists, we're enamored with what they call segmentation. That is, a priori, I go and I say, this is the segment that I want to cater to, and I define the segment with as many variables as I choose to. Whereas the reverse of that, which is called clustering, says I'm not going to segment a priori. I'm going to observe and see the natural Venn diagrams, a heat map of sorts. So I'm just going to collect the data. I'm not going to go in with any a priori thought of I want this, this, this. And what you'll actually find is that there's several Venn diagram intersections that occur, like a heat map. And the heat map then tells you that's the balance between scalability and precision. Because everybody would say, is it precision or personalized? Well, precision has to work for either an individual or groups of individuals. But it can work for groups of individuals. It doesn't infer an n equals 1. And so I would say that because of the sample sizes we're dealing with, because of the people who use these technologies, if we can collect this data and if we can use clustering, and there's 1,000, go read the book by Duda and Hart on how to cluster, versus thinking about it this way. It's a paradigm shift in how we typically approach this. I think we have the sky's the limit in terms of how far we can push the envelope on this precision thing, because we'll get precision, but we'll also get scalability. So we won't have to build solutions for n number of people.
Esteban, go ahead.
Great. Thank you. I really was intrigued by a point that you made that verged on the precision public health, because that's part of what we're trying to achieve here as well. As you talked about South Asian men, and on 14th day, and basically you discussed how their social environment interacted with their medical environment and how we need to incorporate that. So how do we tailor that? And I want practical suggestions. How do we tailor that to particular communities? How do we tailor your stuff to low SES communities in Appalachia, for example?
So it's actually really simple. So we've done it in a couple of, if you would, sub-ethnicities or subgroups. In our past in the Latino communities, one, the Asian communities, two. And the idea here is that you use surveys and you use periodic surveys in your application to collect preference data and monitor the change in that preference data. Okay? One of the techniques that's widely used is, you may have heard of a company called Insignia. They're out west in Oregon, Dr. Judy Hibbard, who's the CEO. And there's a patient activation measure, the PAM score that she's created. And the PAM score looks at these different attributes. And in her case, she uses the attributes to determine a score of engagement. In our case, we use the attributes to determine what kind of configurability, what kind of content do I need to deliver to that person. Because if I do know, for example, that they're going to fast, or if I know that they're just not going to exercise, well, then the treatment pathway may be different, right? I'm not going to say, hey, go lose weight. If I know this person's never going to get on a treadmill, then let me at least help them with meds. Maybe they'll swallow more pills. Fine, then you go that way. And so I think it's a combination of having them tell you in their manner when they want to, and building those profiles and watching them over time.
So I have a quick question for Kathy. So when you were consented for this study, did they present it as solely a research study, or was there some implication that this would be a health management tool as well from all the great data you would be getting?
I would probably say both, because I worked closely with one of the doctors who devised this study. I took it for me because I was interested in improving my health. So I took an active participation in that. And if I'm going to give them data, I need to use that data.
So What features or functions would you guys recommend to provide participants with more of a sense of ownership and control over their data and over the project?
Again, because I'm so big on function and value, I really think that we need to give people the opportunity to perform N-of-1 experiments on themselves. I think that's really the only kind of research design that matters to most people. They don't care about the average outcome. They care about what's going to happen to themselves. And so I think that we need to move towards building apps and systems that give people that capability.
So 95% of me agrees with you for all the obvious reasons. At the same time, there is a piece of the generality that makes sense. It goes back to that Venn diagram concept. Because if there's n number of people, you're not going to have n number of non-intersecting circles. That's just never the way it works, right? There's going to be some dimension of commonality, whether it's their race or it's their med profile or it's their preference, whatever it is. But this concept of do it for me, I'll just share with you a real example. One of the ways we trained some of our models was we had a grant from Maryland, and we got those continuous glucose monitors, and we gave patients a continuous glucose monitor. So in one hand, they had a dense, every 5 minutes, blood glucose sample coming, and then in the other hand, they were entering parameters into there. And so we were training our sparse data system to interpolate and, if you would, predict the actual continuous glucose. I asked the guys if I could keep my sensor afterwards. Fun. So first thing I did after the experiment was done is I opened up a bottle of red wine. And I poured myself my red wine because I love my red wine. And the literature says my glucose should go like this. But for me, why I don't know, it was stunted. And I was like, okay, thank you. I owe you one. Okay? But then there's a South Indian dish called dosas, which I love. Okay? And I made a dosa. And whoo, this guy straight up, right? I'm like, okay, we're even, right? And I think whole wheat in my body, for whatever reason, has a higher glycemic response than cornflakes. Why, again, I don't know, but for me it is. And so I think there is a certain amount of heat, right?
There's a sensible middle ground that actually relates to how we think about evidence-based medicine. When you think about what people will want to do to help themselves, there are things that have a research evidence base. They work for most people. That doesn't mean that they're going to work for you, but it's probably a reasonable place to start. If that doesn't work for you, well, then there's probably a second line, something that you would want to try. But the important thing is you try it out and you collect the data on yourself, so that you, over time, are tailoring what you're doing. And really, in terms of research and the new research designs, this is what we're doing with adaptive research designs. We're figuring out those decision rules. This is why I think that the ability to have these digital data creates the opportunity for a test bed to move some of the research methods faster and forward in ways that we need.
So I wanted to maybe come at this from a different angle. So when we talk about wearable technology, sometimes the solution for continued engagement and adherence isn't to provide more value in the health space, but to make that device useful perhaps in a totally different domain. So one of my colleagues at Georgia Tech, Mason Govinlu, was developing a neck sensor for medication compliance, which is one of these holy grail sorts of things. And it's one thing when you apply that to like an older population. People are happy to wear it. But then he started looking at, well, what about teenagers that have had organ transplants? So it's very important that these kids be taking their anti-rejection meds, and it's like super, super critical they be taking them regularly and at the right time. The problem is that the teenagers are not going to wear this thing on their neck unless the other kids at the high school are wearing this thing on their neck. Now, this is a really tough, I don't have the solution for this, but the way that you would make this a success is you would make that a cool thing that maybe is used for something completely different. And we brainstormed about, could it be a game controller? Could it be a social networking input device? the kids at the high school have to think of this as like a cool thing that like connects you to the, cyberspace, not a thing that monitors your medication.
The Healthy Heart Alliance sponsored a conference. It was actually called a summit last November, and anybody who was part of the Healthy Heart was invited. We had about 150 people who gathered over the course of a day and a half. And during that time, we were doctors, patients like me, researchers. We had a multitude of people coming from all over the United States. And part of that work was to come up with a study. And in fact, we came up with, I think, 11 studies, and we divided up into groups. These people have never worked together. We were strangers walking into a room. We had some phenomenal people who were the facilitators who made it all happen, but we got up, we voted with our feet, we moved, we interacted, and finally self-divided into 11 cohorts. And from there, we wrote 11 different studies. One of those studies on atrial fibrillation actually was continued on and flushed out and went for funding. Unfortunately, it didn't get it yet, but we're still hoping.
So Maribeth said something that's really, really important. I just want to amplify it, which is the blockbuster drug of the 21st century is what? It's the engaged patient. If you get them to do what they need to do, 90% of our problems in chronic disease go away. And then the remaining 10%, the research will figure out cures and things like that. And the trick then is, how do you get them to engage? And pick something that's relevant and interesting and fun. If it's a sports enthusiast, make sure your app has sports analogies or feedback. If it's somebody who's interested in horticulture, then it's got something to do, but whatever. But you see what I'm saying? That's a really, really important point you made.
So if this cohort, so I'm really struggling with the scalability and like that we have to deal with 1 million people and everybody's an individual. Are there a few basic strategies that you can deploy early on? Like if you can't have 1 million different personas, right? Are there like certain things that you can start with that are just kind of like if you could do 4 or if you could do 8, or how do you attack that problem until you actually see what the heat map reveals and then adapt to that later?
So can I give you the nerdy answer first? Okay. So for all of you who remember high school algebra, if I have a matrix of 1,000 people, and let's say I have 10 variables, pick your favorite 10. Maybe it's gender, maybe it's the disease they have, maybe it's their favorite sports team. I don't know. It could be anything, right? Okay. And when I look at that matrix and I take the rank of that matrix, it tells me a lesser number. So if I have n patients, I may have n over 2, maybe n over 3, n over 4 groupings, okay? There are other mathematical modeling techniques to get that dimension down quite low. So even if you have a very large n, you can very quickly arrive, even with just a handful of attributes, at meaningful clusters that say, that's where I'm going to start. Okay, I'm going to assume that those are my 10, 12, 15, whatever clusters, and then from there, I'm going to play the k nearest neighbor game. You're the n plus 1th patient, but you look just like cluster 4. Okay, well, you're in cluster 4. Whereas you're the n plus 2 patient, and you're dissimilar to everybody. Are you your own cluster, and you start, I can do it, and then maybe grow around you. But I think there are ways to do that. That's just math, right? That's simple.
Yes, I am my own cluster. Thank you for asking. Shariki?
Thank you. This is really fascinating. I think my question is a follow-up on this. What happens to ethnic identity or other major categories of identity communities on the heat map? Do people emerge into those, or is that suppressed on the individual, I'll put myself totally in another space, right?
So I'll respond, but you speak up. So I'll take this one personally. I hate filling out forms. It's the ethnic Asian. What the hell is Asian? I mean, you know, somebody from Taiwan and Vietnam and Chennai, India are very different in every possible way you can figure out. And so I think you don't want to, averaging, when you don't have to average, and that's the beauty of technology, you have the ability to collect things. Averaging low-pass filters, it smooths out things. It removes the variables that discriminate. And you want discrimination here because the discrimination allows you to keep, discrimination in the mathematical sense, allows you to keep specificity around that individual. And so I think in that case, you don't want to average and smooth out. You want to keep those variables to the extent you can.
And does that include gender? Because not only ethnicity, but other, you know, we all belong to, you know, at least 6 or 7 communities of identity.
I think this is one of those things that you start, and there will be some variables that you, the beauty of these things is they call it data-driven design. The data actually guides you. The data guides you step by step, and it'll tell you, you know what, this variable actually is irrelevant, okay, because it's the same across all your, remove it. Versus that variable shines, right? So I think that's another.
All right, Pearl Esteban, Rima.
Thank you all for not only informational but entertaining presentations. My question is, so much of the focus is on people who already self-identify into a group, such as diabetes, such as heart disease, such as college age. When we're looking at our million plus, how are we going to possibly have the context and the just-in-time information to keep them engaged of people who do not yet have a diagnosis or see themselves in such a group? And I think, like Kathy, if you did not have a fib, would you be in the Healthy Heart Study? What would have gotten you there? I think that's one of our major problems, challenges. Don't say problems.
I probably wouldn't, because I live in an area where I've not heard about it. Healthy Heart has not made it to the agricultural area of California. So because I chose to go to UCSF, that's where I did. I since brought it back. I've done several talks to administrators and teachers in my area, you know, because I think the teachers are you know, just a wealth of information. They're pretty compliant. You know, they're going to do their thing and be part of a group. They're educated. After I became a heart patient, several of my colleagues have too. So, you know, there in itself, what is it about heart disease and administrators, educators, teachers, you know, is there? Well, no, that was my favorite part. But, you know, I think we just need to advertise and get people involved. We need to bring it up to the conscious level. And it wasn't brought into my level until I was actually sick.
I think it's also important, as we talk about subgrouping people and defining them by their different demographics or their different communities, that we remember that choice and autonomy is pretty important in getting people to engage. And so I have some concern that we could sort of stigmatize or stereotype people by forcing them into their data pocket or their disease entity. And so this I think is part of the reason why having some social networking capability around the system that you're building is important, because it will let people align with other groups that they identify with. And I just think it's really important to give people that level of autonomy.
Yeah, I completely agree with you. And, you know, this question of, well, how do you get someone to want to engage with this application or system? And, you know, your college students are this great example. They're probably not going to be thinking about what their cardiac health is going to be like. But you know, the solution isn't maybe that we have this top down, like we're going to sit in a room and come up with like what do college students care about. But it's more that if there's a platform where you can have these emergent strategies and behaviors from groups that, you know, they choose to group themselves together. And, you know, maybe it's the college students that are wanting to get better grades, or, you know, do better on Tinder. Those could have, we laugh because it's like, well, that doesn't seem like a serious, health outcome. But it's them. Mm-hmm.
So you
Great.
guys said, you guys said far more eloquently what clustering is. So you may have 10 kids who come from families that have chronic diseases, maybe diabetes, hypertension, hyperlipidemia, whatever, but they don't have it. I mean, nobody's ever told them they have it. Their little BMI is a little high, right? So they're not going to come and self-select into a group. They're going to self-select into a group that says, I'm concerned about my health. Said, okay? And you track that, and you keep a variable called family history, and you keep it. Later on, if you decide to pull them into this group and label them, because they are pre-diabetic and their A1C is 7, or fasting glucose is whatever it is, 120 or 130, but you don't start by saying, hey, tell me your fasting glucose, I want to put you in bucket 8, right? That's exactly what clustering is. And so you let them self-select, but you observe, because you should be observing in the background, right?
Hi, that was a great point about having the right people in the room. When Siri, the voice recognition software, first came out, it didn't recognize female voices. And when they did an autopsy of why, there are no female engineers in the room in the design. My question to you, who needs to be in the room to collect the data that we don't know that we're missing,
The citizen science.
It is real, and it goes to the question about shared governance. And it's, unfortunately, about the best place you can start is with your major demographic groups and the groups that you think will be underrepresented. So you will have your highly educated patients with chronic conditions.
One of the big themes of this new initiative is to make sure that we don't repeat the mistakes of the past. And the mistakes, and I'll talk about it in my session, but out of all the funding that has been done in the last 20 years from the NIH, 95% has focused on European populations.
I agree. So this is where you need your targeted sampling. You need to make sure that the people that get left out are in the room. So, for example, when we talk about how my plan is to work the multi-site college student cohort, we want a split of public and private, of minority-serving institutions, East Coast and West Coast, and we want administrators and students on the advisory board so that the perspectives are represented. I think you need a shared governance system so that you make sure that the questions that get addressed are the ones that your both majority and minority and the populations that are usually missing are in the room being able to articulate them.
Thank you. All right, Rima?
Quick comments. Number one, over the past decade, as we started to incorporate beyond genetics, the influences of the environment, the gut microbiome that makes an Asian versus a US citizen versus a European metabolically look different. Number one is we are learning that if we take the environment, the diet, and the genome and look at the readout of the system, which is the biochemistry, we are all different. Each one of us has a unique metabolic identity. So I don't think we need to worry about making a discrimination and a stigma. We are all different. Metabolically, certainly we are. Number two, the gut microbiome cannot be ignored, definitely. Number three, when we put this whole metabolic maps, men and women are different. If we try to correlate these metabolites, we are wired differently. How is it the genetics? Is it the combination of different things? There are traits and different patterns in how we are wired biochemically as men and women and as ethnic groups. So I think the puzzle has to continue to evolve. And gathering data, the biggest issue is to gain knowledge. Not only gather data, but to integrate data so that we can link the genome, the metabolome, the gut microbiome, and gradually start to gain knowledge.
So, Gregor, yeah.
So, is this on? Okay, great. So, Bonnie, you raised some really important ideas on socialization. But as someone who runs a cohort, I worry. And we have an app that I showed you, but we've not opened it up so that participants can talk to participants yet. I think that's coming. But when you think about social media, chat rooms, a lot of potential problems in a large study. So one could be disclosure of information, even though they consent to go into that chat room. What if an employer finds out through that their employee has cancer? Secondly, you can imagine a scenario where a participant walks in and says, hey, thank you million-person cohort for my dermoscopic lens and the $25 incentive, and then within an hour, you've got 5,000 to 10,000 people saying, what about my $25 incentive? What about my dermoscopic lens? So I'm curious, from what you've done, have you seen negative consequences to social engagement?
This was something that we were very worried about, and I spent a lot of time talking about this, particularly with groups at the NIH that have done a lot of this kind of work. So NCI has a lot of social media presence. I've seen a progression where initially we were very, very concerned about harm and misinformation and how we were going to cope with that. And over time, I think we're starting to recognize that the population is smarter than we gave it credit for being, and that they can do a lot more self-correction. Nonetheless, I think it's important for these spaces to be moderated. And there's a tough dance to do, because when you have a moderator step in, it can it can shut down conversation. But the moderator serves the function of, if misinformation is not corrected or the group doesn't police itself, there's an opportunity to act. There's also the issue of being alert to health emergencies. Suicidal ideation, for example, is one. Now, I'm on a college campus, so there's something that we can do about that. But I think those are some of the issues that need to be dealt with.
So we're down to our last 5 minutes. Please be brief.
A couple things on the digital communities of interest. There's also ways to build them with a hierarchy, so that the people who are getting the $25 are only talking to the people who are getting the $25. You can't do anything when they leave that from a hierarchical standpoint in the digital community of interest, but you can control that in your space. The comment that I wanted to make was when we talked about bringing people in who didn't fit into a disease state. And as a non-scientist in the room, the best I can say is that I know from the Black Swan that we're not limited by what we don't know, we're limited by what we know. So how do we broaden that? And I'm curious from the NIH perspective if they've considered using any other kind of consumer tools to go out and target people. So for example, this may or may not be a good analogy, but you can actually target people using social media as an ad platform who have already liked 23andMe. We know that they're inclined to find out what their genetic basis is. We know that they're inclined to find out about their health and they care about that. Has there been any conversation to use consumer tools to go out and market to people who aren't typically in a group already?
So I don't work for the NIH, but if anybody from NIH wants to answer that question, go ahead.
As you should. So I think the question is not really directed to NIH, but to the working group in terms of how are we going to recommend that people be solicited and invited to participate. And I think we are in the midst of those discussions and welcome all the input here today.
Mark?
Yes, hi, Mark Fletcher from Healthy Heart. Two quick questions, or 2 quick points. One, it's probably obvious, but patient leaders like Kathy are incredible assets for studies like this, like Healthy Heart, and I really encourage the committee to engage patients in thinking about the actual research questions and the design at an early stage, and they will be your advocates for patient engagement, et cetera. The other is I really want to highlight what Bonnie has brought up a couple times, which are N of 1 studies. And I actually believe this is the nexus of patient engagement. Patients are so into N of 1 studies. They always think they're different than other people, and they are. And they want to learn the answer for themselves. Mobile and personal technologies, which enable N of 1 studies for a whole variety of different types of outcomes in sort of the dense time series manner that you need for N of 1 studies, and precision medicine. What's more precise than getting the answer for an individual? So,
Last audience question right there.
Okay, Andrew Kazarskas from the Mount Sinai School of Medicine. One of the questions we've dealt with in our own work is this question of bias in terms of people who volunteer for studies. And if we're talking about trying to build a national cohort of 1 million or more, I'm interested in how you think about trying to deal with that in terms of the generalizability of the results to the rest of the population. Because this is something we struggle with terribly, actually. You get people who are engaged, people like Kathy, and many others who are excited by the prospect of volunteering. Maybe they're feeling a little bit patriotic about contributing to a study. How do you try and generalize from that to the overall population? I'm thinking maybe the panel might have some wisdom on that to contribute.
I think it's also the thing that worries me about recruiting too extensively from places like 23andMe. If we only get the people that are already converted, we won't understand some of the difficulties of enrolling the people who are hesitant about going there.
Okay, I have one more question that I was supposed to ask that I have to ask, and it's got a lot of big words in it, so pay attention. All right, what procedures would you recommend to test the interface and engagement functionality, and what use outcomes should be monitored? Right, the last one before lunch. Okay, what procedures would you recommend to test the interface and engagement functionality, and what use outcomes should be monitored?
Well, I mean, there's obviously a lot of different techniques. I think that the reality is the best is if you can bring somebody in to the lab, you can watch them using it, you can have them think aloud about what they're doing, but that's a very small subset of people that you can do that with. And in some of my work with looking at gaming for things like cognitive training, we've gone toward kind of big, in the wild sort of data collection where we don't know exactly what they were thinking and what they were doing, but figuring out kind of clever ways to instrument the application so that we can get more data about what they were doing. I thought of this earlier when Rhoda was presenting, showing the trace of the movement of the pen. We've been looking at similar concepts for like instrumenting like online games, mobile apps, to try to get at a little more like maybe what their thought process was, what their interaction strategy was. So long story short, I think it ranges from very qualitative, like really rich one-on-one interactions with users to just widely disseminated, highly instrumented quantitative analysis.
One good thing is we know what most of the data look like, and that we'll know very quickly if things are not looking good, because most people stop using whatever the technology is very quickly. And so I think one of the other questions that needs to be addressed is we talk about needing to refresh and re-innovate, but I don't think we've got good data on how often, and I think that's an important empirical question.
Commenting on?
Yep. So if you're in Baltimore, come to our office. We have like a wall of TV screens. It's our own Houston control center of all the de-identified data. So I can actually see every single function in my product, and I can slice and dice who's using that function when, what med regimen they're on. Are they people on this? Are they cisgender? Are they this, whatever? So I can see all of that, and we actually use that to drive day-to-day product decisions. It's fascinating. We see people struggling with entering their meds. You make a med entry change, and all of a sudden the number of med entries the next day triples. And so you're like, okay, I did something right to affect the application. So I think, in addition to welcoming them into a room, which I think you should do anyway because it creates affinity, gives them a chance to share their ideas, you should look at the data that's coming at the granular level from your application, 1. 2, embed tools like Google Analytics into your product so I can actually tell every left turn and right turn they make in the product on an Android device versus an iPhone versus an iPad, and I can start to see that kind of engagement, and then I can correlate that and causate it back to the things I want to observe. So I think those are 2 other techniques you would use.
I'll just say really, really quick because I wanted to say a little more about that. For example, we've been taking, you might have like a simple survey, but if you have it controlled by a game mechanic rather than just clicking, you know more about like, maybe they almost answered this and then they went over here. And yes, you can kind of do this stealth data collection in different ways.
Okay, thank you, panelists, for it was fabulous. Thank you.
Well, in meeting this afternoon's panelists for session 3, I think it promises to be as exciting as the 2 panels this morning, which I found delightful, invigorating, and provocative. As I noted, I'm Spiro Manson. I'm a member of the Working Committee. And it's my pleasure to moderate this afternoon's panel, which really is broken into 2 subpanels. The overall topic focuses on variables that are thought to be measurable via mobile technologies. We've broken it into two sections. The first three presenters will share with us their experience, vision, and recommendations regarding this subject in terms of the environment. Each of them will have 10 minutes to present. We'll then follow with 20 minutes of panel discussion among you, as we did earlier this morning, and I will be certain to protect the fact that we have at least 20 minutes for the audience's participation. We'll then quickly shift to the second sub-panel, which focuses on behavioral variables thought to be measurable via mobile technologies. In the first sub-panel this afternoon, we have Dr. Michael Jarrett to my immediate right. Dr. Jarrett is a professor and chair of the Department of Environmental Health Sciences and the director for the Center for Occupational and Environmental Health at the UCLA Fielding School of Public Health. He'll be presenting on environmental data that can be collected using mHealth technologies. He'll be followed by Dr. Kevin Patrick. Dr. Patrick is a professor of family and preventive medicine at the University of California, San Diego, and an adjunct professor of public health at San Diego State University. Dr. Patrick will be presenting and focusing our attention on the collection of contextual data, examples of which include matters of location, place, and activity that can be profitably acquired using mHealth technologies. And third, Dr. Jeff Kay is a Layton Professor of Neurology and Biomedical Engineering at the Oregon Center for Aging and Technology and at the Oregon Health and Science University in the Portland VA Medical Center. I rode with Dr. Kay on the bus ride this morning, and he promised to be provocative in his remarks, and I assured him that I would be supportive in that regard. So, Dr. Jarrett, if you would begin.
Where's the clicker? Is that it?
There you go. Your timer, your slide.
Oh, I'm missing my first slide, though. No. Yeah, it's missing. That's okay. Just go back. Now, how do we get it to go? Okay.
Thank you, Dr. Jarrett. That was a lovely presentation.
Yeah. Oh, there we go. It's always funny to be at technology conferences where everybody's fumbling with the technology. Yeah. So it's really a pleasure to be here to share some of my thoughts on how we can use mHealth and mobile sensing to better assess environmental exposures. And I've been given two tasks by the organizers, and one's to tell you what's possible now with mobile technologies for assessing environmental exposures, and the second is what's likely to be possible in the next 3 years or so as the Precision Medicine Initiative rolls out. A useful heuristic concept to organize our thoughts around the exposures we might want to measure is the idea of the exposome, first coined by Christopher Wilde. And it's composed of every exposure to which an individual is subjected throughout their life course. Now, clearly this is a heuristic because we'll never be able to measure that, but I think it's a useful thing to think about what we might want to measure and some of the challenges that we might face. And he breaks it into three spheres. So the internal, we've heard about biomarkers, so metabolism, hormones. General, external, which Kevin Patrick is going to talk about, so social capital, socioeconomic position, neighborhoods. And then specific external, where we might talk about conventional environmental pollutants like air pollution, water pollution, and that sort of thing. I'm going to focus on this third realm of external exposures. And a useful organizing framework was developed by a committee I was on for the National Academy of Science. We're given the small task of plotting the future of exposure science in the 21st century. And really what exposure science is about is coming to grips with what my colleague Tom McCone at UC Berkeley calls the exposure moment. So you can see in that central box we have stressors, and stressors we could define as something that's either good or bad for you. It could be green space exposure that makes us relax. It could be air pollution exposure that affects asthma symptoms. It accumulates to an intensity in the environment to a point where it could affect the human receptor. And through the time activity prism that people live in, this can bring the stressor in contact with the receptor and produce a potentially meaningful biological dose. Now, I've just outlined some of the technologies that are typically used to assess the external exposure, so remote sensing, satellite imagery, geographic information systems, nanosensors, which we already talked about this morning, and I'll talk about in a few minutes, participatory assessment or ecological momentary assessment, geolocation, and biomonitoring. And from all of this, when we look at the exposome and this conceptual framework, the first take-home message I want to give to you is that mobile technologies will rarely be used in large cohorts as the primary means of acquiring environmental exposure data. So we need to think toward an integrated framework where we can bring together information we can get from mobile technologies with external measures of the environment to get a better assessment of the overall exposure that our participants are subjected to. And the two most critical components that we can get from cell phones or other mobile technologies are location and physical activity. And I want to give you an example from a study that recently completed in Barcelona, Spain, where we had two objectives. One was to show how we could use mobile technologies to improve exposure assessment for air pollution studies. And two, we wanted to validate whether we could get information from cell phones that was research-grade quality for physical activity and geographic location. And essentially, we used a framework where we took model data on environmental exposures. So that's what's known as a land use regression model, the top figure. We actually have this for the entire United States, so it could easily be assigned to the cohort virtually tomorrow. We take government monitoring data and we oscillate this surface up and down by the hour so that we can get a very detailed assessment of what the exposure is likely to be at any given time and any given day. Then we take the information from the smartphones, which gives us physical activity and geographic location. We have ad hoc studies from the literature that tell us penetrance factors for various microenvironments. I'm sorry, that doesn't seem to, oh, there it is. So, for example, when you're in a car or taxi, you're actually receiving a higher dose than you would be indoors because you're in the center line of the road and it concentrates the exposures. And that varies depending on what mode of transportation you're in. And then we use the physical activity data to better adjust the intake of pollutants because we can infer the breathing rate if we know the person's weight. So this is results from the initial pilot study that I'm going to show you. We do have a larger study of 180 people that we're still analyzing the data. So I'll talk later. It's big data. So we had them keep travel diaries, which are considered to be the gold standard for transportation analysis. So they mark down every time they move from one location to another. There were 3 activity measurements. So the phone with the software that we were interested in testing, the CalFit, the Actigraph, and the GlobalSat GPS, which have been widely used in many environmental studies, and body senseware, or body media senseware, another way of getting at physical activity. So this is just one day of activity of our participants showing their metabolic equivalent levels, where the darker colors are showing they're more active. And then this is the air pollution exposure that we overlay onto those points. And one thing that jumps out at you very quickly is it's a very rich data set. There's a lot of data here, but it's also very messy. Those clouds of low metabolic activity levels tend to be where people go into buildings. And if we did it now, we wouldn't really know if we'd just gone outside for lunch or if we were sitting in here because we get a lot of air from our GPS. So it's a very messy data set to deal with. But what we were able to do with this, and I just draw your attention to the circle in the bottom of your right, is to show that the respondents had about 6% of their time in transit on average, which is maybe a little lower than in America. It's about 8% here. But because people in Barcelona are walking, biking, and walking to public transit and commuting in cars, at exactly the same time the pollution goes up, this one small slice of the microenvironment accounts for 24% of their inhaled dose. So that's the kind of precision that we can bring to the exposure assessment when we have the information on location and physical activity that we wouldn't get if we didn't have the cell phones. We'd assume that everybody was a breathing machine sitting on their front step and give them all the same exposure. So how accurate is the information that we were able to get from the cell phone, from the CalFit software, which I should say was developed by my colleague Edmund Cito? And this just shows some of the GPS measurement we were able to obtain over several days. It's of high quality. These are the actigraph plots, or these are the CalFit plots showing the physical activity levels throughout 9 days. And then this is a comparison to the current gold standard that gets used in most studies, the actigraph. And you can see for light and moderate physical activity, it's virtually identical, and we have some underestimation at high levels of physical activity, which we already know how to correct. So just to summarize, we did get very valid measures of physical activity that were comparable to gold standards. The GPS data were generally of good quality, but still very messy and hard to clean. And the wear time is the one issue when you're going forward with this cohort. We only got about 3 days of good data compared to 5 days of good data with the current gold standard instruments, because a lot of people forget to charge their phones, they don't carry them all the time, whereas the other instruments are very easy to wear. So something to grapple with. The other thing too, and I don't think I realized this until I started working with the data get very big very fast. So this is just having 2 sensors sensing every 10 seconds, and we have something like 10,800,000 data points for 1 week for 180 subjects. Now, if I scale that up to the million subjects in this cohort, it's 60 billion observations per week that all have to be automated and cleaned and used. And so we're dealing with very big data very quickly. Now, what about environmental measurements with commercial apps on the phone? So the most prevalent is a noise monitor, because there is a microphone in the phone. There are many different noise metrics that can be used. And we're finding in studies in Europe that we're getting very good data out of this application. I'm not advocating for this particular application, that will correlate well with gold standard instruments. But like most people carry their cell phones in their pocket, it doesn't work very well if the microphone is not exposed. So you have wear issues again. Moves is an activity identification. I had a little animation I was going to show you from my own trip recently to Europe, but it didn't work on the computer. But suffice to say, I was being taken on a slow ride by a taxi driver, and it classified me as being in a bicycle. So there are problems there, but and the other problem too is that they're black box. So you can't really say it's replicable science just because Move says it is. This is an algorithm. They're not going to reveal that, and it's a challenge when we go to move to using these commercial apps. Now, sensor technologies are moving very fast. We have radiation, air pollution exposures, fitness levels, all being measured on externally worn instruments. And this is a pollution monitor that was part of the same study designed by my colleague at Cambridge University, Rod Jones. You can see I've just put a little quarter on top. It's still a fairly big instrument. We were able to get high quality data from the participants, so that we could classify microenvironmental exposures, but it took a tremendous amount of effort in post-processing. So we're not really there yet. We're moving toward instruments that look like this that can be put inside the home and measure many other things. And that's certainly something we want to think about, because having people wear it complicates the post-processing, because the minute I go from inside to outside, the humidity level completely changes, and it takes a long time for the sensor to recalibrate itself. So this would be under the realm of what Dr. Mega called the awearable sensors. But we are seeing the miniaturization of the sensing technology, and this is from a company just down the road in Newark, California, Spec Sensors. So this measures carbon monoxide. We've been experimenting with it in microprocessors like this, which could be worn on a lapel very easily with a Bluetooth to a cell phone. And we're getting almost nearly perfect research-grade information out of these sensors, which if they were scaled up could probably be produced for less than $100. So location and physical activity are essential for the linkage to modeled and measured environmental exposures. And we can measure those well on cell phones. And if I had to say, give me only one thing, that's what I would want. Other apps for noise, travel, and other exposures are showing a lot of promise, but we still need to do a lot to evaluate them before rolling them out. And there is always going to be this problem of the black box if it's a commercial application. And then direct microsensors, although they're not there yet, they're likely in the near term, given the very high level of activity in this technology space right now, to have breakthroughs that are still going to be useful in the time span for this cohort. both for wearable technologies and the so-called wearable technologies when they're embedded into our homes, our cars, our public transit systems. So I'd like to thank you for having me here today, and I'm really looking forward to the discussions we have over the next couple of days, and I'd like to, of course, thank all my funding agencies, and to thank you for your time. Thank you.
So it's great to be here. Dave Gustafson and I were talking this morning. This is the panel after lunch, so hopefully people are awake with luck. So again, delighted to be here as well. And in thinking about teeing up this this presentation, I never thought I would come back to this, but I started my life as a family doctor, and this article was actually published in The Lancet at the time that I was in my training, and then I went on to direct the family medicine training program at the University of Utah. But it's well worth noting, the components of disease, of sickness, are disease, illness, and predicament. And what we were taught is that people don't come to the doctor because of a disease. They come because of a predicament. They can't climb the stairs. They can't spend time with their family. They can't do things that are really valuable to them. And I think if this initiative is going to be successful, it will deal more with predicaments than it will with disease, even though, of course, we want to make sure that we're appropriate in this way. And predicament, from this article, the predicament is a complex of psychosocial issues which impinge on the individual, and space, place, and time are paramount for these. So I have the opportunity to talk a little bit about the context of the space, place, and time. So I'm going to talk about three things. I'll overlap a little bit with what Mike just talked about in terms of location tracking, but also wearable cameras and image-based tracking, and then social influences. So what about location tracking? We jumped into this space under the Gene Environment Initiative almost a decade ago. I remember writing the grant in 2006 for that particular initiative, and it was this personal activity location measurement system. And we have used over the years a variety of the types of devices that have been out there, one kind after another after another. We were the only one funded in the portfolio that was actually looking at this notion of tracking, merging GPS data with location data. Of course, now this has really exploded. There are lots of different devices out there, but I will say that if you actually want to get really good location tracking, even though you can get pretty good from the cell phone, the battery burns out pretty quickly, and it's still a limiting step to get precise data. And I think as this initiative goes forward, unless somebody solves that problem, it's going to be a challenge. And so for sub-studies that we might do within this cohort, these notion of standalone GPS trackers are really still quite good, as are the other methods by which one infers location from communication strategies and devices. So it'll be a hybrid and a blend of these kinds of things as we go along. So again, our platform fuses the physical activity data with the GPS data and can get some level of intensity. And as Mike mentioned, if you understand that intensity, you understand the level of exposure that somebody has to their environment. We can construct detailed pictures of a day, a week, longer periods of time, and get some understanding of what people might be exposed to over that period of time. And we specifically, and this I think is also of interest potentially to this community, we built this platform as a platform that many researchers can use. So as of a few weeks ago, we've had 147 users in 16 countries, data on over 16,000 participants. And imagine this, if we begin to roll up this kind of data across a variety of people in this cohort and do some of the comparison studies that Mike just alluded to. And we've also done validation of this, several validation studies where we've validated some of the strategies we use to recognize transportation patterns, to recognize location, and other sorts of things. And several papers have actually come out of this sort of first-generation PALMS. But I wanted to emphasize where we're taking this, because this was just PALMS, an activity location measurement system 1.0. The data on the left-hand side, as you can see, bringing in the data into this. Point data from a GPS device is very, very different from the sort of GIS-related data that most spatial analysts are familiar with using. And so they have to be essentially annealed or brought together. Those also have to be included with surveys and other sorts of things. You're going to hear a little later about ecological momentary assessments and other sorts of things. So these need to be brought into a geodatabase that can be used and used productively by scientists in this space. And I give a lot of credit to my colleagues, Jacqueline Kerr and Marta Jankowska, a new postdoc in our group, coming up with this conceptual framework related to how we address the data-related issues on the one hand, bring them in and fuse them to begin to understand the meaning from these data, and then push them out on the other side so that we can understand exposure through time, exposure through space, and exposure as a function of behaviors. So this is really, this is a non-trivial process, and it's a big data process in many respects. So what's the challenge here? The challenge is we've always thought about access as being, on the left-hand side, you see buffers as the crow fly, or 500 meters or 1,000 meters or whatever that people might be exposed to things. But that's actually not a good measure of exposure. A measure of exposure is where people travel through time and space. So understanding where people travel through time and space is really, really critical. And you can see the statistical and data challenges when you begin to get more and more and more granular over time, from just a few people capturing data on a weekly basis to more people capturing more data on a minute-by-minute or epic-by-epic basis. It becomes pretty compelling. And so we have, again, we're digging into this and really trying to tease out some of the methodologies that are involved in this. And this is the sort of data platform that hopefully might be informative for this particular project. Now, I also wanted to touch on wearable cameras. We haven't talked much about this. In fact, I'm not sure that I've heard anybody talk about this. But cameras are exploding in our environment. We all know this. We're all carrying them in our pockets and our phones. They're ubiquitous cameras. Costs and size is dropping. Widespread use. GoPro. Who thought a company like GoPro would explode like it did? And along with this, visual analytics are exploding. Big data revolution. There are tremendous scientists around the country and around the world that are doing a much better job assessing and dealing with these data. And you'll note here this comes from the Mobile Data to Knowledge project. This is part of this new NIH-funded initiative that Santosh Kumar is leading to look at the application of a variety of things, including visual data. We, again, our work looking at this about GPS and accelerometers, adding in, enhancing this with wearable camera data, can actually tell you what's happening in those moments. All of us who do physical activity research wonder what happens when the accelerometers go silent. What's happening with them? Well, you can augment that with an automatic capture from a camera of some sort. This comes from the SenseCam, a wearable camera that was developed by Microsoft, now owned by a different company right now. Still lots of researchers using this. But we're developing, in the context, this is the group at University of Massachusetts of the Mobile Data Technology Initiative, a low-power wearable eye tracker that tracks both forward and tracks the eye itself. Now, I know we're here in Silicon Valley. Everybody remembers the challenges with Google Glass. It didn't really work very well. Well, that was, again, a more consumer-oriented, maybe some research applications. This is actually being built for research applications that might be important to be nested in this particular initiative for particular settings. And this is going to be available within the next 2 to 4 years. The lifetime of this project, and we're already prototyping, the group at Georgia Tech and the group at Massachusetts is already prototyping, and our use cases on this relate to both smoking and relate to congestive heart failure. I think this is going to be used a bit more in the craving and smoking side. So the goal with this is to measure visual exposure through these wearable cameras. For example, identify whether a person is watching television, and not only whether they're watching and thus likely sedentary, but what are they watching? If television is bad for you, if we know television is bad for folks, why don't we then try and find out what's on TV and what might be damaging people? And that sounds silly, but with the ubiquitous screen environment that people are in, it may be important to know that in the context of this. So again, this is the group at Georgia Tech that's doing work on this, automatic recognition of this. So this, and again, this isn't a pipe dream. This will be, online at the time that this cohort is fully stood up. And then finally, social influences. I wanted to build a little bit. I think Bonnie Spring did a terrific job talking about this in terms of engagement and in terms of some of the work that she's been working on. But I wanted to focus on one particular angle of this. There are lots of examples of the use of social media at a population level to understand what's happening with, surveillance of things and Twitter analyses and whatnot to monitor infections or monitor other problems. But social media can also be used to track individual health. So if it's important to understand over time what is going on to the trajectory of health of someone, upwards or downwards, we can begin to think about using social media for particular individuals. Online talk says a lot about what people think, the availability of different content affects health, and who people are connected with affects their health. So again, this precision medicine initiative is going to be about individuals, but also the social networks, as we've talked about. who people share this information with, and how they connect with others. And this is just an example of this. This is a work that we've just completed within a 2-year intervention of college students for obesity. And we've developed a language. My PhD student, Gina Merchant, has developed a language called Healthy Active Lifestyle Language. And we're actually tracking the use of this language over time in those in the intervention group and those in the control group, and finding that there is a divergence, a positive greater use of this within the people in the intervention group, and that's a way to potentially track what's happening with folks. So monitoring social media data, we should be able to get these data as well from the people who are participating in this cohort. And I would add, we talked about the Framingham study this morning, but my colleague James Fowler just said apparently the Robert Wood Johnson Foundation has just funded them to add in Facebook data to the Framingham study. So this will be now something additional collected, and you heard this morning about what a great job that group is doing on this. We will now have Facebook data additionally to this. And when I asked James about the 1 million-person cohort, he said, that's very interesting, 1 million people. You're going to have a lot of very interesting connections between both those people that are in the cohort and people outside of the cohort. So there'll be some very interesting things to think about working through as far as analyses. So key issues, obviously, and I'm sure we'll end up talking about some of these things. We're all dealing with issues related to privacy and consent. Privacy with all 3 technologies that I've talked about today are really key. Hardly anything is more specific to you than your GPS trace during any given day, week, or month. And then others, imagine camera data or social media, those other people who may or may not be consented directly into the study. So we have to work through these things. I know there's a really good group that's working on this in this initiative. We're also working on it in our Robert Wood Johnson Foundation Health Data Exploration Project. So in conclusion, contextual data can support this initiative's efforts to improve how disease, illness, and predicament, again, we've got to pay attention to this, are addressed via targeted diagnostics and therapeutics. So thank you. I look forward to talking about this.
Thank you.
Good afternoon. So I was asked to speak about data acquired from the home, and I just want to change that to home-based data, and then I thought I might change that to home as a hub, because that's really where I think we all end up being, and I'll explain that a little bit more in a moment. But first I want to go back to our challenge, which actually Michael already looked at. That's to provide important data, or the variables that would inform the PMI. I think this really is about quantitating phenotypes, or the phenome. So this could be called the Human Phenome Project, and I'm sure some people have already thought about that. And then there's another piece to that, which I think it might be called the epiphenome, and that's the effect of the environment, treatments, exposures on this quantitative phenotype that we're trying to get at, facilitated by technologies. And the other part of this is really what's ready now, what kinds of technologies basically are there that are valid enough and robust enough to be a part. And I think the part is very important. I don't think anybody's going to have a single solution for every single million person or more. So there, getting back to what I was just saying, I think that we really have this, think of this as more of a human phenome project where we're quantitating diverse phenotypes. They have to be validated and sensitive, and I think we need to make sure that this is as difficult as the Human Genome Project was, and it's not simply putting a actigraph on a wrist and or opening up an app. And I think people realize that. So to kind of conceptualize the kinds of data, I created this graph, which is in four-dimensional concept in 2 dimensions, and it's not as complex as it looks. So on the x-axis this is actually the 4 V's. The fifth is value, but that goes somewhere else. So on the x-axis is volume going from small to large data size. On the y-axis is velocity going from frequent measurement to infrequent. And then the color scale over on the left denotes the variety of data from alike to diverse. And the size of the circle on the graph indicates the certainty of the data. And just to draw your attention to the bottom right, the red circle where the genomic data is, it's clearly considered to be large. It's not collected very frequently. It's of high potential variety, and we think it's pretty certain. On the other side of the x-axis there is demographic data, which is on the small side. It's infrequently measured. It's probably fairly alike in some ways and fairly certain. But I really want to call attention to these three boxes on the top. And these are the kinds of more continuous or more frequently captured data that is really where I think the value of the technology approaches that have been described already today and subsequently lie. So up on the upper right corner is our everyday behavior or activity data. The EF is environmental factors, data, kinds of data. And then in the small yellow circle is the ecological momentary assessment kinds of data. And these, I think, need to be considered in this space in terms of how that gets integrated overall. So with that in mind, there's obviously lots of ways of approaching data by type, frequency, certainty, method. I think we have to be careful not to fall back on the law of the hammer. So, everything, if you have a hammer, everything's a nail, or if you have a smartphone, everything's an app, or, use your analogy as you like. But really think about this conceptualization as the Internet of Things, a connected world, with less focus actually on the methods and devices and more on when, where, and how the data is going to be captured. And so with that in mind, I think that one of the organizing locuses of capture, and actually something that will facilitate integrating this data, is the home as a hub. And so the home is, as we all know, we spend 1/3 of our lives asleep, in conferences as well as at home. And, but there's other important activities such as going to the bathroom, meals, social engagement, entertainment. We have no idea quantitatively about those activities, I would suggest. And those probably have a huge impact, maybe greater than many of the things that we commonly think about, certainly in classic biomedical research. It's where you are when you're sick, if you're not in a hospital or an emergency room or Zoom care or wherever. It's consistent, focusing on the home is consistent with the current ideas about we should be bringing healthcare into the home. And I think that the populations that are driving the majority of healthcare expenditures are home anchored. So the old 5-50 issue that 5% of the population takes 50% of the resources. People with chronic disease, chronic illness, chronic pain, 100 million people. I shout out for Alzheimer's disease, which is the most expensive disease in America. These individuals are not all in nursing homes. Most are at home. And then, of course, there are those special populations whose home is not necessarily classic. The homeless, prisoners, transients, and we already heard about dormitory residents of various sorts. So what sorts of technologies could be placed in the home? So what I'm going to describe next is our approach over the last 10 years to creating a life laboratory. So this is taking the laboratory as the person's home as a laboratory and creating a scalable platform where one can be technology agnostic but collect the basic fundamental elements of data that you might need. So up in the upper left corner, we have been using passive IR sensing as well as more recently beacon or Bluetooth technology with a wearable, to collect activity by location and sleep and other kinds of ideas. Contact sensors on doors can tell you if somebody's in or out of a refrigerator or their home. Physiologic sensing will tell you something about body weight or pulse, or actually, in this case, the temperature of the bathroom, the type of environment. Med tracking is something we really need to do. We use this plastic pill box that's instrumented so that when you open the lid, it tells you the time of day. And that's a key feature of data one would hopefully want to capture. We monitor phone use in different ways. We don't listen in on phone calls. We leave that to the NSA. But it is an important measure of social activity. And then the computer itself, and computer meaning it could be a laptop, PC, tablet, is a wonderful sensing platform where you can get basic data about a person's psychomotor abilities as well as using it as a platform for experience sampling or pushing surveys more frequently than usual. Driving is actually based at home. That's where most trips are started and ended, hopefully. And so that's something also that we have been monitoring. And then finally, it's important to keep in mind that any system should be able to plug and play, because new technology comes along and new ideas about sensing things. And so this system has been designed basically to be able to plug in, based on common standard communication protocols, those new and evolving technologies. Obviously, this gets scaled out into the community and the data comes back. There are 4 principles that are difficult or important, actually, I think, in doing this kind of work. First of all, understanding the user, and the user is not just the volunteer, but it's actually the research teams that are either in the field, and we shouldn't ignore those individuals. But once you understand that problem, then we can take the technology into a smart home or smart apartment. Many universities have these. We have one. And bang on the technology to make sure it seems to work as you think it will. But ultimately, it never works as you think it will in these environments. So one really is going to need these, I would call them pods of life labs, to really understand how things work in the real world, and then to successfully scale these out. Finally, in parallel, the data analysis, aggregation, development of algorithms is not to be underestimated. I think that was already brought out by my colleagues here, and we need to work a lot on that. Just in closing, I have 3 challenges to collecting this kind of data. So first is visualization. Most of this data is coming in frequently. It's unsupervised. We need better ways to visualize the data. This is a spiral plot that just shows activity. At the top is midnight, at the bottom is noon. The successive circles going outward are weeks. And you can see that this pattern is, that this person, which is typical, is going to sleep at a typical time, getting up at a typical time, and has a typical pattern of activity. But as you follow this person over a couple of years, in the middle you see that this person has developed Parkinson's disease, and there's clearly a change pattern. And then if you look to the right, a year later, this person is treated with standard therapy, and that pattern has normalized. Second challenge is fungibility, the ability, the technologies change. You need to be able to plug and play over time. So people are still using landlines. They actually use mixed environments. They use landlines, smartphones, cell phones. And so to collect this kind of data is very important, to be able to think through that crosstalk across the technologies. And then finally, validation. So all this unsupervised activity data in particular, it tells you things that seem to be valid, have face validity. But we need to think more about how we biologically or increase the validity. And so just in this case, I'm showing a study where we showed that cognitive function declines or actually computer use declines in people with very mild cognitive impairment at home, and their MRI scans show atrophy in the medial temporal regions, which is actually the typical place where Alzheimer's disease is thought to start. So with that, I want to thank you and just remind you that technology moves quickly. On the left is the ski lift in 1956 up on Mount Hood. It took 20 minutes to get to the top, and it only ran half the time. And then on the other side is the tram, which takes 3 minutes to go from the bottom of our campus to the top. Millions of people have traveled on it. I'm probably going to jinx things, but it seems to never break down. Thank you.
Well, thank each of you for such informative presentations. I'm now going to jumpstart our conversation by playing Ed McMahon to your Johnny Carson Carnac. And by that I mean, I'd like you to, exactly, think ahead 3 to 5 years from now, when there's been assembled a cohort of 1 million or more individuals through this particular initiative. Which technologies do you think now, and what you would project forward in the next 3 years, are best suited for assessing environmental factors that are thought presently to be critical to increasing risk of the onset of a particular disease, disorder, related condition. And I'm interested in how you see those in aligning. And so what's the sweet spot from what you now know and think will be the case as it may apply to particular conditions? And as importantly, once you make that commitment, I would be interested in you sharing the logical path by which you got there.
Well, I was just going to say that there was a phrase you used about, which people. I think that the issue that's really important is we really need to talk about what are the outcomes you're trying to capture. And that really has to drive the kinds of technologies that you're going to use or not use. So if it's, we heard some wonderful presentations this morning looking at what would college-aged kids, do. That's very different than what a population of people with Alzheimer's would do. I do think that there's some fundamental things that were actually brought up. Michael started out with, I think that activity and location are probably the most fundamental and currently the most fungible quantities that we can look at, whether you're using because the accelerometer is an accelerometer is accelerometer. And so in that sense, I think that's probably the shorter term type of sensing that will be done. But ultimately, it's interesting that we spend so much time in this conference talking about engagement. Actually, I think we don't want to engage at some level. In other words, we want to be able, for some kinds of studies, not interventions, but some just regular studies of understanding human activity, health, and behavior, to have things always in the background, like driving your car. So the car is a computer that's collecting amazing amounts of data that's available to us when we want it, or when your mechanic wants it, or your insurance company, right, if you agree to that. So that's one paradigm, but I think if you're trying to do an intervention, active intervention that involves the technology itself, that's another use case, and so I'll stop there.
Yeah, I would second this notion of activity, and I think, again, a decade ago when we were talking about measuring activity in the context of space, no one dreamed that we would have millions of people using sort of research-grade accelerometers. We just completed a validation study of the Fitbit Charge HR. I actually just submitted the paper on this, and it's as valid as the state-of-the-art accelerometers for measuring sleep in young people, and so that's a critical thing. And when you have this ubiquitous presence of these sorts of consumer-grade technologies, that's going to help. So I think that's a big part of the pathway. And again, when you know activity, you know a lot of other things related to exposure. But I also, and I'm going to tee up Michael, we're not as far along on the assessment of some of these environmental stressors in terms of highly portable, highly low-cost types of devices. It's just going to take a few more years. I think we're going to get there within a few more years, but we're not, at least in our research, we're not there now at the way we'd like to. So I think, and again, I'll pass it to Michael, it's a smaller subset where we will be experimenting with the methods by which we'll do this with clunkier technologies, if you will, to then vector that into the larger cohort as time goes by.
Well, I really liked the comments of my colleagues, and I think that the idea of the home as a hub is a good one, because there are instruments that we can deploy now that are quite inexpensive, that we can get high quality information on environmental conditions for a place that most people spend about 70% of their time. And that's considerably less complicated to do than trying to measure on the person as they're moving. So if we do know where they are, and we know that with some certainty, and then we know the exposures that they're facing in their home for air pollution, for example, for electromagnetic radiation, potentially for noise. These are factors that can really greatly inform our environmental exposures. Now, if we look out in, say, 3 or more years, certainly with all the activity that's going on, I think that we will have wearable sensors for air pollution, for noise, that are quite miniaturized. we may also want to start looking at how you analyze data that comes in very periodically as people pull cell phones in and out of their pockets, because there's a lot of information that can be gleaned there. I didn't show the slide about all the different sensors that are on the cell phone, but they have accelerometers, as we've talked about. They have GPS, but they also have gyroscopes, they have microphones, they have light sensors. So all of those can be used, and it's going to be a matter of thinking about the analytics that we need when we capture very short moments of time. And then we're quickly moving, not necessarily for health reasons, but for personal interest, to an era where we're going to have a lot of embedded sensors. And whether that happens in the next 3 years or 5, I'm working on a project now that's funded by NIH in the Imperial Valley, where we're embedding 40 air pollution sensors around the community, with the participants asking us to put them out in places where they don't trust the government monitoring. That type of embeddedness, I think Google is now trying to jump on that bandwagon and embed in cars, embed in public transit, and embed throughout areas around the city. And that has the advantage that we get ongoing continuous information. So again, if we know the location of the people and we have high resolution measurements of environmental data for things that we know matter, temperature, light, air pollution, noise, all of those electromagnetic radiation, we can rapidly assign that. And it's going to be, I think, something that's going to evolve. But the big challenge that I've seen so far is that we really don't have, and I'm heartened to see all the people from the private sector here, but we don't have those kinds of collaborations yet where the private sector is actually sharing data with researchers that they can use on a regular basis. And I think that's one of the challenges that this initiative needs to confront, because there's no way that academics can compete with the resources of Google's and Intel's. But with collaborations, there could also be mutual benefits for Intel in getting new ways of analyzing and thinking about their data, or Google. But for the researchers, they're getting mass information on movements through cell phones and things like that. And Google and other companies like that have already done much more research than Kevin and I can muster, even if we're well-resourced, on how to clean data, how to deal with these gigantic data, and they have the backbone and the infrastructure. So we need to foster those collaborations, and I hope that's something that will come out of this initiative.
Yeah, and one final thing, I did want to emphasize this notion, assuming that we're successful in the shared governance and in handling the voluntary contribution of data, and there's been a lot of discussion about this, I know there was at the first meeting, and we can get people comfortable with this notion that we will value these data and handle them with the greatest level of respect. The signals that we can detect from contributed social media data, from contributed other sorts of data that people can provide us, will be very, very important. They'll be that we can discern the signals in those data about what's happening with folks related to what might be making them sick or what might be affecting them in some way. And so I think it's an and both here, but I think that's a really, really critical. So the group here that's dealing with consent and with understanding the meaning of this for being a participant, being one of the first groups of people participating, can't be more important for the kinds of data that we're talking about because of the level of sensitivity that they have.
Well, Michael, stunning the one slide that you showed with respect to the GPSing location, and you can't help but come away with being struck by the mass of the data. And it sounds like we're addressing the data management, analytic, and computational challenges of this, notwithstanding the complexities. Where are we at in translating the findings, the observations, into meaningful terms for participants, patients, and providers so that it can inform decision-making? How do we think about that? Jeff, I think that's also true with respect to the massive data that your life labs probably are acquiring.
So I don't want to make excuses, but I think actually that much of this is the science of this activity is actually quite early. It's, when the human genome was sequenced, there was an amazing potential, but it's only now that we're actually understanding where that potential is. Some of the things that we think are very important is the power of these kinds of data collection applied, for example, to clinical trials, where there's this massive backlog of potential treatments, and the methodologies for clinical trials are still using the same methodology that James Lund used in 1774 to look at sailors treated with scurvy. I'm overstating that a little bit, but really we could actually do trials faster with smaller sample sizes if we apply these kinds of technologies. So I think that we will begin to see more and more of those applications. I think there's a lot of public health opportunities for the environmental sensing that we are going to see very soon. But I still think it's actually relatively early in the science of this kind of data.
Totally agree, and I think this is where this initiative has this opportunity to crosswalk with the other new initiative, the Big Data to Knowledge initiative. I mentioned the mobile data to knowledge. There's several more years of that to be done, and again, my most interesting meetings these days now are with data scientists who are helping us think through how to deal with multi-level, multi-scale, the temporality, the different sorts of aspects of these data. And it's again, that's a good way to say it. That we're in the early stages of this, developing new methods. The other thing I'd point out is opening this up. So one thing we're doing with an NSF project is trying not us coming up with the answers, but we're just trying to sort of create a buffet, if you will, of the kinds of data that are available, and then making it more available to many, many people, be they citizen scientists or people like us or nonprofit organizations who have an interest in this, so that it's in effect crowdsourced. So it's in effect getting everybody working on this project, and that's quite doable. But again, it's only doable within at least for my sense in this precision medicine cohort, if we're able to gain the trust of the participants to then open as much. And there'll be a distribution. Some people will be happy giving everything, some people only this but not that. But that's good. Let's not let the perfect drive out the good on this. But I think that's what's exciting, is getting this openness to this, to have other folks working on it.
Well, I think ideally we want to be able to convey the information to the individuals, especially about environmental exposures, in a way that it informs their everyday lives, so that they have a tremendous incentive to stay committed to the project and to the cohort, because they're gaining access to better information when they want to go out for a jog. They can know where the pollution is. They're gaining better access to where they should put their children in school because they don't want to be by a highly polluted area. Those types of issues are very tricky, because the data that comes out of the sensors is, as I showed, it's quite messy and it's quite uncertain. So I think the science of how we communicate this imperfect data to people on an ongoing basis, that hopefully could be through their cell phones. And I've been involved in a European Union initiative that is called CitySense. So its whole intent is to look at how you can use all of these technologies to empower citizens to better know the environmental and other risks they're facing in their daily lives. And that's certainly the biggest question that we've come up against, is how to convey the information that's potentially useful to them without unduly alarming them. And this is something that, and living in Los Angeles, there are going to be days where we're above government standard for air pollution. What do we tell the participants? You curtail your normal activities. And if you look at the types of indices that have been developed by traditional government agencies, they're not very clear on what to do and how you should respond to that information. So when you get more of this information and it's en masse and it's all very uncertain, this is an area of research that we really need to work on to try to better convey those uncertain data about risks to our participants. And I agree with my colleagues that we're still sort of grappling with that. But I do hope that we can have some studies that are part of this initiative and others that are going to be of the size and quality of the ones that I've been engaged in the European Union, because I don't just go over there because I like the social climate or like spending 15 hours on a plane. I'm going there because they're doing work that is not being done right now in North America. And that's something that we need to think about as we go forward in this cohort, how we can play some catch up, because they've invested a lot in characterizing the exposome, characterizing citizen science, and that same level of investment has not been forthcoming yet, with all due respect to all the other great investments that have been made at NIH.
Thank you. Candor is appreciated. Let's open it up to the committee members in the audience.
So that was really terrific. I'm impressed that thinking about environmental exposure, one of the major areas that we don't seem to have a good handle on is diet. And everybody believes that variation in diet has tremendous impact both on our risk of obesity and many of the attendant diseases that result from that. We certainly have a handle, I'm convinced, on being able to measure activity, and it would seem that if we had a grasp on a good way to passively measure diet without requiring people to write down everything that they eat. Even N. Haynes only tries to get that, I gather, for 2 consecutive days, and even that is recognized as not being very useful, or very complete. I'm wondering your thoughts, particularly thinking about some of the camera technology, Jeff, that you mentioned, what the prospects are for passive measures of diet.
Well, so first of all, cameras are tricky, particularly in the home space. So in most surveys of populations about attitudes and beliefs about different kinds of technology to bring into the home, direct visualization is not favored, except under very special circumstances. So most people don't want a camera in their bedroom or their bathroom, even if you tell them that, oh, we're just going to look at decomposed images. It's still not great. So I think that that kind of visualization may not be, at least currently, the way to go. I do think, however, that there are ways to inch toward getting better data about eating activities. So I wouldn't call it that we have diet, but certainly, I didn't have time to show this, but you can do thermal sensing in a kitchen and get a fairly good fingerprint of how much time a person is engaged in relevant activities in preparing a meal and eating a meal. There are other kinds of sensors that can give you that kind of information. It doesn't get to what I think you may be wanting, the elemental composition of the person's diet and how well it's absorbed in their bloodstream. But in fact, one could consider that there are point-of-care kinds of technologies where one could obtain many analytes in the blood at home, and I think those will develop. And so, actually measuring nutrients on a regular basis in a home environment has a lot of potential, and we probably will see something like that.
Yeah, the projects looking at dietary measurement were part of this portfolio that our group was funded in, and I think they had the hardest time, this notion of diet. I mean, everybody knows that it's very difficult, and in fact, 3 of them were focused on image-based assessment of food and working through the issues and obscuring data in the background. So this is going to continue to be a challenge. I've sort of come to the conclusion that it's going to be a set of things ranging from some of the, I like this notion of the types of activities, eating at bedtime, overeating, other things which might be inferred from wearable sensors and from other kinds of things just by virtue of how long your eating episodes are, what time you might be doing this, that don't require an actual nutrient intake. But then there'll be community level things. We all know the terrific work that's being done with respect to community availability of foods. Again, some of the work that we're looking at related to precise locations of where people might go. Are they not in fast food joints, or are they not in healthy food locations? And then additional data at a macro level with respect to purchases and other things. So I think there'll be some mathematical. I kind of support what Anand was talking about earlier this morning. Some of the mathematical solutions to this will get richer and richer to the extent that we have more data to feed into them, and we give them to some really bright mathematicians and say, we want to work this out. So our models are going to get better. We're going to be able to understand this better from this variety of data sources.
Hi, thank you very much. From the discussion about the importance of the home, should we, as looking at the more than 1 million people going forwards, be looking at family units as opposed to individuals?
Yeah, I think that's a very good analysis. It's very difficult to define the families. I've been involved, though, in several studies where we've looked at, parent-child pairs, and that's been very informative because you can then look at the interplay between, say, physical activity when the parent's there and not there, and start to understand some of the social dynamics, indirectly at least. So yeah, I would say that's probably, now there are many families that don't live in the same home, so that raises other challenges. But in terms of social support as well and potential contacts, that's certainly a good unit to think about.
It was just happened to have just been in a meeting this last week with one of our local epidemiologists, Tina Chambers, and also another one, Andrea LaCroix, another epidemiologist. And we were crosswalking what this initiative might become with the new lifespan challenge that's also coming out of the CTSAs and others. And actually, I've not heard us talk about this, but not only potentially families, but test beds, but in places. And I think you had a picture of homes, and it doesn't have to be every home. It just has to be enough homes where you might have everybody in that home participate in some way so that you're getting an understanding. And again, we're all talking about the anchoring of these data to place. It is really critical to anchor data to place where people are at home, where they work, where they travel. Southern California, where the most toxic place is along a freeway, and if people spend 45 minutes each way going to and from work, you don't want to listen to exposure biologists tell you what's in the air on freeways in Southern California. It's scary. So this notion... yeah. So I believe that there should be some very serious discussion of at least a few place-based test bed types of environments where, in fact, we look at the concentrated micro environments of families. Again, we talked about social networks and by affinity groups or others, and that's important. But again, the tightest social network is really the family, for good or for worse, depending upon what happens within those families. And so I think some serious consideration needs to be given to some methodologies that would allow us to do that, because that would then tease out some very interesting dynamics related not only within family, but again, I restate, place-based research. Because if we just enroll people and don't pay attention over time to where they've lived for a long period of time, we will miss a great opportunity.
Just want to quickly make the comment that there's lots of research that has shown that the health outcomes of an individual person is highly determined by the person who's helping them. And the health of that person helping them is at much greater risk of declining by themselves. And so that interaction is very underexplored and probably has a huge impact for discovery and understanding about the basic trajectories of change with illness.
So I have a very practical question, and it's sort of a tech support question, but it's real. A number of you have talked about the platform, and Jeff, you spoke about it. For us imagining scaling to 1 million people, there's this continuum of, hey, we with NIH, with industry, builds out a platform that is the study platform, and it's the, I don't know, to make an extreme, the lockdown set of capabilities we're putting into the home at any one point in time, and a specific cell phone. And on the other end of the continuum is BYOD, anything goes. Practically, when you guys are doing your studies today, help us know what is the quote-unquote platform and that balance between BYOD device and stuff that can be controlled, where you can control the security and the privacy and maybe get more valid measures. What's that balance, and what do you think we ought to be aiming for?
So I think that the balance is that initially you want to actually have things a little bit more proscribed and controlled. And so you obviously have to give up something for that. But I think that the sweet spot, hopefully, is I look at it as the communication protocols are actually standardized. So whether it's Bluetooth, cellular, Wi-Fi, Zigbee, X10, those all have standards. And so as long as the platform allows you to plug those communication standards into a network, a home network, and bring that data out, I think that's the level of thinking about a platform. And what I've seen is it isn't very hard, even for us highly underfunded academic researchers, to take a commercial scale or device, as long as it has those standards, reverse hack it and get the data out. So if we can do that, I think that with the support, the wonderful support of Intel and Google, that platform could be scaled out quite easily. And one other quick comment I want to make is that there is this, and we've done this and others have, this concept of, for better or worse, sensors in a box. So the ability, and there's some commercial products now that have gone this way, although I'm not sure how effective they are, but the idea that you could actually mail somebody a box of sensors, color-coded, this goes in your bedroom and it connects together is very doable. It's doable for it actually per house. It's about the same as a $1,000 to $5,000 genome. The same amount of money, you could get that data as well.
I think that's a great question. And again, having been involved the last several years in one NSF and two NIH-funded projects where we built essentially data capture, data processing, and visualization types of stuff, we've essentially controlled this on our own. When we started, we weren't using cloud-based services. Now Amazon, I mean, we have the ability, and so this is terrific because we even have the San Diego Supercomputer Center in our backyard, but they can satisfy some of our needs and others they can't. But I'm now in a position of challenging our software developers to saying, why are we developing all of these in different ways? Why don't we develop some sort of a unified approach? We don't really have an answer. I mean, this is, that's just the way it happens in again, underfunded academic areas. But I think that's a critical question, and I think we're going to have to probably strike this balance of entrepreneurial activities that allow things to happen in highly creative ways that we can't yet anticipate, coupled with getting some sense of pulling together the variety of activities that are happening so that we get much more into standards, comparability, data sharing approaches, and whatnot. I think there's a session tomorrow morning. Ida Sim is going to be talking about this, some others on a panel. But terrific question, and I think part of it is engaging researchers like us to think about what the requirements for that will be.
Shrika?
Thank you. I want to go back to the issue of measuring nutrition or diet, because this session has two parts. One is on behavior, which is what I think most of the answers were about. But there is also an international effort to measure what's available. And there's a lot of digital data from food companies and supermarkets about what's available. So some of that information is being used to evaluate food company adherence to their pledges to change what's there. But I think that there is a private sector issue with getting that information. But I would love to hear your ideas about how we can actually measure the equivalent of air quality in terms of, in what day do we get, or in what location do we get to the point where we're over the top with people being able to make a healthy choice?
Another really good question. I've worked with the Environmental Science Research Institute, so Esri's geospatial business analyst, and they do have marketing data that's highly resolved and gives you a very good assessment of the types of consumer patterns that you're seeing. And you can see some of the areas of the city where clearly there are preferences for more vegetables or they're not eating dairy. But the problem is that the information is coming in units that we can't compare to any census data. So we cannot, or to our cohorts, it's coming in strange marketing units that they use called tapestries that are meant to segment the market, but they're not very useful for doing health research. So that information can potentially be incredibly powerful, and when I've looked at it, the spatial patterns that I see are very consistent with what we might expect, where people of lower socioeconomic status are eating more sugar, more fats, less vegetables. Oftentimes, falling in line with our prior hypothesis and what we know from specific studies, but we've not been given access to the data at a highly resolved level so that we can do these, as Kevin's been calling them, place-based studies, so that we can really understand and link it to the cohort in a meaningful way.
But I was talking about not what the people in those communities are eating, but what is in those communities to choose from, which is a different a different issue because of the marketing pattern. So maybe Kevin.
Well, this is what they're buying, so it's not, it's something in between eating and.
It's different because the marketing is
access.
targeted to those communities, so you can't tell from that.
Yeah, so Sharika, it's an excellent question, and I tried to allude to that when I was saying, we had an initiative with the Vons data, for example. Vons, for a period of time, offered up all Safeway, the Safeway data, so terabytes of data, and we were able to look at this across a big community. I think they called it the Blue Sky Initiative. Bob Kaplan was my department chair at that time, and there were some studies looking at trans fats and other things. So if there is a way to get to the large food distribution companies, and I would say we have an opportunity to smile and lean a lot and really encourage them that it's in the public interest to potentially make these data available in one way or another. That's what I meant if we add that in, and also some of the fine work that Jim Salas and Barry Popkin and other people have been doing related to understanding the data. I think, again, we can begin to extrapolate and get a better understanding about what might be available in certain communities, and that's an overlay. It's much the same as any other environmental characteristic overlay, that then one uses that layer to make some inferences about other things. But I would hope that that would become part of this over time, that these would be additional forms of sort of background data that we could bring to bear and nest our questions about precision medicine in.
We have 5 minutes left, so I want to try and get in 3 questions. We can.
Building upon the previous comment regarding things that are hard to do right now that maybe shouldn't be, what do you wish that is currently considered innovative, stuff that you're working hard on in multiple research labs, but really should be a commodity? And if we have Intel, Samsung, BD2K, what do we need to do from an infrastructure perspective? The example I would use is, Richard, myself, and Josh are always wishing we could do patient linking easier, get access to Medicare data. That's the refrain of the EHR guys. So what is it from the location or mobile guys? What is the one thing that we need to not make proprietary and just focus our energy that would enable innovation as opposed to commodity work?
Sorry, so I just want to make sure that I'm understanding your question. So what would be the most innovative private sector contribution that?
What is the thing you're spending energy on that you wish you didn't have to spend energy on? And lots of other people are spending energy on it. They're like, this is easy if we just get these guys to agree. Just buy it, make it free, and you could actually focus your energy on the innovative stuff then. What's the distraction right now?
Well, a big distraction is the processing of the huge data and trying to align that so that you're able to tell indoor versus outdoor activities. You're able to, if somebody's walking down a densely populated city street in San Francisco, you're able to see that they're not jumping inside the Wells Fargo building and jumping out every 10 seconds. So that takes a tremendous amount of time, and I was just advising on a study in Paris last week where they basically are trying to get very high quality information on people's commuting patterns, and they've decided that the only way they can legitimately do it is to have people go in and manually correct the data. And you're talking about 4 or 5 person years of data over the next 3 years to just have somebody sitting there doing an incredibly tedious task. So if that could be solved so that we could get the level of information that you see on Google Maps out of our health data, that would be a big step forward.
2 more questions, 1 and then 2. We'll see about 3.
So as a clinical researcher, and even worse, according to Jeffrey, I guess, as one of those Neanderthal clinical trialists, this response actually is sort of preempting my question, but just 3 points, and I'm interested in your reaction to this. I mean, hearing this and everything else today, it's like I'm imagining the biggest garbage dump in the world with just all kinds of trash and garbage and stuff in it that you can't sort out as to what needs to be recycled and what needs to be sent elsewhere or burned or whatever you want to do with it. There are holes in the data. Every precept of drawing inferences from clinical research seems to be violated by the problems that you guys are alluding to: biased samples, missing data, incorrect data. Even worse, or maybe better, most people, when they hear precision medicine, they are thinking we're just not observing things. We're actually going to give them advice about what to do, which means that we have to understand causal inference and also realize that over half of observational observations turn out to be the inverse of what the answer is when you do an intervention, because the confounding and all the biases that are so hard to pick up. And then you all have been lamenting the underfunded academic and saying that we can't really analyze our own data. We got to depend on Google and Intel to do it. So, and then finally you say 5 years to clean up one little piece of data. We're talking about curation and data janitorship as the most important thing. So if you're looking at the million-person study and expected advice to people, what's the way out of the box? We can't just collect a bunch of garbage and hope for good things to happen, can we?
It's always the FDA guy. It's always the FDA guy.
Coming from Oregon, where we recycle everything, I actually think that as bad as we might have given you the impression that the data is, it's orders of magnitude better than the self-report data that's sparsely collected and totally unverifiable often. And so I think that really the first step is probably to focus on smaller, not every million person will be doing the same thing, but probably having smaller cohorts that have the full metal jacket of the kinds of things that we can do, and then moving those out into the larger cohorts over time. I actually think that clinical trials, which hasn't been a cohort that's talked about, is a perfect cohort, a set of cohorts. Thousands of people are enrolled every day into clinical trials. They make commitments for years on end. There's a lot of structure to those, to the crappy old-fashioned data even. So I think that those are the first opportunities, and I hope we didn't overstate our. I'm actually quite optimistic.
Yeah, I guess.
Michael, you've got 15 seconds.
Well, I thought we were talking about the advances, but I guess we emphasized the negative. But I would say that the other thing that you can do with this type of cohort is you can focus on natural interventions. So when new parks are put in, when the environment changes, and you are tracking individuals over time, and you can see a very abrupt change in the exposure, that offers us the opportunity that's not an exact clinical trial, but something that's going to approach that. So if we have the high-quality data, we can then move forward with those types of comparisons that are going to get rid of a lot of the bias and confounding that you're mentioning are typical in observational studies.
Thank you. I know you've been waiting so patiently, but can you think about wedging in your question into the next sub-panel? That would be great. I promise I'll come to you first. Thank you, gentlemen, very much. If we can have the next three presenters.
Somebody's phone.
Dr. Burton, Dr. Campbell, and Dr. Stone.
Thank you. Thank you.
Thank you. Let's move it on down. We can make it a little more intimate than that. I know. Well, they had mine wrong, so. Although our previous subpanel inevitably found its way into discussing behavior and in a number of occasions person-environment interactions, this particular subpanel has been charged with focusing specifically on behavior. And again, with the same task of providing insights into those aspects of behavior that are deemed most measurable presently by mobile technologies. We have three speakers again. Dr. Imre Erten, who is a research associate professor in the Department of Electrical and Computer Engineering, an investigator in the Davis Heart and Lung Research Institute at Ohio State University. He'll be presenting on wearable physiologic sensors. We're joined as well by Dr. Andrew Campbell. Dr. Campbell is a professor of computer science and co-director of the DartNets lab at Dartmouth College. And Dr. Campbell will be presenting on passive measurements of behavior using mHealth technologies. And Dr. Arthur Stone, who's a professor of psychology and the director of the Dornsiff Center for Self-Report Science at the University of Southern California. And he'll be presenting on self-reported data using ML technologies. We'll use the same format. Please.
And the clicker is?
Should be right there.
This one?
Green, yes.
Okay, thank you. I also like to thank the organizers for inviting me and enabling me to be part of this exciting workshop. So I'm going to be talking about the wearable sensors for measuring physiology or mobile health, as it says here. Okay, so we are all here because we believe if we can measure physiology of subjects into their daily life routine, then we can understand the root causes of complex disease and risky behavior, and hopefully enable large-scale research. So we all want our sensors to provide clinically relevant, validated measures, but at the same time, we don't want our cohort to stick out in the general population, like the one on the left. As the subject of this is physiological sensing in the context of behavioral sensing, perhaps it's good to understand what we mean by that. So the idea of behavioral sensing from physiology is if we can observe physiology, the different facets of physiology of subjects by surrounding them with different wearable sensors, then perhaps we can see the underlying processes of psychosocial processes that really derives that physiology. So on the left, we see all sorts of cardiorespiratory measures that we collect from a subject together with activity measures. And then on the top, the green is the activation of the ANS system that relates to the stress. So we can see in this particular lab study, we can see that we can process all the physiology to provide a signal that is at least correlates with stress, which is on the left. And as I said, we don't want our subjects to stick out in the general population, which means our wearable sensors are much have to be required to obey much stricter restrictions on power, size, weight, as compared to the traditional sensors in the daily life. So, of course, with those restrictions comes the limitations of those sensors and the data they provide. So the autonomous nervous system modulates several biological processes. And now we have essentially a sensor that looks into each of these biological processes with a wearable sensor. So specifically, we have cardiorespiratory monitors, motion activity, as people talked about, galvanic skin response, EEG, spirometry for respiratory analysis, temperature sensors for seeing the thermoregulatory system. And we also have ability to analyze like glucose, lactate in a form factor that goes to wireless sensing. And for the most part, these sensors are just the traditional sensors put into the compact framework of wireless sensing. So, and together with the limitations that comes with that. So this is how I see the mobile health or wearable sensor landscape. So we have sensors that provide specific information about specific pathways, like the cardiorespiratory system or EEG, but they are somewhat dorky. And then we have on the right sensors that sort of blends into the life routine, but as a result, provide generic information about motion and some heart rate information and things like that. So in order to be successful in this effort, we need to move in the direction of the arrow and provide sensors that provide both specific information about specific pathways as well as blends into the daily life routine. So we all agree here that we want to have the sensors to provide clinically relevant, validated information about physiological and psychosocial processes, with giving some contextual clues that the previous panel talked about, so that we can correlate these confounders from our sensor data. So these sensors have to be minimal burden so that we can have large-scale, even voluntary adoption of these sensors. And they need to be continuously monitoring. So we can't really have sensors that comes out, once in a while, because the event of interest might happen anytime in the time. So if you are looking for stress research, the stress event can come any time in your daily life. So they have to be robust, and I'm going to go back to this factor. So they have to have predictable performance in the field. And we hope that these sensors are not just, engineers dreaming it in the lab, but they are informed by the physiology, biology, psychology, actually rooted in science. So as I said, most of the sensors we were looking were just taking the traditional sensor and putting them into a compact wireless form factor. We have some now new modalities that are especially suited for mobile sensing or wearable sensing. So one is we are all embedded in wireless signals right here. So I looked up, there were at least 25 hotspots in the field. So we are certainly bombarded wireless sensing, wireless signals. But we are really, and these signals really penetrate into our bodies and reflect and actually provide information about how our body functions. So on the left is a sensor that is close to my heart. No, really, it's actually showing my picture of my heart. From wireless sensing, wireless sensor that we developed that can monitor cardiorespiratory rhythm, so both the lung and heart motion, which can be, again, linked to contactless sensing. And on the right, we have soft electronics, which is basically understanding that our bodies are not flat surfaces, so why our sensors are so flat. So trying to see how we can do body, skin-conforming sensors that blends organic materials with electronics. So most of them are from science, different issues of science, and then we have the contact lens sensor developed by a local company here. We understand that, yes, these sensors are coming in the next 5 years, perhaps can make an impact, but we need to, before we can, use these sensors, we need to assess their accuracy, specificity, and how they link to the outcomes that we care. And just to understand the challenges of doing that before we, adopt these sensors, I'm going to switch to sensors that are much more well-developed, cardio monitors, and try to sort of highlight some things that are different. So not every heart sensor is the same, is basically the same message of this. So when we look at cardio monitoring, people are used to look at the EKG waveform, and when you say heart rate, it's basically how peak-to-peak changes across time. So when we have now sensors that are built into reflectance PPG type sensors that are built into Apple's iWatch and Microsoft Band, what they are measuring at this point is an average across 1 minute, which is, perhaps giving you a heart rate information and your activity, but doesn't give you, for example, heart rate variability, which is the peak-to-peak variations of that distance. So, and to see why, we can see on the right 3 signals. So the black is the EKG. The blue and the red are actually 2 PPG sensors that are mounted on the wristband of the same person. So first of all, the first thing we realize is look at the time resolution, the peak of the EKG versus the information you are going to get from this kind of wearable sensors. So, and this is nothing to do with, a particular company's sensor. This is about the process. One is about polarization of the heart and how that electricity shows in your sensor. The other is the blood flow, which is inherently a slow process. So, which means no matter, how well these guys make the actual lenses, etc., they are going to be, our ability to do the beat detection will be on the order of 20 milliseconds versus the 1 millisecond of EKG. So when you are taking that sensor and saying, I have a heart rate sensor, not all heart rate sensors are created equally. Second, of course, EKG gives you different projections of the heart on different planes, and that's why it's so useful in assessing cardiac health, whereas PPG is a 1D signal, which is not about electricity of the heart even. So we have to keep that into mind. And we also see that these sensors were mounted on the same person at the same time. And we see even the two sensors at the same location, left, right, wrist, has variability. And which means the data that will come out of them will have that variability, and we need to deal with that. Similarly, let's step to motion sensing. Simplest job, counting steps on treadmill. Then we have seen different sensors that are apps on the mobile phone, and then variable sensors, and on the right bottom, three pedometers. And we can see how variable that even simple information reveals itself across these platforms. So, moreover, the accelerometer, gyroscope, magnetometer that are built into these sensors enable fine-grained motion analysis, and we can recognize gestures relating to smoking, eating, oral health behavior, like how many times do you brush, how many times do you floss every day. So, and we were talking about how camera can be intrusive, and think about somebody tracking every hand movement of your daily life. I'll leave that picture with you. So, we have to understand that sensors are just a small part of the big picture. You know, the sensor doesn't stop with the raw signals. We need to. People talked about using data cleaning, dropouts, etc. But there is more processes about that. We need to model the data from the physiological process and link it back to the outcome that we are trying to measure. So this requires both doing subject-level models, personalized, as well as population-level models, so that we understand the physiological process that we are trying to measure versus the raw data we get from the sensor. One more remark is basically, when we talk about behavioral inferences, what the sensors are providing is completely different from what we are trying to measure. For example, to get a smoking puff, detection of smoking puff, we need to analyze the respiration together with the wrist motion to understand when exactly you smoking puff. There is no actual physical smoking puff sensor. So there is a good way of work to be done in modeling and doing machine learning algorithms to link the sensor data to the behavioral inferences. So to summarize, I'm a little bit over time. So variable sensors have to account a lot of variability between individuals, between devices, and between you mount these devices on people. Sensor placement, body composition, the geometry affects how these sensors functions. And to make a sensor is not about giving you the raw data. The successful sensor design requires standardized measures from the highly variable outputs of these raw data. So this requires you to do real-time personalization of the sensor so that it can adapt to you, so that the outcome of the sensor is always standardized across subjects, but the input is different because you are different. So hopefully we will be able to use the data we collect over time to enable continuous improvement of the sensor parameters itself, as well as our interpretation of that data. Thank you.
As Dr. Campbell is approaching the podium, I'd like to point out on your first slide that the depiction of Captain Picard from Star Trek and his transformation to a Borg was among the most highly emulated roles in the recent National Comic-Con convention. So you could be on a real style wave here.
Resistance is futile.
Well, good afternoon. I hope you've all had enough caffeine to keep going. If not, there's plenty over there. So, great. Cookies are coming too. So great pleasure to be here, like everyone else, and have a chance to talk to the committee and the broader audience. And I was asked to talk about passive measurements of behavior. And I'm going to particularly focus in on a student cohort, a student body. And I'm going to talk about what are the capabilities of the smartphone by itself in the background to do passive sensing. So I'm not going to talk about all these gee whiz great wearable devices that are happening, because clearly we are in the wearable era, but I want to talk about what you can specifically do with a smartphone in terms of behavioral inferencing. So think back to your college days. That might have been yesterday or quite a few years ago. But college is typically about going to class, studying, dealing with friends and families, and deadlines, right? And in my case, perhaps partying a little too much. Students' concerns, as Bonnie was talking about this morning, students are concerned about, well, they're concerned about grades, they're concerned about their professional development, relationships, roommates. At the bottom of the line is typically health issues, but also financial issues, cultural issues, safety issues on our campuses. These are sort of the concerns of students today. So college life is complex. So what happens, see if this works. So what happens if life throws you a googly? And by googly, I don't mean one of these, which is not bad actually if this is thrown at you with a lot of research money. But actually what I mean is cricket. And think of cricket. Cricket's like baseball, but much more fun. and we hold the bat down here and not up here. So a googly actually is a certain type of ball delivered by a right-hand bowler, and it has a really deceptive bounce that's devastating for the batsman. Typically the batsman's out. And this is a picture of my brother Edward, who was a great cricketer and a computer science guy. And life threw him a googly when he was a freshman at Durham University 30 years ago, and when he had his first depressive episode and he dropped out of college. And he subsequently was diagnosed with bipolar disorder and really had a difficult life because of that illness. And it got me thinking 30 years later, you know, Ed was really into technology 30 years ago. What would our millenniums do today that are so obsessed with screens and technologies? Could sensors and smartphones not only sense their behaviors, not only predict future behaviors and illnesses or onsets or relapse of various illnesses, but intervention? So things that you're familiar with today. And you can't open a paper. Doesn't that sound so antiquated? Open a paper. Then read headlines like this. More college freshmen report having felt depressed. And again, Bonnie talked about, today in the New York Times, about the rise of suicide on the college campuses. And here, you know, it talks about those who felt overwhelmed by schoolwork and other commitments rose to 34% from 27%. And if you read what's happening in the popular press, there seems to be a rise of anxiety, depression, and suicide on our campuses. So this is a serious issue, of course. At Dartmouth College, where I'm from, which is in Hanover, New Hampshire, actually doesn't look like this anymore. It actually is beautiful, and people are walking around with smiles on their faces. But last year, the statistics were 11% of Dartmouth students were diagnosed with depression in 2014. 12% reported depression having impact on academic performance. And really what surprised me, this last one, 28% have seen a mental health counsellor over the last year. And as a faculty in teaching these kids and looking at them in the classroom or walking by them around the campus and thinking, 1 in 3, that's you know, it's pretty high. And of course, what I claim is faculty, and I can only talk about faculty because there's many stakeholders in student health, of course, on campus, but most faculty are really unaware of what their students are struggling with beyond grades. And at Dartmouth, we're a little bit more friendly than Professor Snape there. But we really don't know what's going on. And so to actually get under the hood and try to find out what's going on, I did a small study where n equals 48, terribly small, but I would argue the data is very deep. It's over a 10-week term in spring, and we put a smartphone application on all these students' phones, and we collected a lot of continuous sensing data, or passive sensing data, as well as some EMA and some mental health surveys. And the cohort was 10 female students, 38 male students. They were CS students, so the data's probably biased. Results are probably biased. 30 undergraduates, 18 graduate students, 23 Caucasians, 23 Asians, and 2 African Americans. So a small group. So let me tell you about the technology we used. We put this application called the Student Life app on their phones, and what are the types of behaviors that we could infer just from a simple smartphone? So no fancy devices. You have to excuse me if I slip into any sort of loose clinical description here. I'm a computer scientist. But what could we infer? Well, activity. You can infer sitting, walking, standing, running. That's embedded in the operating system now of all smartphones, pretty much. 5 years ago, you had to roll your own classifier. We did for this particular study, but it's in the operating system. We also can infer fairly accurately face-to-face conversations, their duration and their frequency. So we're not talking here about listening in on people's telephone calls, using the 4 mics that are on the phone to actually infer conversational data around a person. And one of the early panelists said, oh, if your phone's in your pocket, you know, you can't use the microphone. That's not true. Put the microphone in your pocket or in your bag. Microphones are incredibly powerful sensors. Here we're not recording data, we're just inferring speech is present. Surprisingly, without actually ever using an alarm clock on the phone, adding any or interacting with the phone, your phone knows how long you sleep. By just using sensors such as the accelerometer, the light sensor, the sound sensor, and the lock and lock, plus or minus 30 minutes, without you ever touching it or telling the phone anything. A bit of black magic there, but it can do it fairly accurately. We also can infer whether a student is studying or not. And not only if they're studying, but if they're studying, are they focused while they're studying? And here we use a combination of location, sound, and activity to infer this automatically on the phone. And similarly, we can infer partying. At Dartmouth College, believe it or not, all the parties are in the Greek houses. So we use similar sort of techniques, location, sound, and activity, to infer partying. We collected all this data over 10 weeks, and really important to me, I made this data publicly available. It's anonymized data, and it's on the web, and people have already started using it for their own research to discover things that we never looked at. What sort of behavioral trends could we pick up from this data? Well, my colleague Dave Coates standing over there will look at this, and this will be burnt into his brain, because this is the timetable at Dartmouth. The phone automatically determines whether the student, what their class attendance is, because it knows their location, it can cluster it, and these are actually the various slots from Monday through Friday over the day for the whole term. The lighter it is, the cohort are more likely to be in those, more of the students are in those slots. The darker it is, the fewer students are in those slots. So the common thing with this particular study was common to all the students was one class, and then they took other classes from 18 different departments. This is all their sleep data across the whole 10 weeks. Some students went to bed before 12, early to bed. Most students went to bed between 12 and 3 o'clock, and then we had a bunch of vampires at the other end of the scale down there. I'm going to show you some quick-fire slides. They're all going to have the 10 weeks across the x-axis of the study. They're all going to have the midterm period, and this is the sleep data. What's not shown on here, actually, what is not shown on here is there is actually a workload that rises up, comes along here, and drops down, because this was a keynote slide on my Mac, which has not played nicely when converted to PowerPoint. But imagine there's a workload curve there as well. Well, students come back from spring break. They don't really sleep very much for the first week. They get some sleep, and then their sleep drops off through the midterm period. They get some sleep again, and it plummets during finals. Here's some for me, this is a really interesting slide. So this, the top slide, the top curve here has, don't know if this is going to work. No, but the top curve here has the duration of their conversations, and this curve here has the frequency. So when they come back from spring break, they have fewer, longer conversations, which I can only think of being 2 minutes. That only can imagine being sort of social conversations. But as we go into the midterm period, it flips over, where they're having more shorter conversations, which are more business-like, maybe stressed-out styles of conversation. And then it picks up towards the end, where they're having longer, more social conversations. They do physical activity until the midterm, and it stops. This is EMA data. They come back from spring break. The top curve is affect, positive affect, feeling really good about themselves and not stressed, the bottom curve. By the end of term, they're highly stressed and feeling terrible about themselves. This is class attendance, which is fortunately the curve is not there, so I won't embarrass myself. They go to the gym till midterm and stop going. When do students party and when do students study? This curve shows you that Wednesday night is the big party night. This is automatically inferred from sensors on the phone. No EMAs, no self-reports. So Wednesday's the big night to party, which used to be Friday night when I went to university. Friday and Saturday are big nights to study, to party. Over here, you'll notice that on Monday, Tuesday, and Wednesday, those are the biggest nights for studying before the party week starts. So I know I'm sort of running out of time here. Here's one serious mental health result. We found correlations between this automatic sensing data and PHQ-9 depression scale. And nothing surprising here, but those students who slept less, had fewer conversations during the day and the evening period, and were around fewer people, were more likely to be depressed. But again, what's cool about this is automatic sensing data on your phone that is being correlated with PHQ-9 depression scale. Why are these results important? Because 24/7 sensing is here now. It wasn't here a year or two ago. Why is it important? Because we found significant correlations between passive sensing data and gold standard validated surveys. And I'm going to get kicked off now. Where's it going in the future? The phone will be able to predict GPA. We can do that already between 1700ths of a grade point in work we've done. It will be able to predict depression and different mood disorders. It will be able to build personalized relapse models so we can do intervention. So what's going to happen in the future if life throws you a googly? Mobile will detect it, and mobile will deflect it. Thank you.
Oh, they do. Pleasure to be here today and chat with you about the slightly maligned self-report. I'm going to argue. Thank you, Jeff. I'm going to argue today that actually self-report is tremendously important for this initiative, and it's important that we do it as precisely as we can. The way I thought about this talk was that instead of presenting you some studies from our center, we do lots of work validating self-reports and developing new ways of measuring self-report. I thought I'd try to give you more of a conceptual overview, trying to make the case that self-reports are critical for this initiative, and doing it well is critical. So with that said, though self-report sounds kind of dry, it's not a real exciting, sexy kind of topic, but I want you to take a look at what they are. Self-reports include patient-reported outcomes in healthcare settings. These are critical to the medical environment. Medical and social histories for medical trials, opinions about all manners of topic. I mean, these are self-reports. As well as more traditional psychologic status, whether a person's depressed or optimistic, whatever. These are the realm of self-report is incredibly broad, and that's one message. But why should this PMI effort collect self-reports? Well, there are internal states that we simply have no other way at this point of getting at. So you see there, we have pain, stress, fatigue, anxiety, craving, motivational states. We don't have sensors for these things. And as a matter of fact, we need to measure these things with self-reports if we want to develop sensors which will try to approximate them. Actually, I think the last talk showed you that. You know, there was EMA in there. EMA is self-report. And we need that in order to figure out what's going on with our sensor data, frankly. But I think there's also some unique things that we simply can't capture without going to self-report. For observable states, here are things, I put a bunch of symptoms there, asthma attacks, coughing, consumption, drink, food, medication, exercise, lifestyle. Now, these are in theory observable things, sure, but no one does that, usually, because it's too hard. So we ask people. The point here is that, well, let me finish this and then let me make a point. For environmental characteristics such as where people are, what they're doing, who they're with, social support, and for observable exposures, and then we collect sociodemographic information from people. I want to point out that we use this data in most scientific trials, even if the focus is on genetics or physiology, we use this information, collect this information in most human trials. It's imperative that we do it as well as we can because in my last point on the slide I say self-reports are subject to various biases and errors, and that's absolutely true. There are lots of things that we as creative humans have evolved to be able to do in order to make ourselves feel better, in order to make ourselves view the past in particular ways. We have limited capacity, so don't ask me how my pain has been over the last month, because frankly, I can give you some rough approximation of that, and that'll have a signal to it, but it won't be that good. And we need to be precise here in what we do with self-reports, and that's where a lot of our effort goes. So why, the way that we try to get at self-reports in a more precise way is by going and doing real-time collection of data or near real-time. And what I mean by near real-time, I mean end-of-day diaries, for example, where we ask for a relatively small reporting period that day, and we collect that at the end of the day. And we've done studies validating end-of-day reports with many momentary reports throughout the day. I'm not going to go into those. So we need real-time, near real-time reports in order to increase measurement precision. Then we need it to provide much greater insight into people's experiences. This is what's important to people, how they're feeling. And if you ask folks about their pain for the last month, that is a very gross way of understanding their pain experience or any other symptom experience that they have. We need to be more into people's natural environments, following them as they go through life, experiencing what they experience. Now, the other thing about real-time and near real-time is that it allows new associations to be discovered that simply cannot be discovered without high-resolution data. So, for example, we can look EMA, ecological momentary assessment studies, very often study people in a very dense way, relatively dense way, 10, 12 times a day for many, many days, sometimes many, many weeks. And from these studies, we can put together patterns, and we can use particular kinds of sampling routines in order to understand people's trait-like feelings and experiences, as well as by targeting certain aspects of their day when certain events have happened, so that we can understand things like resolution of an event or response to a medication. These have already been used in examining gene and environment interactions, where we know, for example, that people with different genetic loadings have differential reactions to momentarily measured stressors, small things that occur to people throughout the day. How should we do this? This is largely about mobile technology. That's great. We can use mobile technologies to do end-of-day diaries. I'm going to argue in a minute that end-of-day diaries may be especially a good way to go for a long-term intensive study like the PMI initiative. Or we can go to within-day capture, EMA, and we can get very high resolution, but the burden is much higher as well. So there's going to be, as we've heard already, there's going to be a balance between burden and resolution or intensity of data collection. And that's something we've played around with a lot, and I can tell you more about that offline. And then there are actually ways of doing micro-experiments. If you program your devices that are collecting EMA data appropriately, and you use the various kinds of random sampling, event-driven sampling, and time-driven sampling, you can do lots of different things, as has been done in the smoking research area, for example. There are decisions and challenges in collecting self-reports in this initiative in particular. The platform will matter. I just have to emphasize, as some others have, we've heard about usability, user-friendliness. That's incredibly important for a long-term endeavor like this. Much work needs to be done on how to make this work for people over long periods of time. I'm not going to talk about connectivity right now, but that may matter too, depending on the kinds of self-reports you want, the kind of branching routines, the kind of feedback you want. I think that there are some things to be learned, some lessons to be learned from the literature on EMA, which now is 20-something years old. And that, in thinking about a recommendation for this initiative, it was sort of hard to think about it because I don't know, nor does anyone else know, exactly the kind of questions that we want to answer. And usually when you're structuring a study like this, you think about the questions and then you back into the design. That's pretty hard to do. So I think that the committee is going to have to think more about what are the most critical questions and at least design a protocol to get at those, because you're not going to be able to do continuous monitoring for 50 years. I don't think, anyway. Another challenge, but I think it's an exciting challenge, and it goes into we can learn new things. If you collect dense self-reports, you can summarize experiences in ways that may be much more meaningful to people than what we currently do. Asking people about their average pain over the week is one way to learn about their experience. However, there are many others. The pharmaceutical industry has started to take this up and is getting a bit more savvy about this. But we right now have a project going that is trying to understand what kinds of ways of summarizing dense information are most meaningful to patients and are most sensitive to the medications and treatments that we give them. Not only that, what kinds of ways of summarizing data are most of interest to regulators like FDA and EMA or to other folks. For example, the insurance agents, not agents, but the insurance industry. And that's something that we haven't paid enough attention to. Finally, in my last 20 seconds, I'm going to advocate that you consider an intensive burst design for collecting some of this kind of data. This is coming out of the lifespan literature. A burst design is where you know you're going to be tracking people longitudinally over a period of time, but you decide that you're going to do, for example, 1 week of intensive measurement or 2 days of intensive measurement at preset times. And this is being done in the longitudinal, like I say, the lifespan area. However, I think that there's actually a trickier way to do it, and we're trying to implement this at USC right now, where what I call sentinel event monitoring, where you do a loose tracking of what's going on in people's lives. Say, for example, on a weekly basis, and you use that to trigger some of your bursts, so that you're following people at times when interesting things are happening in their lives or when they're anticipating interesting things happening, like retirement, like an illness, like a death of a spouse or close person, things that could impact health. So in sum, thanks for your attention, and I really do think that mobile self-report capture, it has a lot of challenges, but I think it would add much to the PMI effort. Thanks.
Thank you all. As the working group has been struggling with the first order of business, and that is the underlying principles by which to formulate this cohort of 1 million people or more, it's been debating about the relative priorities of investing in the acquisition of that cohort and, if you will, sort of minimal data set. My question is this. I'm impressed by the previous panel's observations, the last question of them, and I think many of the observations you shared here specific to behavioral dynamics echo some of the earlier cautions about the perhaps premature nature of data acquisition at a large-scale basis. So is it fair, convince me otherwise, if you will, that we can set aside in the assembly of the cohort an immediate concern with the acquisition of data by mobile technologies of this nature, that we can think about that as the immediate next several stages of inquiry as the cohort is assembled and as the questions of the day emerge? Or what are the other options?
Okay, that's let me unpack that question. It's a great question. Can we trust existing research and advances in sensing going forward? Is it valid enough to use, or is all this sensing just good enough for consumer sports sort of applications? My feeling is that I can only really talk about my own space in terms of like smartphone sensing, and so I think it was Kevin talked about the trust of a Fitbit in comparison to a clinical grade accelerometer. I'd be interested to ask him what does he think about, the top of the line smartphones in terms of their accelerometer or inertial sensors. My feeling is that if you just take one thing that I feel fairly confident about, 5 years ago, we were, like many others, were building classifiers, doing machine learning, programming in phones to do activity recognition, which had quite high performance in terms of their accuracy, 80, 90% accuracy. Along came Apple and Google, and they embedded those classifiers into their phones, into the operating systems of the phones, basically now collecting hundreds of millions of accelerometer data and inferencing to actually evolve their software on their phones to be of high grade. So I would claim that those classifiers for doing activity on smartphones are probably rock solid, great to build something on. So similarly, if you can imagine going forward looking at other types of behaviors, like I'm particularly interested in, a Fitbit for the mind or a Fitbit for the brain, whatever you want to call it, trying to infer psychological states. And I agree with Arthur that you do need EMA or self-report to get to many of those internal states. But if we could get an automatic sensor that Google could put in Android to automatically infer stress and anxiety and depression, then that would be super going forward. So I think we're not there, of course. Now, is the lifespan of this particular PMI 5 years, 10 years? If it's 5 years, I very much doubt that a validated set of psychological sensors will be embedded in any operating system put on the phones. But in 10 years, I think there will be. And people like Ginger.io who are here would probably have a voice in that as well, like the commercial side, not just the academic research side.
Let me just add one concern to this. Coming from the momentary data capture field, we're very concerned about using the principle of random sampling throughout the day in order to try to understand in an unbiased way what people are doing. To the degree that sensors are being used in a self-selected way under certain conditions, when people are in pain, when people are not in pain, I start worrying about how valid the data is in characterizing them generally. Now, maybe for continuous monitoring, that may not be an issue. But a lot of the devices that we talk about sample, and we let people sample when they want to sample, and that, I think, can be fraught with dangers. So I think it's just something that we want to keep in mind. Same thing goes with social media data. Same deal. When do people tweet? When do they do Google searches?
Yeah. So just picking up the, accelerometry, clinical grade versus what is in our phones, what's in our wristbands. So there is literally a handful, less than, fingers of a hand, companies that makes the actual semiconductor sensor that measures these devices. So if the clinical grades have, some leg up, it's about the calibration. It's about, having that form factor being used repeatedly over time. So obviously, all the variable sensors that we will have will match the quality in terms of raw data, and we are going to catch up and, exceed clinical grade accelerometry because of the huge data that will be generated by it and our ability to calibrate. So now coming out of accelerometry, we all understand that variable sensing puts limitations, having 12 lead, 2 lead, no lead PPG type of sensors. And I try to highlight, yes, there is going to be validated information, but it's going to be shortcomings due to the physics behind the sensor. Not as much as we want to work with it, it's going to have those limitations. And I think it's important to understand those. And as an engineer, I don't tell people, show me how it works. I say, show me how it fails, because that's what it really defines how it can be extended to different populations. So I think in terms of our ability to capture raw data, we are there. In terms of linking to physiology, we have some way to go.
Let's open it up to the general audience in the committee. Please.
Arthur, this is coming to you, and it's around...
Could you use your microphone for the phone, please?
Sure. So this question is around the self-reporting. How do you think about demographics? And you talked a lot about utility and ease of use. When you start to have different levels of education or just the type of knowledge around even normal phones, smartphones. I'm just curious how you're thinking about incorporating that.
With the question being, can people of various demographics actually do this? Generally, that's been a positive picture. Surprisingly, older folks do very well with some of the smartphones in the EMA applications anyway, and I imagine with the other sensors. So most demographic groups do okay, but I think you're absolutely right in the sense, too, that collecting data in real time is not for everyone. It doesn't work so well for surgeons and bus drivers, for example. So that's when you have to start thinking about who is the population, where am I going to get the most coverage, and that's where you can go to an end-of-day diary, and there are actually new variations of end-of-day diaries that I didn't talk about. There's something called the day reconstruction method, which is a way of combining time use information. That's how people spend their time, and that's a field that's been around for 40 years. Parsing the day into episodes, and then finding out, once people have reinstantiated, got that back into memory, what's happened during those segments. And right now, we came up with the DRM about 10 years ago, and there's something like 1,400 citations of people using this at this point. I think this could be done. It's being done in some of the large-scale NIH studies, variations of it, for example, in the health and retirement study, as well as by the WHO and OECD.
Thank you. Hello. So I just wanted to make a brief comment of an issue that has been raised actually by both panels, which is measuring diet, which is an issue that we have given a lot of thought in Nurses Health Study 3. So to put it in a nutshell, so what we have decided that the best current solution for that is to try to incorporate into mobile technologies existing versions of dietary assessment tools. Because, and the other thing that we have come to realize is that there's two elements of diet that we could separate in using MMHealth. One is the composition of diet, in which the current best solution we think is to adapt existing methods into mobile platforms. And the other domain is the diet behavior. When do you eat? Why are you eating at specific times and at specific places as opposed to others? And for that, we're actually much closer to getting a very good passive assessment using EMA, using built-in phone sensors, than we are to getting to the actual composition of diet, which is a much more complex question that I don't know when are we going to get there. Hopefully soon, but it's definitely not ready for prime time today, and will probably not be ready for prime time within the next 3 to 5 years. Maybe I'm wrong. One thing that we have tried is to go outside our comfort zone as far as trying to find solutions. So we are organizing an event that we're calling a hackathon, where we're inviting programmers and hackers from all over the country to try to address the questions that we haven't been able to solve in this, to address precisely these questions regarding diet behavior. Now, the other point that I wanted to comment on briefly is this concept that has been touched by both panels regarding that not necessarily everybody in a cohort this size is going to be using sensors, but everybody is going to be either answering questionnaires or is going to be having an app or some other thing. But the sensors who gets what sensor at one time may vary during the cohort at any one time. And one of the things, we don't think this is necessarily a disadvantage. And actually, one potential application that we have seen for this type of different ways of collecting data is to create measurement error correction models. So you may end up getting much higher quality data with sensors in a subgroup of the population, but that doesn't necessarily mean that all is lost with the rest of your study population, as you can use the data that's collected across the cohort to validate and to create measurement error corrections for the larger group of people.
Make one comment since I'm sitting here. I really think, and it's not my field, so don't get discouraged if you're working in this field. I think people reporting what they're eating repetitively by entering data is not going to work. And I think, because I just think it's tedious unless they're really, really interested in their diet. The general population or of a cohort this big wouldn't be interested, I think, unless you can really automate it. I mean, I think the future of behavioral sensing is all about the passive nature of it, the zero cost to the user. So I think what we can do here, though, there is some light at the end of the tunnel. I think clearly computer vision technology is the way to go about collecting dietary information over the long term. And computer vision isn't there right now to be able to do that in a robust, reliable way. People are working on it, and maybe if Google really worked on it, they could solve it, because again, just because of the massive amounts of data they could collect. But I think the future is an automated way using cameras and computer vision in solving that problem, and not people entering information.
Thank you. Richard?
To what extent is it known how consistent the interpretation of various kinds of measurements is across populations? Does a pattern of measurements that reflects stress in one group of people mean stress in another group of people, or partying, or a whole variety of things? So just wondering if the PMI is going to adopt some of these, does it need to be attentive to other characteristics of the individuals who are being monitored?
You said stress has about 47 meanings. If you're talking about self-reported stress, the area of psychometrics has developed really to fairly good science, and this is one of the main questions. Do different groups of demographically defined folks, or by any group status, do they answer items in exactly the same way? So there's something called differential item function, which is, do these items respond to groups in, as I said, exactly the same ways? But there are other issues. We currently are under an NIA grant. We are currently trying to figure out whether people self-report about their pain and their fatigue, their well-being, and their general health, global health, in the same way when they're older, younger, or middle-aged, just to make groups out of it, because we think that people may use different ways of comparing themselves to the world at different ages. So these are questions that are being examined. How it works with the sensor data, I don't know. But it's a great question, and it's something that needs to be resolved.
How does it work with the sensor data?
So maybe I can just talk. So as I was trying to allude to, how to do the stress measurement through physiology is about seeing how the body autonomous nervous system activates regarding the negative effect associated with stress. So that part is going to work across the population. But how that activation is actually perceived into stress, that's a personalized process. The fact that I might be a person that's an adrenaline junkie, and I might not perceive that activation and form it into stress. So that the personalized differences can only be, I feel, resolved through simultaneous EMAs, etc., to see how that physiology goes to the perception of stress, and which is a very complex question.
Well, this takes us back to Kevin Patrick's earlier observation about the importance of the movement from disease, illness to predicament, and the significance attached to individual experiences vary enormously by these kinds of factors, and how we can get our arms around that in some comparable ways, the challenge I think you're articulating. Please.
Back to the mental health thing, which I think is, particularly the Dartmouth, a great opportunity for getting in early and doing something, even if you can't pinpoint by Android or whatever exactly and predict. Can you just put a sort of threshold on sleeping behaviour, say, and pick people and say, oh, your sleep's dipping down, just like a mother. You need more sleep to stay happy, or you need to go to the gym more, or whatever. So can we do that sort of thing and do it sooner? And then the second point is, I guess, Schrodinger's cat, which I'll throw out, the act of measuring and changing what you're then looking at. And we've heard a lot today from the participant groups. People want to do N of ones, they want to see changes, but as researchers, how are we going to actually stop things changing long enough so that we can compare to all the people out there who aren't in the study?
So here's a straw man. I think, first of all, if you're interested in what phone to use in this cohort, it shouldn't be an iPhone. There's a strong word for you. Because, not that I'm sponsored by Google, but because but I actually am sponsored by them, but that's another thing. Because, so here's the thing, that it's not a continuous sensing device. It won't allow you to run continuous sensing passively on an iPhone. With the research kit, it seems they're opening up a bit there. But I'd say Android is a great environment for doing sort of continuous sensing, passive sensing, and maybe the iPhone will be. I know there's a phone from Microsoft as well, but we won't talk about that. In terms of the question about what's feasible in terms of getting to psychological states, whether it's physical stress or psychological stress or mood disorders. What we did in our tiny little study, and of course I can't claim with just 48, where n equals 48, that's generalized out, or computer science students at an Ivy League university would sort of generalize out across the country to different colleges, different types of colleges. But my feeling is that we found sort of significant correlations with passive sensing data. We don't fully understand why that is the case, but we found it for perceived stress scale, for PHQ-9, for flourishing, and for loneliness against those, gold standard surveys. So the question is, if we could repeat that at very different universities and other people could do that and find similar sort of results, it would build up a confidence, at least, that passive sensing measures from smartphones could be used for not only sort of physical health, but also psychological health. And the next step beyond that, and I think it's probably beyond the cohort, is to take those correlations and to take the understanding of those signals and build predictive models to predict, something like the questioner just said, like to come up with something that's fairly simple, or reasonably challenging, which is to predict something like a PHQ-9 depression scale from the sensing data. Beyond that, then you're getting into the domain of how do you actually do personalization for an n equals 1, which I still think we don't really fully understand. So I see sort of a roadmap to actually getting to a point where one day we might have a validated psychological sensor, probably running on an Android phone today.
Arthur, you have the last word. Be pithy and wise.
Well, the person's gone. I thought the person was also asking about reactive arrangements. That is the act of measuring people going to change what's going on? Because EMA has been around for quite some time, people have asked us that question. We're hitting you 10, 12 times a day. What does that do does that change how you report? And it turns out there is so far, in about 4 or 5 studies, very, very little evidence that things change over time, at least over a several-week period. That's a bit surprising, but that's what the data is saying. We designed one study to look at that in particular and saw no change in level or variability or relationships among variables that were being measured at the moment, which is the best that we could figure out to do to get at this reactivity issue.
Thank you. Please join me in thanking all panelists this afternoon. We'll now be taking a 15-minute break. We'll have Dr. Collins announce its reassembly in quarter after, please.
The first speaker is going to be Gary Bennett, and the way I'll do this is I'll introduce each of them, and I'll speak for 4 minutes, and then I'll allow each one of them to speak. So Dr. Bennett is the Bishop McDermott Family Practitioner of Psychology, Global Health and Medicine, and Director of Duke Digital Health Science at Duke University. Then we have Dr. Donna Sprujits-Metz, who's the Director of USC M-Health Collaboratory at the Center of Economic and Social Research at the Keck School of Medicine in USC. And then we have Dr. David Gustafson, who's the director of the Center for Health Enhancement Systems and Studies at the University of Wisconsin. Each of them will present briefly. The goal will be to be concise and have audience participation. So I'll begin. So with my slides, there have been tremendous advances, and the goal here for us is to make sure that those advances are accessible to the vast majority of Americans. And as you know, the demographics of the United States are changing dramatically. As of today, currently 40% of the U.S. population identifies as non-European in origin. The vast majority of children born today are of non-European background. And this is actually very important. This is the tax base that funds the National Institutes of Health. And these have real implications because when you look at common diseases like asthma, and my slides are not working, so there you go. There you go. Those are the demographics of the United States. Very important because when you have common diseases like asthma, when you see the prevalence of asthma, it varies dramatically by race and ethnicity. And it's easy to argue that perhaps this is a sampling bias, but it's hard to argue when you look at death rates. You see it, again, highest in African Americans and Puerto Rican populations and lowest in Hispanic Mexican populations, but the vast majority of research has focused in on Caucasian populations. The federal government has recognized this and has created some initiatives. In 1980, we started the Women's Health Initiative, and then in 1993, Congress required the Revitalization Act to focus on the inclusion of ethnically and diverse populations as well as women and minority populations. So one of the questions that we've asked is, how have we done? And in the last 10 years, since the completion of the Human Genome Project, we've made tremendous advances in science. Tremendous. In fact, more genes have been identified in the last 10 years than probably all the history of medicine combined. But we've made some shortfalls. And here's an example of where we made a shortfall. This is a publication that we published in 2011. Just looking at how many non-European populations have been included in modern genetic studies. And this is a travesty. The data speaks for itself. And that's what we want to get right on this initiative going forward. We want to make sure that we don't repeat mistakes of the past. I know everyone knows this well, the idea of food deserts. Everyone knows that well, and I don't need to speak to that, but what we've created, in a sense, are scientific deserts. And when we have scientific deserts, we don't understand the biology of how disease operates in different populations. And so we have scientific deserts plus health deserts. It leads to health disparities, and that's what we're trying to prevent here today. So without that, and this is really important, because when we have data like these, and this data is a package insert for one of the most commonly used asthma medications in the world, Advair, which is a combined inhaler. And if you read closely the package insert, which most of us throw away, and I brought it here just in case you want to see it. This is a map that none of us reads, but if you read this map carefully, it actually specifically says this, and this is problematic. And this is why I think it's important for us to understand the biology of how drugs operate in different populations. So without further ado, I'm going to turn it over to the next speaker, because we need to address how do we get PMI, precision medicine, out to the community? How do we address everybody? How do we make sure that our technologies are not only applicable to people in Silicon Valley, but also to Appalachia and low SES and high SES communities with like? So with that, I'm going to introduce Dr. Gary Bennett and have him speak. Thank you.
All right, well, good afternoon. It's my great pleasure to be here today. This is a really fun conversation for me. I've been coding and tinkering for most of my life, and it's exciting to be in this room with so many nerds. Let me start out by saying that I run a research center at Duke, where we too are very interested in leveraging all of the excitement around new mobile devices and sensors and the like, but we're particularly interested in their application in places like this and like this. And we are predominantly interested at Duke Digital Health in trying to understand ways that we can utilize mobile health technologies to try to remediate health disparities. I've been doing this work just long enough, since the early days of 2000 and 2001, when if you propose this kind of thing, reviewers would say, yeah, but poor people don't really use computers. was a real comment that we heard pretty frequently. We've come a long way, and so it's extremely exciting to be able to talk about really going after 1 million people and allowing mobile devices to be a major part of that effort. So in looking at some of the videos from some of the talks at the previous workshops and thinking a little bit about what the agenda was today, I just tried to, I grabbed a couple of questions that I think are probably of most interest. How can we engage diverse groups? Is that possible using mobile health technologies? If we do that, what biases might we introduce? And how might we mitigate those biases, either through use of technology, sampling, and the like? I'm going to be talking, I think, at maybe a level a little bit upstream from the conversations that I've heard this afternoon. I'm really going to be talking about data acquisition. How do we get the data in? I would love to talk about the challenges of sampling, but we're going to talk about how you get the data into these data sets. And I think the first, just to do a little level setting, medically vulnerable populations, those are racial ethnic minorities, those who are socioeconomically disadvantaged, those who live in rural settings, are both connected and disconnected. We have both of those things happening at the same time, and they present a host of challenges when you're trying to do this work. So we've heard a lot about the 64% of the population who own smartphones, and of course that masks a lot of variability within that metric. It's the case that more blacks and Hispanics own smartphones than do whites in the United States. But if you look at this by income, the situation's actually a little bit different. Before I get there, let me just say that one of the things that's most interesting, if you remember the digital divide from the early 2000s, you thought about disparities, racial disparities predominantly in connections to broadband pipes and in access to computing technologies. And today we have some new divides that are, I think, mostly a function of the fact that racial ethnic minorities are disproportionately more likely to use technology. And that is that they're actually using the advanced digital data features of their mobile phones. And so if you look at this list of activities, all of these are disproportionately more likely for blacks and Hispanics relative to whites. And if you look at some of the social media sites that many of us spend our time on, these too are disproportionately black and Latino in some cases. And so this provides an untapped opportunity to reach populations that we've been calling hard to reach for more than a generation. But it's also the case that if you look at income and education, we see a somewhat different pattern. So somewhat less likelihood to own smartphones for those at the lowest ends of the socioeconomic spectrum. And of course, this is going to complicate our efforts to try to roll these technologies out to the million. I want to highlight this group of 19% who are smartphone dependent. These are populations who utilize a smartphone predominantly but don't have access to other types of broadband pipes in their lives. These folks are disproportionately racial and ethnic minority. They tend to be low income and have low education. And this would seem like a major opportunity. This would seem to boost the likelihood of being able to use mobile phones in a large population. The problem is that their access is actually quite tenuous. And if you've done work in this area, you realize the cancellations of service, the degree to which folks have exceeded their data caps makes this a real challenge to roll out in a very pragmatic way. So it's both a challenge and an opportunity. And then we have the 10 to 20% of the population writ large who are disconnected, depending on how you look at the numbers. Disconnection is more prevalent among blacks, Hispanics, and those in lower education and income groups. So we have a host of challenges here, but I think there's some opportunities there as well. And our question really is, how do we engage the medically vulnerable with mobile health? And I'm bullish on this as a possibility. So let me walk you through some of the principles that have emerged from our work and work from others. A lot of this, I think, dovetails with what other things you've heard. But the first point I think I want to make is that there's been a lot of discussion about smartphones, and I think one of the things that we realized very early on in this work is that we're still at a point where smartphone penetration has just not reached the level that makes widespread dissemination of interventions in my case really feasible and really able to reach into the medically vulnerable. And but it is the case that 91% of us still have a mobile phone. And most frequent activities, whether you're talking about mobile phones, so those are feature phones or smartphones, are texting and voice calls. We can smarten texting and smarten voice calls to do a lot of the kind of self-report assessments that Art was talking about just a moment ago. And that's really where I think we've hit our sweet spot in using technology to reach the medically vulnerable. There's been a lot of discussion about this issue of both precision and how we might reduce measurement complexity, so I won't spend a lot of time on this. But I will just illustrate just very quickly, this is a key point in reaching the medically vulnerable. There is a temptation, if you're like me, to try to ask people as much as you possibly can, to hook as many sensors on someone as you possibly can, particularly in the context of intervention, where we can then use those data in providing high-quality treatments. The problem is, and this is a real example, this is a nutrition label, of course, but this is also a survey. This is a health literacy and numeracy survey that's widely used in primary care. We use this in our studies. And we ask questions like this. Take a look at this nutrition label and tell me, if you ate the entire container of ice cream, how many calories would you consume? The answer is 1,000. Most of you got that. I'll tell you that when we give this in our samples, so I work almost exclusively in the primary care setting, most often in community health centers. Just about everybody's in poverty, high levels, racial, ethnic minority. I work in rural settings. We've worked in urban settings. The most frequent response is no response. People will stare. They will push it back. They'll look at it. They'll push it around the table a little bit. We've had several people cry. We like math. I like numbers. Real people don't. And I think one of the challenges that we've encountered is that you have to be very, very careful when asking even things that seem very, very simple in populations that have had difficulty in the education system. So what we do is that we've designed a somewhat different approach, and we have people sit down at a computer terminal, they fill out a short survey, we run their data. I'm going to breeze through this, so forgive me if you have questions, I'll tell you later. We take their responses, we throw it into the cloud, we run it against algorithms that then go into a large library of behavioral goals, and we spit out 4 behavioral goals that we want people to focus on. The name of the game in obesity treatment, which is where I do most of my work, is in long-term engagement. You have to figure out a way to develop an intervention that people will use for long enough to derive clinical benefit. And we see the best benefit when people are steadily engaged and self-monitoring over a long period of time. So we give people these very simple, common sense, easy to understand goals and ask them to self-monitor them, in contrast to asking them to monitor all their calories. We then give them technologies like these that we've developed in our group, a wide range of different technologies to do this, and we ask them to go off and self-monitor. You can see an example of one of our text messaging technologies here. And again, these are simple. So instead of asking you to count all your calories or to list all the foods that you've eaten or to take a picture of it, we just say, how many sugary drinks did you have yesterday? That's an extremely face-valid question for people, particularly after a year and a half in treatment. And they can respond in a very dichotomous way, very simply using text messaging, and then we can provide feedback. We've done this most recently in a group of medically vulnerable women who were obese, and the goal of the intervention was to try to prevent weight gain in this group. And we asked them to monitor weekly using an interactive voice response call. So it's like an automated telephone call. Fully automated, uses thousands of hours of audio that are voiced by a human actor. It pieces together the call and the feedback so everyone feels like they're hearing something a little bit different. They take about 3 to 5 minutes, and at the end of them self-monitoring their adherence to these simple goals, they get tailored feedback. And this is what you get. You get about 72% adherence in a highly impoverished group of predominantly African-American rural women, about 72% adherence, which for me is a major win. That means they take these calls and they go through the self-monitoring episodes. You can imagine fitting some of the kinds of things that Art Stone was talking about into this kind of he called it sort of an end-of-day diary. It's a similar kind of thing. So you can do that with a medically vulnerable population. I suggest using multiple channels to try to minimize attrition. We had one study recently where we allowed people to choose whether to receive that automated telephone call or to go on the web to do their self-monitoring. And what you see is, may or may not be surprising, what you find is that the telephonic technology works better than the web. People track for longer. This is a 2-year trial, so they're tracking weekly over 2 years. Again, high poverty group. There's homelessness here. There are people who are using food pantries, predominantly African-American, urban, high rates of poverty, all primary care-based. And you see here that they use the interactive voice response calls at a much higher rate than the web. But importantly, when they use the automated telephone calls, they're actually less likely to stop tracking over the course of that 2-year period. We also allowed people to switch back and forth between interactive voice response and the web. And what you find is that when people have that ability, those are the people who avail themselves of the opportunity to switch are actually those who are least likely to stop using. So the message here is to give people options and not to just presume that everyone will use an app. And we recently have shown that if you combine this interactive voice response with text messaging, you get 80% adherence. Again, medically vulnerable, primary care population. And this idea is not a new one. This is exactly what Facebook does. Facebook doesn't care whether you're accessing it through text messaging, a mobile web app, or the web. Using multiple delivery channels is a time-tested, true approach to try to maintain engagement, and it happens to also work in the medically vulnerable. I think we want to consider user experience as well to minimize bias. There's been a lot of talk about sensors. We learned very early on that you can't use a sensor that connects to someone's ankle and expect that to work very well because it may heighten concerns about criminal activity. We also can do a lot of fun things through email, but it's hard to use email in populations that are manual labor occupations or that work in the service economy. We use a scale like this. Instead of attaching it, we ask people to weigh themselves every day, and instead of attaching it to Bluetooth or to Wi-Fi, this connects directly to the cellular network like a Kindle. And when you do that and you put this in the homes of rural North Carolina impoverished men and women who mean age is around 60, they weigh at 4 days. So we ask them to weigh daily, we get 4 days. I think that's pretty good. So pretty good indication, but what's important here is that we've minimized the barriers to them actually being able to use this. We haven't presumed that they have broadband access and the like. So I'm going to just, in the interest of time, I'm going to just stop there and say that the final piece is one about user testing. A lot of what we do uses user-centered design. We ask people, what do they want to see? What do they want to do? But one of the most important things we've learned is that Steve Jobs said a lot of times people don't know what they want until you show it to them. I'll make that a little bit less narcissistic and say that a lot of times people don't know they may know what they want, but they may not know what they'll do. And so it's critical to continue testing these, and we can test our way to higher engagement. And we've shown that you can do this in medically vulnerable populations. I'll leave it there. Thank you.
Okay, it's an honor to be here, and I have 10 minutes to tell you about why children should be part of this. And so here I go. So first, let me just dispel a myth, and that is that children don't have phones. So this is new data coming out of the Pew study. Youth aged 13 to 17 have about 88% have access to cell phones, and actually smartphone access is higher in African American populations. What about younger children? This is a interesting study that only came out in 2012. So I hadn't been able to find much newer data except some data that we have ourselves from Los Angeles inner city schools. But this one was national, and what you see here is that about 11 years old seems to be the sweet spot that parents are buying phones for their children. So this is really important to know. Kids do have phones. And why is that important? Because we talked about the mobile phone a number of times, but I just wanted to remind you again, these are data-hungry, ubiquitous computers that we are carrying around, and they're integrated with wearables and deployables, or what our earlier speaker called a-wearables. So a lot of data can be gotten through these phones, and a lot of data can be given back through these phones. So what I wanted to do today is I've worked in children and mobile technologies since the early 2000s. And I want to share you some lessons learned about what it's like to work with children, particularly minority children. All of my work is in minority children. One thing I know is that context is king, and these mobile technologies give you the ability to understand behavior and health in context, in the settings where these things are happening. So this is my first case study. This was a study called NOMI Networks, which was a suite of wearable wireless sensors that interfaced with a mobile phone, and it had real-time data analysis and feedback to the children. And we designed this sensor suite with the kids and for the kids, so user-centered design from beginning to end. They were involved the entire time. And we did decrease weekend sedentary time by about 170 minutes, and these are profoundly sedentary kids. Here's some lessons I learned working with these kids. If you want them to trust you, you need to be accurate with the feedback that you give them. So what we did was interfere in sedentary time. And what we did was, if they'd been sedentary for a certain amount of time, we said, aha, we see that you've been sedentary. But that means your algorithms need to be pretty accurate when you're working with kids, especially because they are so tech savvy. Another thing that we learned is that, at least for the kids that I worked with, if there wasn't a human fairly close in the loop, our technology wasn't ready to receive the messages that we got back from them. So we had to keep a good watch on it. They like to hear from us. Another thing that we learned was that we had these surprise users, surprise people who wanted to be part of the research. So after a couple of these user-centered design sessions, when the parents were in another room getting some education, we took care of them very well, we fed them. Suddenly they stormed the barricades. They too wanted to be part of the NOMI study. They too wanted to wear this technology. It would have been a $20,000 programming job because they wanted to see something different on their watch faces and on their phones. But what's interesting to me is that by having children in this study, it was value added to the parents. I can only imagine now with this new cohort that we're going to develop that including children will make the entire endeavor much more valuable to the parents. Another lesson that we learned, and this is one of my favorite articles by Susan Wolford and colleagues, is OMG, don't say LOL. They know who you are. They know that we're researchers. We are not children. We shouldn't be trying to use their language. They are smart and savvy, and really, don't do it. Lessons from digital natives. I asked a bunch of kids, are you willing to share your digital traces after explaining to them what that meant, their phone use, their location? Are you willing to share that with a researcher like me? The answer was sure, yeah. Not, with some, maybe I would like to opt in out of a few things, but for the most part, yeah. And then I asked them, are you willing to share your data with friends or family? Just your physical activity data, for instance. No. No. So, sharing is a whole different animal with these kids. After all, this is the generation of Snapchat. That's where their data appears and disappears in like no time. They kind of know what they want to share and what they don't want to share. And they are sensitive to things that we aren't expecting and not sensitive to things that we get our knickers in a twist about. So working with kids is a whole new thing. But if we want to build this for sustainability, building for children is really important. They were born digital. Their privacy and security concerns are going to be really different than ours. But designing something like this, we can learn really a lot from working with kids. Okay. They loved attention from us, and they sent us messages, about 14 a day, sometimes more. And I said, it's like having a doctor in your pocket, just having us around. They love talking to us. These born digital kids expect digital as part of their experience and will be a real asset to a cohort like this. I want to talk about something else. This is my second case study, Imagine Health. What we've done here is we've developed mHealth solutions for collecting really sensitive data in the field in youth. So for instance, if you want to study stress and you want to get salivary cortisol in the field, how many of you have ever done that? It's hard. Joan, where are you? And one of the important things is timing. When they wake up, they've got to do it right away. So we've developed this app that gives them an alarm. We give them labeled vials. We ask them to take their cortisol exactly when they get up and 3 more times during the day. They take a picture, so it's time-stamped, and they send it to us. And then we ask them a couple of stress questions to see how they're feeling. Two really important things from a system like this is that we know now for the first time when they actually, unless we're using MEMS caps or some very expensive technology, we now know exactly what time they've taken their cortisol, which is extremely important. And another thing that we have on the back end is when we ask them, how are you feeling stressed, are you feeling anxious, we just had a little algorithm developed that if they were feeling stressed or anxious, we didn't ignore that. We said, so tell us what you're feeling stressed about, and we monitored that on the back end. So these are really great solutions for sensitive data in the field, and kids are very willing and very able to do it. Last case study is Virtual Sprouts. This is a mobile gaming. It's a game to learn gardening and cooking and healthy diets for kids from 3rd to 5th grade, predominantly Hispanic children. And there's only a few things I'd like to tell you about this. Interactive gaming is incredibly engaging and it's adaptive. It adapts to the child as they learn. I'm surprised that I didn't hear gamification today, but I'm really glad I didn't. Gaming is hard. If you're going to put games in, you need to have somebody there who really knows how to do it, and it's got to change a lot. But the one thing is that it's sticky, and how we need to make these technologies sticky, and we need to make them engaging for a long period of time. And another wonderful thing about these, so what you can think of as an interface that's kind of like a game interface, Maribel talked about that earlier, that collects this wonderful data on the back end about how children learn, what they do and don't understand about the data that you're giving them. So it can collect a lot of data on the back end that you don't know you're getting, which is really, really fantastic. This is also being done in the elderly, by the way, and has been extremely successful. So, in closing, I don't want you to forget the Internet of Things. I think we've heard a lot of things about that today. These are the wearable sensors. They are combining with the wearables, so I think that the need for wearable sensors will decline a bit as the phones get smarter and the sensors get more deployable. I think learning about diet, for instance, in the home and having the home as a hub is the next generation. I'm going to be involved in some of that work. If anybody would like to hear about it after this, I'd be happy to talk to you about it. But this is it. These children are the grown-ups of tomorrow. And I think that involving them in this space is the most important step that we can take. Thank you.
Thank you. The next speaker is David Gustafson, and we're running behind, and so he'll keep it to 12 minutes. Thank you.
Sure will. I think it'll keep it.
It's the thought control interface.
Is that what you have to sit here and look at it?
It's late November on a Tuesday morning. Gwen wakes up at 7 a.m., a bit later than usual, and makes coffee. Even before she opens her morning paper, she sits in front of the touchscreen display on her kitchen table and checks her eChess screen. She sees she has an in-home nurse visit scheduled at 4 p.m. today, and she notices the reminder to herself to make sure and vote. She's got 2 new messages, one sent by her granddaughter, Katie, looks like it's got some more pics of little Jared, and one from her exercise team. There's a new goal set, 4 15-minute dumbbell sessions for the week. She has yet to let her team down, though the exercises can sometimes get a bit tedious. She looks at the pics of Jared right away. He looks just like Ron did when he was little, but will respond later tonight. After the paper, it's laundry day, and she's got cookie baking on the mind. The kitchen smells like ginger snaps. An eChess alert sounds, and she ignores it because she's on the phone with Ron. When she's done talking, she walks to the kitchen table and taps OK on the screen. It seems you've been spending more time in bed than usual. Are you feeling dizzy or lightheaded? She answers no. Make sure you call your doctor if you start to. You are almost out of warfarin. Would you like to order more for delivery? She again answers no, as she enjoys picking it up herself. It's a chance for her to get some air and to see pharmacist Chad, who makes her laugh. And so handsome. She gets in her car and heads to the pharmacy. Inside, Chad pulls up an eChess report and notices that it looks like she has been experiencing more fatigue and swelling of the ankles than usual in the last couple of weeks. When he asks her if she's been consistently taking her Lasix pills, she comes clean with him. Reading the paper every morning, Gwen has developed strong feelings about this election period. She wants to stop to vote at the community center on the way home, but she's not familiar with the route and not feeling as comfortable as she used to behind the wheel. She says community center into her customized GPS unit and is directed on a route adjusted especially for her preferences, avoiding left turns on any busy streets. She knows that's where a lot of folks end up in trouble. When she's done voting, all she has to do is press home on the screen and follow the special route back. Receiving medical services at home could be stressful for Gwen. It used to be difficult to keep track of who was coming, when, and for what, and she felt anxious sitting around the house waiting. Another eChess alert sounds. On the screen is a picture of Christine, Gwen's nurse, and a notice that she would be 15 minutes late today. Good to know. Christine shows up about a quarter after and checks in by inserting a thumb drive into the computer on the table. Christine is the only one Gwen knows who can stick in an IV needle without causing any pain, which is why she gets a cookie on her way out. And when a survey pops up asking Gwen how Christine did, a 5-star rating. Gwen actually found Christine using the service dependability feature, scheduling appointments with her because she had been rated highly by others who needed similar services. As Gwen is watching Murder, She Wrote, an iPad vibrates on the coffee table. She picks it up and sees it's a weather alert. Looks like it's going to snow tonight and tomorrow morning. She watches a brief instructional video on how to use Yak Tracks and walk safely on ice. She's been leery of all things slippery since her fall in the tub, so she listens closely. She already knows that little knuckleheaded Johnny from down the street will be over to shovel first thing in the morning, as he always is. A while back, EHS asked her what she liked to do, and she entered in cooking, state history, and of course, Murder, She Wrote. Later, a community organizer called her up and asked her if she would be interested in swapping some cookies and impromptu state history chats, both of particular interest to the young knuckleheaded Johnny, for some snow shoveling, which her wrist prevented her from doing. They struck a deal. Johnny would shovel, and Gwen would bake and teach. Johnny's parents were thrilled to have him out of the house now and again. Johnny's mother wearily refers to him as a boy with way too much energy. Gwen is usually able to keep herself occupied during the day, but at night, when there isn't much going on, she often thinks of Donald, and sometimes a terrible sadness washes over her. Gail had lost her husband, too, in the same year as Gwen. Gwen and Gail used to trade off visiting each other in their homes in the afternoons. It always made both of them feel better to talk, even if it was about nothing in particular. When Gwen first tried EHS, she had learned to use the simple video chat and email features so that she could talk to her granddaughter after she moved a year ago, and really wanted to be able to keep in touch, so she learned fast. She hadn't expected to use it for anything but that. Eventually, though, she followed the invitations made by EHS and joined a chat room. It was supposed to be a place to talk about cooking, but often the talk ended up being about nothing in particular, which was just fine with Gwen, though she did appreciate when others shared pictures of their cookies, turkeys, cherry pies. It isn't as good as visiting with Gail, but it's always there for her, and somehow makes the sad evenings less sad. Saving her favorite part of the day for last, Gwen opens up the message and writes back to her granddaughter, Katie. She pulls up a picture of Ron when he was little and sends it along for comparison. See, same crooked smile, she writes. She clicks on send. Time for bed.
Well, that's the system that we have going at the University of Wisconsin in 3 counties in Wisconsin, one urban one, Milwaukee, suburban one, Waukesha, and then a rural one, Richland. And it's a system that makes me wish that PMI was PHI, not precision medicine, but precision health. And the reason I feel that way, maybe is obvious there, that is that medicine is really important. Don't get me down. I mean, I had a heart transplant 6.5 years ago, and so I like medicine. But it's only part of an elderly person's life. And if we're really going to make a difference in their life, I really think that we need to go beyond a medical focus. This is, when we first got started, we did a process called asset-based community development, where we went into these 3 counties and spent time with about 100 people per county. And we found that the elderly people said, what I want to know is, how do I deal with loneliness and isolation? They wanted to know, how could they get meaning out of life? And they wanted to know, how do I get to a community event? I can get transportation to the doctor's office. I can't get it to a concert. Now, doctors, on the other hand, appropriately so, said that, well, we need to deal with things like falls and depression and dementia and adherence to medication. Neither one is wrong. They're just 2 different views, but they're both important views. And what we've done in this particular project is to assume that if we deal with the left-hand side, a lot of the middle and the right-hand side is going to take care of itself. And so we focused on loneliness and isolation and things of that particular type. One of the questions we're supposed to answer is a question related to adaptation. And in that particular area, what kind of adaptations are we going to need to make? And I think one of the things that's so important is to, if anybody sort of feels like, well, the 55-year-olds of today will be elderly at some point in time, and so they'll be able to use mobile technology. Well, Prograf is an anti-rejection drug. I love the thing. It keeps me alive. But it also makes my hand quiver. Prograf also gives me cataracts, and for many other reasons, we change as we get older. And so to expect that we're going to be able to use mobile technology in the same format than everybody else does is wrong. Now, of course, I'm generalizing, and of course there will be some people who can and others who can't, so forgive me for that generalization. Another thing that's really important to this audience is the importance of keeping things very simple, to, as much as possible, automate data collection. We get open rebellion by our people on the system when we ask them to answer what to do about a particular kind of question that we've decided on. And so I think it's really important that we minimize the amount of stuff we expect these people to give us. I'm going to pass over this particular thing. Another thing I worry about on the simplicity side is really don't give us too much information. And also, for the same thing for doctors. What we do is if a person hasn't had a bowel movement in the last 3 days, that's when we contact the doctor. Not what their bowel movement is every day. They pick things, they say, oh, don't tell me anything unless X, Y, and Z happens. And then we communicate to them. So the idea of big data is okay, but we got to narrow it and whittle it down, and that makes a big difference. Finally, as far as heterogeneity is concerned, I think that there are a number of different things, but I'll talk about the bottom 3 things there. I worry about elderly in communities that are an internet desert. You know, so many of the elderly people in rural Wisconsin don't have access to the internet. But yet, if we're going to have a 1 million-person study, we got to reach those people. The second thing that bothers me is I've never really liked the term personalized or patient-oriented or patient-centered things, because in reality, when I got out of the heart transplant thing, it was my wife who kept me alive while I was there to some extent. And she was the one that drove me. She was the one that picked me up. She was the one that cooked. She was, etc. And so there's very rarely a patient disease. There's almost always a family disease. And it's important, I think, that we move away from the idea of an individual, the single person standing there in the picture. Let's replace it with a family. And then finally, high quality data is really important. Garbage in, garbage out. We got to worry that the stuff we put in is really good stuff. Thanks.
Beautiful. That was awesome. And we are on time, and I'd like the rest of the half to be open up to the audience, and we'd like to solicit audience participation. So if there are any questions, feel free to use the mics. We have them on the periphery. But we do have some questions for the for this panelist, and these are just placeholders. So I will challenge them to address them, but then again, it's open up to the rest. We had a wonderful spectrum of disease from womb to from children to elderly and everything in between. And the key thing that I heard echoed was that we need to reach out and we need to be nimble. So the same things that we do for someone in a nursing home or elderly home might be different than what we do for someone who is of a low SES community. So I want to open that up and really get input on how do we do it, the practicalities. So one of the questions, I'm going to open it up to Dr. Bennett, is how do we make sure that the modern advances are not exacerbating health disparities or not exacerbating the digital divide? You had a young, low SES group. What was your experience on the nuts and bolts on what to do?
Well, let me answer that in a couple of ways. I think the first one is not to presume that people who are in medically vulnerable circumstances will not use technology. I think we have to recognize. I am sometimes surprised at how surprised people are that folks in medically vulnerable communities are disproportionately likely to own smartphones and to use them at high rates. I sometimes say, if you really want to know how to design a social media app, go ask a single black woman who's in poverty because she's disproportionately likely to use Facebook and Instagram to connect with her friends. So I think that the first thing is to understand that people are using the technologies, but then I think the second issue is to really approach the design of these applications with the same type of rigor that we would approach any other aspect of our science. So that is that we may start with focus groups to try to understand likes and preferences and those kinds of things, but then to rigorously test and iterate through the process of developing these types of applications to ensure that they're optimally usable and not to allow our own interests in leveraging new technology or the hot new shiny thing to cloud that. And I think Dave's point at the end here about making sure that we keep these things simple and that we're really designing this in an optimally and a user-centered way is really the way to do it.
Other panels have suggestions?
I just want to second what Gary said, that I don't think it's a good basic assumption to think that disadvantaged populations or minority populations are technically not savvy. I think they're often more savvy than we are.
Dr. O'Rourke, you had a question, suggestion?
Thank you, and thank you all. Particularly to Donna, I was intrigued with the case study you gave with I think it was Hispanic teens with weight reduction. In your comment that be accurate and also the need to have a person interacting. As we look forward, I would like to know, is that generalizable to anyone? Because in some ways it's almost like we're sending these things out and stuff's coming in, but how much person-to-person, either hand-holding or coaching, is necessary from all of you, actually?
So that is such a great question, and I wish I knew the answer. We've got a couple of grants out to try and figure out where that is, but it's a moving needle. So when I did that study, 2008, 2009, natural language processing was not there. Wasn't really ready to help us, right? And I know how vulnerable children are. So I also want to know what they're thinking. I don't want to just get their data. What good is that without knowing what they're thinking and feeling? So we went for human in the loop, also, and they really appreciated that. Now new technologies are making more and more things possible. So for instance, one of my colleagues that I'm working with now at the Institute for Creative Technologies, Bill Swarthout and Skip Rizzo, have developed things for the Department of Defense that one of them was Sim Sensei, which is a therapist that is so reactive to your facial expressions. It's in the computer right now, and we're starting to use more of that on the phone. Dave has used quite a bit of these avatars on the phone. So I think that we're getting more and more advanced, and I think that we can start to think about having the user slowly pressed out of the loop and almost entirely pressed out of the loop. Never always. But I think that we just need to, every step of the way, make sure that we're taking care of the needs of our population. Not only because we should take care of the needs of our populations, but because we're going to make better scientists and actually better people if we do. Does that help?
I think that one area where you'll probably always need some human being involvement is in the communication, and we do a lot with computer-based discussion groups. And in our work with teenage asthma kids, we had this boy called Genital Boy. We don't need to go any further with that, but you can guess what he was doing on the system. But in the case of elderly people, one of the things that we found was that some elderly people tend to lose their filters a bit. And when they lose their filters, it turns out they're the most argumentative, the most snotty people. We've done addicts, we've done cancer patients, we've done asthma patients. The elderly people are just plain snotty. And as a result, and especially on religion and on politics, I mean, they're at each other's throats all the time. And so we've had to literally do some calming down and some phone calls and saying you really shouldn't get yourself into that and all that kind of stuff. So I think that there's always going to be need for a human monitor anytime there's a communication system involving people.
It's clearly all that murder she wrote. So I think I think that at least in the intervention literature with respect to the kind of major health behaviors, I think one of the real challenges right now is that much of what we know about the efficacy of mobile health derives from studies in which humans have been involved in one way or another, often as in the delivery of care. And that makes a lot of sense. I mean, you know, if we're thinking about the optimal dissemination of these kinds of technologies, then we should be thinking about how to develop technologies that fit within the existing care spectrum. But it does make challenging, I think, interpreting how these technologies will exist on their own. I don't think we really know that as much as we should.
I'd like to really encourage the audience to jump up and ask questions, and please make use of the mic. Anand?
Fantastic. Great discussion. My question is one about how much we want to include the global community in this dialogue. And the reason I say that is the examples, Gary, that you gave about fascinating statistics. At the same time, when you go to India or you go to South Africa, the Kingdom of Lesotho is a great example. They don't talk about higher access, lower access, higher affordability, lower affordability. It's low, period. And yet they have come up with the most innovative, simple, SMS simple based stuff that gets them to the outcome that's desired, and that's better health outcomes and peace of mind, and I can take control and all of that. So my question really to the governing body is there are plenty of examples, so many of them, where a lot of these disparities, people have figured out very intelligent mechanisms to solve those disparities. So maybe it's a question for the governing body or even the panel that says, how do we bring the international community into this? Because they solved a lot of the problems we're beating our heads against for.
Can I speak to that? I think it's a fascinating comment, and I disagree. I do think we should bring in the international community at some point. Very important. They've done very important work. But if we're talking about place-based work, it is so different in many ways than what we can do and need to do here. So I think we can learn from one another, but I think that after sitting on many, many panels for mobile health research that's done outside of the United States and certainly in India, it's very different users and very different ways to come downstairs together. So I think we can learn from one another, but I think that we will end out with really vastly different solutions. My 2 cents.
Anand, I'm glad that you spoke because I had a question for you. You actually brought up a very salient point that I think might have been glossed over here, and it was in response to what I learned from my daughter, who's here, who's a high school student. When she went to GE and part of the Girls Who Code, they said Siri didn't work, and because they didn't have women in the room. When I asked you, how do we target particular populations, and you use the example of the Southeast Asian men who have a unique form of metabolic syndrome and integrating their social factors, it's not realistic for us to have everybody in the room. So how do we actually do things like that? For example, in the African American community, the barbershops are very important. But do we need to have someone from that community inside when we're actually planning the precision medicine initiative? I'm being very practical and pragmatic, so I want solutions. You raised it, so I'd like to hear what you have to say. How do we roll this out to people here? And we're at Intel, but I could tell you that third world conditions 5 miles away from here. I grew up around here, so I know that. So we have the international community here. How do we make them feel included? They're funding the dollars that are being used to pay for this. So how do we do it? You're the one that provided the input, so I want to ask and challenge you.
So I'll give you an answer, but in all fairness to the panel, why don't you guys address it first, and then I'll see if there's anything intelligent I can add, but you guys should address it.
We should stop talking because we've already talked quite a bit.
So let me use Apollo. Everybody knows who Apollo hospitals are, the largest hospital system in the world, right? Heart disease is the #1 problem in India, and it's fueled by a number of things, which is a rampant prevalence in diabetes and hyperlipidemia and whatnot, but it's a big problem. They started a program with the wireless operators years ago called 1 billion hearts beating. And the idea with 1 billion hearts beating was very simple, right? They wanted to encourage people to take steps. And that's something that crosses all socioeconomic strata, if you would. It's something that you can actually accomplish in a very simplistic sense. You can accomplish it for the most sophisticated person and for the least sophisticated person. And it was literally take your route to work and understand your subway route or your bus route, and then you would get an SMS, 3 stops, 4 stops, whatever you set that day before, saying, hey, get down and walk the last X number of steps. And they're actually starting to reap the benefits of those things now. There are many case studies like that, so I guess perhaps the answer is inclusion doesn't mean, let's go in and let's try to find the barbers and let's put them in a room, and because that's expensive and it's time consuming, and yet there's so many good case studies that cut across. So the horizontal application of that isn't just for heart disease, it's actually for a number of things, not the least of which is obesity and how we fight childhood obesity and getting people more active. And so I think maybe an answer, not the answer, but an answer is take these case studies. There are lots of them. They're well publicized. Take these case studies. We should say, what can we extract from them? What learnings can we extract? Because they're foolish if they cut and paste American solutions in their environment. It won't work. We'd be equally as foolish if we took their solutions and cut and paste them in our environment, because then we have privacy. But what can we learn? And maybe that's the answer that says, let's take these case studies, but they should at least be part of our research and dialogue.
Now that I totally agree with, for what it's worth.
I guess that one thought about involvement is it strikes me as important here. When we first got into doing work in addiction, I got myself admitted for heroin addiction, and I stayed overnight in a detox facility, and I stayed overnight in a residential facility, and I toured a lot of addiction treatment agencies to see what is going on. All of our computer programmers have to volunteer 4 hours a week in an elderly senior center because I don't want them to have a job, I want them to have a calling. And it seems to me that while we can go out and try to learn from each other as much as possible, it's important that the staff that are engaged in putting the solutions together have personally experienced what it's like to be the customer that they're trying to serve. And this has been borne out time and again in research and organizational change. By far the most important predictor of success is how you understand your customer.
That was a wonderful suggestion, the one that I'm going to incorporate. One of the questions that we want to address is, how do we, and I'm asking everybody now, how do we address mistrust amongst community members? So the people that are actually designing the research don't necessarily, but most likely don't reflect the people that are being included or asked to be included in the research. So how do we address that? And this is open to the audience.
So I'll answer that question, and I'll answer the previous question too, because I think that our experience with Nurses Health Study 3 actually gets to those two things. When we compare experience trying to enroll through an HMO-based population as opposed to an organic enrollment of peer-to-peer enrollment, it's very clear that the strategy that wins the day for enrolling a cohort today is establishing partnerships with people who already have existing relationships with the people you want to reach. You just, at least we haven't been able to successfully reach people if we do not have an existing relationship. Building a relationship saying, hey, I'm a Harvard researcher and I want your data is not a good introduction card. But if somebody else says, hey, we know about this study, we think you would like it because of A, B, and C, and my personal experience with similar types of studies or with this type of study is this one, I think you would like it. That is a much better solution to try to gain somebody's trust than to simply wave the I am the researcher card. And also, I also wanted to comment about your question about inclusion and how do we get people from a wide variety of backgrounds involved. And I think that one very practical thing that that make some of the decisions that we have made in designing our study is that we want to make a priority to design for Android-based devices, because there's a very strong socioeconomic background in who gets an Android device versus who gets an iOS device. And if you have more money to spend on a cell phone, you're going to buy an iPhone. If you have less money or you're going to try to get it for less, you're going to get an Android device. At least that works on average. Even among health professionals, which is our study, we still see that trend within health professionals. So I think that a very practical thing to do is if you want to have a greater inclusion of people across the country, go for Android devices initially, at least.
In your patient population, it's a very skewed population, so can you argue the generalizability to the United States for your population?
So yes, I can. So one thing that we have done in this time around with Nurses 3 is we've expanded the definition of who is a nurse as far as the study is concerned. So in Nurses 1 and Nurses 2, you had to be a registered nurse to be part of the study. So, and right now we've relaxed that definition to include licensed practical nurses and licensed vocational nurses who have a substantially lower salary than registered nurses. And by doing that, we've actually expanded dramatically not only our socioeconomic background of our participants, but also the racial ethnic composition of our participants. Now, it's still a cohort of professional women, but even among professional women with this type of background, we do see these socioeconomic choices.
Thank you. Next speaker over here.
Yeah, I just wanted to emphasize that and add one thing. I think the relationship for recruiting patients and gaining their trust is critical, but also giving something back. And it's been touched on a little bit in this meeting, but really not that much. It doesn't have to be a monetary gain that the patient gets, but something that engages them with their health and or with their life. We've done this in a cohort of various insurance groups, so migrant farm workers all the way up to high-tech workers, about 300,000 people, and we got about an 82.5% opt-in rate for research, and the retention rate was similar to that actually over the course of a year. So it's really, I think, it's establishing a relationship. We also looked at this in a group that we've coalesced with DIA, that was partially government, both European and American, partially industry, lots of foundations and some patient groups. And there was one consensus in that room, which was that government actually and industry both have a problem with that trust relationship. And so I think that's something that we need to work on in terms of fielding a proposal back to the patient that's acceptable to those different patient groups.
I think giving back is so important, and we have resources that we don't even know are resources, and that we end out a sort of double give back. I mean, so when I work with many young girls of color, and having my students just help them with their homework, it helps the students, it gives them back, we hear their stories. So giving back to the population raises the trust in the kids and also in the parents, and we have a lot more things that we don't even think about that we can give back with, including their data.
I'd like to just say one quick thing about trust. Our experience with the elder, you remember the video, there was a little sensor that measured quality of sleep that was underneath the bed. That was the only thing in that video that isn't that way, and it was vetoed by the elderly people. They said, "Don't spy on me." There's an issue of trust for elderly people in a lot of ways. You're taking my money, you're trying to put me into a nursing home, you're trying to kill me. Those are the three things that, and as a result of that, you need to be really sensitive to what elderly people are going through, and you need to listen. We have really designed our system to respond to the issues they feel, so that they can trust us. And we're just about ready to start moving into the sensor stuff for sleep, but it's taken 2 years.
Next speaker.
A few comments on the quantitative aspects. Is it on?
Yes.
Closer. Okay, a few comments on the quantitative nature of the data we will gather and the relevance of it. Number one is we do have analytical tools that are powerful and diverse. Someone asked, are there tools? Yes, there are tools and platforms, NMR-based, mass spec-based, where thousands of chemicals can be measured. There are large initiatives in Canada and in Europe where there is a tally and creation of databases of knowledge on metabolism, on all metabolites within different types of diets. Number two, what is important in capturing the effect of the environment is not only what we are exposed to, and we certainly only sense part of them. I would encourage that we engage NIEHS that is thinking about the exposome and implementing projects, because what we are capturing from environmental exposure is a small piece of what's going to be captured with these powerful analytical tools. Number three is that the drugs are also critically important, and they impact metabolism and profiles and health in many ways. The effect of the drugs, we are mapping and creating catalogs of the effect of these medications. So these types of databases are going to be quite important and informative.
On that note, could you identify yourself, and could all future speakers identify themselves?
Yeah. Rima Dauk from the Duke Medical Center. So I think
Thank you.
The one last comment, just if I may, also on the issues of mental health.
We're going to wrap it up. Thank you. Next speaker, been patiently waiting. Go ahead.
Rodo from the Framingham Heart Study. So I just wanted to comment, because we talked about sort of trust and relationships, and I think that that's one of the strengths of Framingham, is that, you know, we've developed the trust because we have significant relationships across generations. I think one of the things when you have this kind of trusting relationship, how easy it is to expand. So for instance, when we brought in the Generation 3, we were actually funded by the NIH to bring in 3,000 of the Gen 3. 6,000 responded in our first recruitment. So we went back and we got permission to bring in 4,000. I can tell you that right now, our Generation 4 is asking, what about us? So I think that this is a way in which once you develop it, the relationship, it actually expands. And that's where we talk about the family rather than the individual.
Can I ask a follow-up question?
Yeah, Rick.
So just in Framingham, where your patients are ascertained without perspective to disease necessarily, what are you giving back, and what is Framingham's view of giving data or other compensation back to patients?
Sure. So first of all, we don't call them patients, we call them our participants, and we recognize that they're volunteers. So one of the first things we do at Framingham is we understand they are the most important. You know, I always tell my participants that, you know, as a researcher, I'm a dime a dozen. The value of Framingham is actually with them. One of the things we do is we communicate with them constantly. So one, we always give them extreme respect, no matter what. One of the things when I was first brought into Framingham, I was told very clearly, you wait for them, they don't wait for you. And so we carry that forward. We're very careful about how we handle our participants. We respect their time, we respect their contribution, and we try to show that. We don't pay them at all, so this is all volunteer-based, but we do things like, you know, we give them newsletters, we give them heads up about things that are coming down the pike, and it does help. You know, we tell them when publications are out there. We're in the media, so that helps a lot as well. So it's a constant interaction with them. Return of data, we don't, so what we do in terms of, we do inform them. They have the, you know, if they would like us to send their results to participants, we do, to their physicians, we do that. We do monitor them so that if we see anything, we do contact them and encourage them to go to their physician. So we do sort of active monitoring of them as well as feedback. We don't give them data per se, because we're worried about interpreting research-based data in which we're not really sure about what these results may mean. So we are comfortable sharing general information and then also sharing it with their physician.
Great. Well, since there are no other questions, I want to digress until you come up and share a little of my experience. And I talk a lot about the Ivory Tower trying to reach the community, and I actually had experience coming from the Ivory Tower and trying to work in the community. I launched a study from the Brigham in Boston a long time ago that was supposed to be launched in San Francisco and Harlem Hospital, and it failed miserably because I didn't realize that even within my Ivory Tower at UCSF, we have Parnassus Hospital and San Francisco General. Recognizing that our study was failing, because I was really designed to study from the Ivory Tower, then approached the community, it didn't work. We revamped it, and it worked quite well when we actually only recruited through federally qualified health centers, and we revamped our team to have community members actually do the recruitment. So we match the recruiters to the community, hire people in the community, worked with community clinics. That's been my experience. We recruited 10,000 minority children from throughout the United States, and it's been wonderful, but that's my experience. But I'd like to hear other people's experience who have done similar work in the community. And I don't want a top-down approach. I'd like to hear from people in the community. So I brought one of them who runs the pediatric asthma clinic at San Francisco General, which is primarily the safety net for all of San Francisco. Despite the fact that we have huge wealth in San Francisco, we have huge disparities. And I'm sorry to put you on the spot, Ms. Kim Honda, who runs the clinic. Would you be able to provide us some practical experiences that you could share with us?
Hello, my name's Kim Honda, and I do run the Pediatric Asthma Clinic at San Francisco General Hospital, which is an environment that's quite unique if you've never been there, if you're not familiar with it. And I think there have been such wonderful ideas generated here today, and it's really inspiring. And it's always great to come up with the challenges that sort of surface as a result of these types of conversations. But I think the thing that continues to come up for me as I think about how we would bring these ideas back and implement them into our clinic in real life when we work with our patients is how do we really engage families and engage patients in a way that brings value for them? You know, we talked about different incentives and how monetary gain is not necessarily something that would fit for one population versus another, but it is really challenging to find something that would add value to a patient's time or a family's time who's coming in to give their information and sort of their health access information to you.
So we as providers, should we tell you what we think you need or tell you what the research questions are, or should we have an organic approach?
Well, I think an organic approach is great, but I think it's also been brought up today in a couple of different talks that really talking with the patients and families themselves who've had the experiences and being able to sit and have a conversation and hear from them directly what works and what their aims are, because our aims as providers are not necessarily in line with what our patients are seeking at the time of coming to us in clinics.
Thank you. Next question.
How do you deal with the multi-generation of, especially the Hispanic community? They are different. You can't label them as one community because they're different in acculturation, they're different in 22 different countries of origin. Do you see a need to provide something different for the different generations of Hispanic? And I would ask Dr. Metz the same thing.
Since we're on air, I want to repeat the question. The question is, how do we address the multi-generational nature, particularly with some communities like the Hispanic community? Go ahead.
So I wish I had a simple answer for you. I think it's a really relevant question, especially as we look at the way that our patients define family. It really is always, I shouldn't say always, but in many, many cases, the vast majority really define family as multi-generational and intergenerational. So having an approach that incorporates different perspectives, different language, different literacy levels, these are all important. I don't have a simple answer. I wish I did.
Does the provider or the researchers need to match the community that they're trying to include?
It was mentioned earlier that having really field experience or being sort of versed in the community and the population and the type of experience that you are actually trying to address is very helpful, and I think that's really valuable. I think certainly having cultural and language appropriate services and approach is really important. I know that families who come to us really trust us, and we have the most success with families who really feel like they can engage with our community health workers because these are people that they may have seen or known who have lived in these communities and grown up in the same areas, know San Francisco, speak the languages that they may speak, may have family dynamics or look or speak or act in a way that feels comfortable or familiar to them. And so that's really a big part of what makes our clinic work.
Thank you, and I appreciate that I put you on the spot. And Srinky had a question.
Can I address it too? Because she did ask me. Would that be okay? Yeah. Because you mentioned something else that's a huge, and that is the Hispanic is not one thing. And we're doing a bunch of studies now sort of in Florida and California to try and sort this, and I've been studying it since I immigrated back to the United States. I think that there's going to be a Venn diagram of things that work, and there's going to be other things outside that Venn diagram that are really population specific. I won't even address generations because the child is always the center of my universe, and that radiates out to the family, and that's a really great way to address that problem. But I think that as our technologies get more agile, and we find we have great databases of what works for different people, I think we're going to be able not to have, one size is not going to have to fit all anymore. And I think that's the thrust of the future for this initiative.
Yeah, if I just could add to that a little bit, so for the technologists in the room, let me maybe try to articulate one of the reasons that this matters. We've been trying for a long time to. We have presumed that in the work that we've done, that so many of the folks in the medically vulnerable community health centers, that medically vulnerable populations that find their ways to community health centers where we work, we have long assumed that they actually cared at all about losing weight. And it turns out that obesity ranks pretty low on their health hierarchy. News to me. It also turns out that tracking their data, I happen to be a pretty quantified self. I have a pretty quantified self, but it happens to turn out that they don't enjoy that experience just merely for the purposes of seeing numbers, accrue. That they are actually more interested in kind of maintaining their shape. They're not actually interested in losing a whole lot of weight, and they're interested in kind of staying where they are. But they are extremely interested in reducing stress, extremely interested in sleeping better, feeling a little bit better, being better connected to their friends and their communities. And it really wasn't until we took time to spend time in the community that we were confronted with this, and it completely changed our algorithms for how we provide feedback. There was a comment earlier about providing feedback, and I think it is both the right thing to do. I think it's the ethical thing to do. I'll get off that soapbox, but I also think that from a scientific perspective, we know very clearly that when we don't provide feedback, we don't maximize engagement. And so for interventions that really require ongoing engagement, or for observational trials that aim to try to keep people involved for some period of time, then providing feedback is absolutely critical. But if you provide the wrong kind of feedback, and I've done that several times, then you really risk sensitizing these feelings about mistrust. So it's just absolutely critical that one does the work on the front end to really understand what folks in the community are really dealing with, so that you're designing the technology in the way that best meets the user's needs.
Thank you. I have Shariki and Dr. Platt.
Thank you. I wanted to comment about a theme that's running through this that hasn't been made as explicit as I think it needs to be, which is the behavior and the attitudes of researchers, and understanding the limitations and strengths of different types of expertise on a team. You were asking for examples. I've had so many people come to me when I was in an institution to tell me the PI doesn't listen to me. They're hired as the recruitment person. They give advice. If the advice makes sense in some way to the PI, they may listen to them. If it doesn't, it's rejected. And then they begin to feel that they're caught between actually put in a position where they may do harm to the community because they can't get their boss to take what they consider to be critical advice. And so I think there's going to be an education or a paradigm change in terms of what types of expertise are needed for which purpose in a team, and the lead scientist may only be the scientist in one aspect, and there may be other people who know the science of, especially crossing social class barriers, because the difference in having resources that are very limited is probably something that nobody in this room really understands very well, because by virtue of being here, we've crossed that, and that is critical when you actually live and interact with people who have to make decisions based on surviving and resources. It's different, but we need those folks very much in the cohort, because they may teach us more about resilience and survival than we would, where we've got a good cushion under us.
And that point was made very clear last time we met by the presentation from the Jackson Heart Study, which I thought they did a very good job of being involved in the community at all levels. Dr. Platt, you had a question?
So first a comment. This is another tour de force panel. Thank you very much for explaining these things to us. I'm struggling with how to know which pieces of the good advice you've given can be applicable to a cohort of 1 million people. because it's 1 million is a lot of people, and there might be a couple of hundred or a few $100s per person per year to build the cohort, maintain the cohort, learn things that are useful to the entire nation about it. So, like a caller to a radio program, I'd be happy to take your answers off the air. But I think it would be enormously
First-time caller, long-time listener.
Just be extremely helpful to, not just from you, but from all the people who've been sharing their wisdom with us, to understand what pieces of it are absolutely essential. If it's absolutely essential, how do we apply it to a cohort that's a couple of orders magnitude than the ones in which you've done your learning?
That's a great assignment. I think we should all give you that answer. Not going to answer it right now. Do I look crazy?
Are there other?
I mean, yeah, you're going to.
Well, just one little crack.
It's dangerous.
Keep it simple, I think is fundamentally important. If we're going to be dealing with a bunch of different populations and with that many people, just don't get fancy. Get down to the essence of what you're trying to learn and keep it very simple.
Now that you've taken the plunge, I will try. I agree. I was going to say keep it simple as well. The one thing, a refrain I've been hearing a lot is that there are going to be these multiple kind of overlapping cohorts. At least that's one recommendation I've been hearing. Right? There's one group in which we're going to do some very granular, kind of very highly precise measurement, and I don't think our comments are actually. I think our comments are quite consistent with that idea that if the bulk of the cohort is going to be the masses of Americans, if the goal is to really generalize, then I think that for the 80% or the 90% among whom we are not doing the highly intensive measurement, then we should keep it very simple, and that we should be very user-centered. We should be asking only for the kinds of things that we should be asking lots of self-report questions very simply. I'm a psychologist. I'll give you all 50 questions. We should probably ask 2. And I think we need to provide, and we need to identify ways of providing feedback. And that's the thing that I think is, where I think there's going to be a lot of challenges. Just on that point, I think we tend to overestimate how much feedback is necessary. For medically vulnerable populations, I think we dramatically overestimate the amount of feedback that's necessary to facilitate trust. In my experience, I think really the cardinal experience I've had with medically vulnerable populations is people don't really ask them what they think very often. And my experience has been that when they enter into a trusting research relationship, they actually become quite engaged, very dramatically, because it's one of the first times that anyone's ever taken an hour or 2, I'm a psychologist, 3, 4 hours, and really spent some time, asking and struggling with the kinds of issues that they're dealing with. And to watch it happen, it's a really beautiful thing. So don't ask them that many questions. You'll get all the answers. But I think trying to find ways of providing feedback that activates people is not going to be that challenging, and I don't think it's going to require that we have a lot of sophistication.
Great. Thank you. We have a speaker in the back.
Hi, I'm Joyce Tung. I run research at 23andMe. I just actually wanted to respond to that question, just to share a little bit of our experience in this. So I think for us as researchers coming from more of an academic research background and then sort of colliding with sort of this consumer internet group that sort of forms the other half of our company, I think learning from them, we've come up with some ways to address exactly this problem, which is if you have hundreds of thousands of people and you're trying to do research with this group in a cost-effective way, what can you do? And I think a couple of the things that we've learned are you really want to iterate, right? So we have people in the team that are constantly just testing. If I try a Facebook post, if I try a Google AdWord, what is my cost per acquisition? If it's $100, then maybe I stop doing that and I try this other thing. And in this way, I think sort of using this tiered iterative approach, you can figure out, what is the best way to get to your particular target. I think one of the challenges that you face when you do this is that all the research has to be done under an IRB, right? So, I think people are used to saying, well, this is what I'm going to do. I'm going to get it all approved by the IRB. It's going to be in the protocol, and then we're just going to do it, and you're stuck with it. And I think the approach that we have to move towards is something that says, okay, we're going to try this. We're going to give ourselves 100 options to try, and we're going to use the one that works best, and then really monitor how you're spending your money. And I think this is the way, at least for us, we've tried so far to really maximize sort of value for effort.
One of the reasons I'm particularly bullish on academic mHealth is because we have not done that, and our results are still pretty impressive. So I think that when we really get down to it and we start iterating in the way that we can, I think I heard Rob Califf say at one point that we need to rethink the common rule. Once we figure out some of those issues, then I think that I think the potential for what we can do is just going to be dramatic.
Great. You're next.
Andrew Kasarskas from the Icahn School of Medicine at Mount Sinai. This question is surrounding a little bit about adoption, and particularly for Dr. Gustafson, speaking about people in relative isolation in rural areas, but really to the whole panel. For a lot of software adoption, of course, having a community of users is very important. And I'm curious as to your thoughts as to how if you're going to try and do a representative sample of Americans with 1 million or more people, how you think about the importance of physical proximity to actually building a community of people who can actually engage in providing the data, working with whatever software is required for that, and what your thoughts on that particular thing would be, because it would seem to be important based on my experience with consumer software to date.
I guess for me, our experience has been that it's, especially if you're dealing with communication systems, discussion groups and things like that, there's almost an advantage of having people from a lot of different locations at once. For instance, we can put somebody who from the inner city of Milwaukee on the same discussion group as a farmer from Richland Center, two very different populations. And since they can't see each other and they don't know much about each other, their communication has some real positive aspects to it. So I guess I'm not as maybe worried as I should be about the distance thing. It doesn't seem to have been an issue for us. Maybe I misunderstand the question.
I think one of the lessons of, say, Facebook is that people need to have shared locations in mind, but you may not necessarily need access, physical proximity to that location in order to maximize an adoption effect. We see that in our work as well, where a lot of our actual intervention delivery is quite distal from the health center, but having the health center as a place of common physical sort of reference is very, very useful.
Great. Thank you. Anand?
First of all, Don, I think it's a great idea. We should all think about the answer to that question. We should just take that as an action item for everybody. But the one possible answer, sir, to your question is, if I think about us at WellDoc, we ask an enormous amount of information from our patients. We do. And yet we find that they give it to us. And we ask ourselves why. And the analogy for me is you have a dry sponge and a bucket of water. And I can take the bucket of water and dump it on the sponge, and the sponge will probably absorb some of it, but the water is going to spill. But if I take that same amount of water in the same sponge and just tailor the flow rate and position my water flow at different points in the sponge will probably absorb quite a bit. And so maybe there's a lesson for us that says, oftentimes in research studies, we try to get everything at once. It's what you said. Let me ask my 50 questions. When patients actually and people will quite happy to tell you things that are relevant at different points in this journey. And so maybe there's a part of this that says, it goes to where did Wendy go, but it's the design. We should really think about the design of these types of things, because we can actually get volumes of data, provided it's comfortable for them to give it to you at bit-sized chunks that make sense to them.
And I think I'd really like to add to that what we can find with the new technologies that we're using now, and there's a lot of work being done on this, not enough, but we're moving towards that, is what's a meaningful moment? What's the right moment to ask a question? Or when you're available, when you're interested, what's the right moment to deliver an intervention? I think finding those meaningful moments with new technologies is one of the most important endeavors that we can do right now.
Thank you. We have a speaker on the left. Please identify yourself.
Joan Broderick, USC. Picking up on that, I think one of the things that we're hearing is that when patients or participants feel listened to, it's a very valued experience. And so to the extent that our data collection triggers meaningful interaction, so Arthur Stone talked about burst design, so we're monitoring our participants and then something happens where we want to learn more intensively about them and then we contact them and try to engage them in a more detailed way. They realize that the data that we are collecting has meaning, that we are monitoring it, that we are taking note of significant experiences, and that then we want to learn more about them. And I think that's a very valued thing. And it doesn't require human engagement or telephone calls or community meetings, although I think those are valuable too.
Wonderful. Thank you. I'm going to wrap it up. I'm going to wrap it up with a good example, though. It's really, I think we're on the precipice of a wonderful opportunity, and the NIH is trying to get this right and making sure we solicit input from all facets of America. We've rolled this out on the East Coast, the middle of America, and now on the West Coast. It's important to make sure we have diversity and representation, and that makes good social justice sense. It's a good reason, but it's not enough. And what we want to make sure, at least my goal, is to make sure we have scientific integrity, and the inclusion of diverse populations is important because we learn a lot about the biology of disease. You'll be impressed to know that last year at this time, the Attorney General of Hawaii sued the company Bristol Myers Squibb for marketing a drug, a major blockbuster medication called Plavix, the heart medication, not knowing, but it didn't work in 55% of Asians because they didn't have the gene to metabolize the drug into its active form. So if you're Asian and went to the emergency room for a heart attack, it's 50% chance you would have gotten a placebo. If you're a Pacific Islander, it would have been 65%. To me, that example highlights not just the social reason why we want to have diversity, but the scientific reason. And by missing out the inclusion of diverse populations is about as naive as not including women in clinical trials, men and women, or children, for that case. Having said that, I've done my best to bring kids in. I brought my 17-year-old daughter here, who's a high school student. Her first response was, "You medical types are way behind the user interface." She's the one that did Girls Who Code and the one that told me that Siri didn't work for women. But I want to thank the panel. I want to thank the moderators and the audience, and particularly you for sitting here for the last 8 hours. I want to thank Intel for hosting this and Eric being our point person here. For tomorrow, please keep your identifications to get into Fort Knox here, and we will start here at 8 a.m. promptly tomorrow. Any other announcements that I suggest?
Yeah, let me add one thing. So tomorrow morning when you come in, you will not have to go through the main lobby. The bus will let you out, and you can come through a private entrance where we won't have the adventures of getting into the building that you did this morning. So bring your badge, and you'll see signs to that private entrance. It's just to the right of the main entrance where you came in this morning.
And the audience, if you're coming back tomorrow, really, we want the nuts and bolts. We're ready to start writing, and we want to make recommendations. We want your input. Thank you.